Good morning, everybody. Welcome to the Platone Final Conference. I welcome all participants here in the room. Thanks for having me and us, and also everybody online. I hope you can see and hear us clearly. And before I start with the agenda, what you can expect today and what we will see today, I would like to send out the thanks to EDSO for having us here, for sharing this beautiful room, and for inviting us to Brussels. So thank you very much for that. I'll be your main host and guide throughout the session today. My name is Andreas Kurusa from Baum Consult, and I'll be also guiding you through the day and taking your Q&A session questions. That means the online audience, as far as I'm informed, has the QR code already on the screen. For you here in the room, you will be shown shortly a QR code here on the big screen, and then you can just scan it with your phone, and you can also type it in, or you raise your hand. I also have a microphone over there, then I'll bring you the microphone later, so you will be heard if you have questions. There is no problem. A few more house rules to introduce before we start. So you have always the option to send a Q&A question. I will do my best to address them. I cannot promise that we will be addressing all of them because we have a little bit of a time constraint because we have a lot to do today. And I will be here on stage especially between the sessions. So there are three reasons why I come on stage. A, to be the moderator between the sessions, introduce some of the speakers. B, you are having a pitch and you are running out of time, so I'm coming here, so you know you should wrap it up. Or C, you are having a session or moderating a session and there is a question from the virtual audience. I might come up here and just bring it to your session. So whenever I come up, there might be a reason why I'm here. So just for your information. What are the objectives? What are the goals today for our conference? Well, we want to look at our impact on the challenges of the energy transition with the focus on digitalization of DSOs especially. But we also want to look at the key results that we have accomplished and how we approached it and how we exploited them in general. So these are the big topics that we want to address today. We will have a big variety of formats that we will be addressing. We will have keynotes, we'll have panel discussions, we have short pitches, as I mentioned before, interviews, also recorded sessions, and there will be some polling, so you also need the Slido QR code throughout the session. It will always going to be the same code, so if you scan it, you can just keep this tab open on your phone or on your computer, and it's going to be changing regarding where we are in the session. So just keep that open. Maybe that's the best thing to do. Another remark, we have a showcase area in the back of this room, or the other room, better said. Unfortunately, virtual participants cannot see that. It's just more a physical participation thing, but we'll be showing some videos, basically describing a little bit what we have done there. In the lunch break, I will tell you a little bit more about that when it's time. And other than that, before I introduce the first speaker and the first little keynote, I also wanted to give you a little small take from my side before we start. And for this, I have found a good quote from Plato, which I think is pretty nice in this context. And it says, "Knowledge which stops at what it does not know is the highest knowledge." So what does it mean? Well, for me, it meant it underscores the importance of continuous learning and exploration. This is what we also do here. And it suggests that true knowledge goes beyond the limitation of existing understanding and embraces the pursuit of new insights and advancements. And because I'm fairly new to the project, I just joined about a year ago, I have experienced that in a way that there's so many interesting things that have been developed and so many great people working on it that I said, well, this is a lot of knowledge conglomerated in one project and so many interesting results. We have to look at them and we have to keep working on them. So I'm real keen and glad that I'm here today with you, and we're going to be looking at these things together. And this brings me to our first speaker, who's going to be joining us online. His name is Luis Cunha, and let me just give you 2-3 words about him before we try to hand him the word online. He is the Director of European Policies and Projects of EU-REDIS, the Portuguese DSO. He's responsible for the coordination of European activities and funded projects, and he's a board member of the EU DSO entity, Vice Chair ETIPSNet, and active member since the foundation of EDSO. So many things there. The first keynote, he will address challenges and risks, but also needs faced by DSOs in today's times. but also bringing the perspective at IPSnet to the table. So I hope, Mr. Cunha, you are online, you can hear us, and the stage is yours. Yes. I hope it's going to work out.
Good morning. Can you hear me? I hope so. Okay, so I will assume that you can hear me. So good morning, everyone. And first of all, let me apologize for not being with you. Unfortunately, I'm in another place in Europe right now, but still very keen to have this exchange with you. A first word goes directly to the Platone project and to my colleagues and friends there. I think it's a day to celebrate the achievements of the project. It's for sure a great project, one of the key projects when it comes to flexibility right now at European level. So I'm very glad to be here. Although we are not part, I mean, ERITS, as members of this project, we are also very keen to cooperate, and we have been cooperating with this project across these 4 years of existence. So thank you very much for the invitation, and congratulations to the coordinator, Antonello, and to all the members of the project and to all the team. So going directly to the topic of my presentation. So I was challenged a little bit to talk what are the challenges that DSOs will be facing or are already facing in order to prepare the future. And I tried only to compile here a few figures that will help us understanding the problem that we need to face in some years and are already now facing. So if you don't mind to go to the next slide, please. Okay, thank you very much. So I will start with something that is not new, but I think it's important to summarize in a very short note like this one. So one of the big challenges that we have been overcoming during the recent years is firstly the integration of renewables. And we have indeed an important target at European level. And we know by experience that this impacts a lot the way we operate our system. And we see that this is a trend that is still in the middle of the process. So we have been through the process of integrating mostly windmills and wind farms. And right now we are in a process of extending this also to the solar PV generation. This does not go without saying that we are also adding to this the participation of consumers through their own PV panels, being it on the rooftop of their houses or the buildings, or even with the energy communities. So overall, if we see what is going on currently with the current regulatory framework and the legislative packages at European level, we see that what we did so far, integrating renewables, is still a very short thing compared to what we need to do in the coming years. So this is probably one of the first challenges that we need to keep addressing. And for those like me that work for a distribution company or even for a transmission company, we know very well that one of the problems today, I mean, in operational terms, is exactly how to have enough capacity in the system to accommodate all this infeed of energy that is flowing to our networks. If you don't mind to go to the second one, please. Second slide. Okay, so having talked about the generation side, I think it's also important to understand what is going to happen on the other side, on consumption side. And on this side, what we see is that the Commission has a very important goal. It has been there for the last almost 10 years, which is efficiency first. And it's very well stated in the different legislative packages. But despite this goal of the reduction of energy consumption, there is indeed one need, and that need is to electrify society in order to achieve this overall reduction in the energy consumption. So we should expect the demand for electricity to keep growing also in the coming years. So the figures are around 2% per year. This is what is estimated according to some studies out there, and we have the reference also in the presentation that you can check later on. At the same time, we all know that we are going to face, and we are already facing, an important penetration of electric mobility. And this is not the fact that we will have these devices moving from one side to the other, but also the fact that they will rely on infrastructures that most of them are not yet there. And it's very easy to imagine what will happen when a lot of neighbors want to charge their electric vehicles at the same period of the day, and the consequences that this might have for the operation of the system. Namely, when we need to have this trade-off and this balance between the generation being it local or centralized, and this consumption that are mostly happening at local level. And here again, the number of initiatives that are being led by the Commission are pointing towards a much more challenging situation. And this does not go only with the electric vehicles, but also with estimated number of heat pumps and other kind of devices that we will use in this electrification process. So to summarize so far, we need to keep up with the integration of renewables, and we will see much more pressure on the local dimension, namely with electrification of of society, or most of society activities. If you don't mind to go to the next slide, please. But of course, there is also the good news on this. And the good news is exactly flexibility. And I think flexibility is the center topic of this discussion today. Of course, it's Platone, but Platone is a project that is mostly dealing with these new challenges for DSOs and also for TSOs of incorporating flexibility in their activities and making this a tool to overcome part of the challenges that we need to face. And there are already some figures out there. None of these figures are coming from myself or from the entity that I work for, or even from the associations where I also take part. These are coming from the International Energy Agency, from SmartN, the association that represents aggregators at the European level, and also a study from the European University Institute connected to the Florence School of Regulation. And the good news here is that there is enough flexibility out there, at least estimated flexibility, that can be used to overcome some of the problems that we will face in the future. And this will also have a positive effect on the citizen side. I mean, they will benefit from that. Distribution system operators as well as transmission system operators most probably will also benefit from that. We will reduce the need for investment in traditional copper. But there is always a but on this thing, and it's important when we discuss this type of topics that we try to identify also the buts. The but is there is an optimal level between this trade-off of investing in the grids and making using of flexibility, and this has to do with social welfare. So we need to keep into consideration that the system that we run is a system that delivers electricity to everyone. And when we think about the benefits of flexibility, we cannot make it a benefit for only a certain part of society or only for a few number of people. This should be something that would benefit society as a whole. And according to a study developed by the European University Institute, of course, that needs further detail, and it's something that probably we need to have a new project on that just to understand. This is not a panacea to solve all the issues. So flexibility is a very, very critical topic, a very important topic, but we need to find the right balance between flexibility and all the other activities that we also need to run in order to solve this complex equation that is running the system in the energy transition. If you don't mind to go to the next slide, please. And now I would like to introduce a little bit another very important topic that could also help us solving the problem. This is from a different angle, I would say. Flexibility is really a solution. Digitalization is not a solution by itself. It's a means to achieve what we want to achieve, but still a very important one. And here I would like to share with you that we DSOs have been working together with the European Commission and with the TSOs at different levels to work in a structured way, the way that we are going to digitalize our networks from end to end. I mean, also addressing the low voltage networks. And so far, we have identified these 5 main topics, which is topics or areas, if we can see it in the broader sense, which is to improve supervision of the network, so increase capacity to observe and control everything that is going on in the network and in the connection of the network with the edge and with renewables. We also need to rethink the way we plan our activities. And please take note that flexibility and the work that Platone has done on this is also very crucial in order to understand the impact of flexibility and how can we use it in the different phases of our processes. The third one is to find new ways to operate in a more resilient and cyber physical secure way our grids, bringing flexibility on board. And this is also about and mostly about participation of consumers and the industry in the processes. And finally, improving all this data exchange between the different parties. And let me just also share with you a particular concern that I have relating to this. I think that data exchange is a cornerstone for all these activities that we need to develop in the coming years. And we should think it in a broader sense, and we should not see data exchange in a silo of the energy sector. Data exchange is something that we really need to understand, because from the moment we start electrifying society, we as citizens will start to mix our normal consumption activities with other daily tasks that we have in our lives. That means that the data that we use from the electricity sector is no longer enough to solve the problems that we need to face. So data exchange between data spaces from different sectors and different activities will probably be also one of the key issues that we will need to face very shortly. If you don't mind to go now to the next one, please. So just to give you a sort of conclusion on this trade-off or balancing between what we need to do. These figures that I present to you are mostly coming from two sides. One is the European Commission, other one is a study that was done in 2021, still not up to date so far, but it's important just to have an order of magnitude of what we need to do. And basically what we say is that we need to invest more or less 600 billion euros in the system. 2/3 of that value should go in more or less to improve the distribution grids, and 1/3 of that value will go to digitalize the system. And all these figures already have into consideration the positive impact or positive effect of flexibility. So I think this is one of the key messages of my intervention today, is that there is a huge, very relevant place for flexibility. We are more than obliged to incorporate flexibility in our activities, because it's going to bring consumers on board, it's going to facilitate the energy transition, it's going to a certain extent to put some informal rules in the way we operate the system and interact with the users of the system. But this is not going to solve everything. So we need to think at different levels when we try to address the problem. If you don't mind to go now to the next one, please. Okay, let me just share with you a brief note on what we do at European level, in this case DSOs, in order to cope with all these challenges. And I just bring you some food for thought. And please, if you don't follow, please follow also the website of EDSO. EDSO is an association that gathers the major DSOs across Europe. And we have been doing during the last 13, 14 years an excellent work in trying to advocate for the needs that the system has. And this is going on policy level, on project level, on technology level, and also producing a lot of events. And on the projects level, I think it's really important for this discussion here, because EDSO is a member also of this project, also is a member of other projects, and EDSO is also doing an excellent job when it comes to connecting all these activities from the different projects. So thank you very much for that, and for those that are not following closely what EDSO is doing, please keep in touch. EDSO is right now putting a lot of effort also in cooperating with other stakeholders in order to make this transition very much more easy to overcome. If you go to the next slide, please. The next one, if you don't mind. Okay, Okay, so we jump to the technology rather, just for you to know that we are working now on a lot of technologies, and we most probably need to cooperate with your project and other projects so that we can identify the real issues. A final word that I have for today is on ETIPSnet activities. So currently, I'm working as acting as vice chair of ETIPSnet. I found out that ETIPSnet is really a good platform to improve cooperation when it comes to bring smart networks to reality. And we are doing this by having a long-term vision, a mid-term vision, and a short-term vision. And this is very important because we know that there are trends that are goals for 2050, are goals for 2030, but there are also the need to implement. And one of the key words that we have today is exactly implementation. So we need to find a way to accelerate implementation. And this is where Platone comes in. This is where the projects can bring real solutions to the industry side. And what ETIPSnet does is exactly to collect the industry view and try to accelerate this process. So if you don't have yet time to read some of the papers, you will find that we have roadmaps with a long-term vision. We have implementation plans. And we are also working on another base by request of the European Commission to produce some key insights, giving the industry view on certain topics that are crucial. And so far, we are working on two different subjects. One is regulatory sandboxes. We have already presented something that was very well accepted and received by the Commission. And currently, ETIPSnet is also working on a very important topic, which is energy data spaces. And you can see also on the right side of the slide that there are a lot of high-level use cases that more or less cover all the issues that we need to address at the smart grid level, and that are listed there just for your information. So I would go for my final slide now, if you don't mind. Okay, so just to sum up. So to make it simple as possible. So as I told you, in my view, I think we have four main challenges. One is to keep up with integration of renewables. Another one is to find a cost-effective way to electrify society. There is a third one, which is resilience. Resilience is becoming even more important with climate change, with some critical situations that we are facing in our systems. And this also encompasses modernization. We are running a system that has a lot of assets, mostly of them with more than 40 years of operation. And finally, we need to do it in an efficient way, because in the end, it is society that will need to have a cost-efficient system in operation. In order to do that, we also have to do something beforehand, which is digitalize everything that we do. And for that, we need to concentrate on 5 key main areas: planning, flexibility, supervision, operation, and data exchange. There is also an important topic that we are working now, which is the digital twin and the smart grid indicators. And both of them are very well connected. There is a work going on at the associations level and also with Commission to identify what are the main areas that we need to work on digital twins, and how to push for smart grid indicators in order to drive investments, to identify where we need to invest, and to measure the results of those investments. And finally, I think it was also clear from my message, and probably the most important one, there should be a right balance between the need to invest on grids, the need to digitalize, and the need to use flexibility. And I think now with projects like Platone, we are closer to solving this equation. We are not there yet, I must say, in my view, but I think we are getting closer. And I need to thank you again for all the work that you have been doing, and congratulations once again. Thank you very much.
Thank you very much, Mr. Cunha. So we heard a lot about challenges in the presentation, but we did also hear about good news. And for me and for us, I think good news is how our work and our project responded to some of the shown challenges regarding digitalization, but also flexibilization, and in particular also the Platone framework. And the next speaker, Antonello Monti, who is here today, will be presenting this in a short presentation. He received his PhD in electric engineering, He started his career in the industry and went back to academia. I guess this was your call. And now, since 2008, he's professor at RWTH Aachen University, where he's the director of the Institute for Automation and Complex Power Systems. And since 2009, he's also a joint appointment of the Fraunhofer FIT Center for Digital Energy. Antonello, the floor is yours. Have fun.
Thank you. Good morning. Can you hear me okay? Okay. I'm looking for my slide, sorry. Okay, here we go. So it's a great pleasure to be here today as coordinator of Platone to present what we have been done in the last 4 years. I call it a bittersweet moment because we are happy with what we achieved. It's anyway sad every time we are at the end of a project. We built a community, a group working together, work very well together. And so, but we'll have more opportunities work together. We are already project that will continue this cooperation. So my presentation will cover 2 aspects. First, for those of you who are not that familiar, I have a few slides saying what we promised at the beginning, and then a few slides on what we achieved. And my message is we achieved much more than what we thought. And that's one of the most relevant aspects of this project. We thought we had ambition and goals that were very high level and everything, but it turned out a lot of coincidence around the project, very positive confluence of things that made this project a center of very relevant activities for which we all are very proud. And I want to thank all the partners because every partner has a very strong commitment in this project. Everything worked together beautifully. I think it was an extremely smooth experience for me as coordinator. I didn't have to worry much because everything was working great. So that's what we had at the beginning. And first of all, apart from our partners, you can see here, we had set 5 key elements of the solution. Here already, the project goes beyond what the Commission was asking. The Commission focused the call on flexibility, as we heard. But we realized that the key element that we want to achieve was to center flexibility as a major asset in the transformation of DSOs. So we built the project really around the distribution system operator, their needs, and then facilitating this transformation with a clear path towards digitalization. And in doing this, we realized that the other key element, as we heard also from the numbers that Luis showed, is the involvement of customers. So we had to close this link between DSOs and customers, create the right condition for them to work together. That's the way to achieve flexibility, and the digitalization is the key element to make it possible. So we want to unlock flexibility. This was, fitting the requirements of the call. We want to improve grid operation. We heard from Luis, observability is one of the top goals of DSOs of today. Customer engagement, we want to make it flexible and possible, but at the same time, we are part of a big system, so we cannot forget the TSOs. We didn't have TSOs in the project, but we had to build a solution that linked DSOs to the TSO. And at the end, the overarching goal is to make the power supply reliable, so improving overall the operation of the grid. The key element was our architecture that brings to the so-called Platone framework that is here summarizing this 2-level architecture. We had identified an access layer that in several of the tests we did was based on a blockchain solution, and we actually had 2 different implementations. That's another point. The solution we offer is flexible, open, and composable so that you can rearrange some of the building blocks. And then we had at a higher layer these 2 key other parts, the DSO technical platform, that is one of the major deliverables of this project, and the link to the market platform. And link it to market platform in an agnostic way, so that yes, we have a market platform, but we also have links that can go beyond a specific implementation. And this is key because then if you look building around the DSO, the view of the project, as in this slide, you see that we incorporate what we call legacy systems, so the standard IT architecture for grid operation, but we enrich those, we open them up to innovation with the DSO technical platform. which is, in our view, an open architecture based on open source, and that brings to the link to a previous project, and I'm glad to have here with us Fiona Williams, who coordinated the Sogno project, which is, let's say, the father of Platone, if you like. The link to the customers with the blockchain interface and the link to the market platform. So the Sogno architecture was in the middle as a database, was the original idea. Key element of Platone are these three new interfaces that make the idea as a center around the interface for much more open and flexible solution. We didn't do just theory in Platone. We had the pleasure to have 3 relevant field tests, all very important and large, in 3 different countries. Here you see the major title, balancing between local and higher level network in Germany, Italy, cutting barriers, unlocking flexibility, and Greece, innovative flexibility service and advanced network observability. If you look deeper, what is nice about the demonstrations is that how they complement each other at the end and present a complete coverage of the challenges of the DSOs. So if I try to summarize the experience in Germany, I think the most relevant part there is the link between a local community, a small town, and the DSOs, and building win-win situation between grid operation and local communities. And that's possible thanks to, as mentioned here, decoupling LV and MV instantaneous power flow. So all this possibility of flexibility at the border, which is a benefit for the DSO, but also allows to build new use cases of cooperation with the local communities. We had the element in Rome, which is really focused on flexibility and customer engagement. And I will come back to the example of Rome, because when you talk about exploitation, is also a very relevant example. And I would say the part in Greece is vice versa, what brings much more the focus on grid operation. Things like state estimations and new algorithms, observability. And you see how they build these 3 together. You have all the elements. And we, in our university in RWTH, we had maintaining a reference implementation as an overall picture together. What we achieve, we have a long list of results. This is you will see through the day. We have this little flyer. Each one of them is, using the terminology of the Commission, a key exploitable result. They cover a variety of aspects. It's a long list. I couldn't make a slide. I just put them on the floor. Yesterday I took a picture because I couldn't summarize in one slide all the achievement we had. And you will have later, basically also during lunch, the opportunity to go through them. So we'll not spend time now to go through this list. I just want to send a message. It's a long list. It's about software. It's about hardware. It's about everything from measurement devices that have been expanded from the previous project, EdgeFlex. Again, thanks to Fiona sitting here, because it was a project she coordinated, and now we moved to another step forward. And to software like the DSO technical platform becoming a Linux Foundation project will be a topic of a session later, and all those variety of results. So very, very exciting list. But it's real exploitation. So what I like to bring here as a summary of the project, the experience in Rome, in which we started with the project demonstration and building the solution, testing how you can include customers in the operation in the first demo, and then moving to the current structure that is a large project of renovation the city is doing, all built around the ideas of Platone. So it's moving from a test to a city-level experiment, not experiment, product, basically, and really embracing the philosophy that we have been pushing, and we will discuss how that works also with the commercial solution, the open source and involvement on the Linux Foundation Energy and the Sogno platform, and then moving to a really visionary solution that Rome is bringing together, combining all the pieces in something really new, and I would say at this point, unique in Europe. And I think this is one of the major legacy that we give to the project, a real commercial activity that started and now running independently from the funding of the Commission. And in conclusion, also one last of our achievement, this was not at all in the grant agreement, but we had COVID in the middle, so we didn't travel. And so what do we do with that? We thought, okay, we all talk about digitalization, but it's a tough task for the people in the sector to learn how to do it. So because we learned so much in the project, we decided to build a full course, educational course on digitalization, using our platform, of course, as example, but with real practical instructions, starting from, let me say, the philosophy. So that's my presentation, just what is about digitalization, role in DSOs, and then get really practical with some of our software developers, explaining how you make it happen. And this will be freely available online. Is a legacy again of the project. This video will be available. Everybody can download our software, install it, run it, see how you can build your digital platform. And as an academic, of course, the fact that we have this extra deliverable and exploitation action makes me particularly proud of the results. And I want to thank everybody that accepted to do this extra work instead of trouble. And that was our exchange, taking the good side of the COVID pandemic. Yeah, with that, I stop here, and I hope I was on time. And now enjoy the discussion that will come and get into the details of what I just flew over now.
Thank you, Antonello. Thank you. So just a quick segue so you can start the panel discussion. Also, you've been very much on time, so we have even a little bit less spare minutes. So what I liked about what you said is how to make it happen. And I think that's a very big and important thing that we have to address also in this type of projects. And what you have also shown is that open source plays one of the key roles when developing these things. And I think open source as a topic will become more and more important in the future and is already very important because the European Commission is also pointing in this direction. And with this, I would like you to introduce to the next moderator. We will have a panel discussion. It's already here on the slide. And your moderator for this panel discussion is going to be Ludwig Haag from Baum. I think he doesn't need too much introduction, but I can say so much, he's my boss. So I'm very happy that he's here. And he's also the CEO of Baum. So maybe a small applause for Ludwig, and then you'll call up your people to your session. Have fun about open source.
Well, thank you, Andreas, for introducing me so nicely. Open source software or proprietary software? That's a question of mindset. Is it? Or is it a question of wisdom in innovation? Or is it at the end a great business model? We need to talk. I called some panelists on stage, and I hope that everybody made it. I see many people. Yeah, I see Mark Pape. Can you join me on stage, please? Mark is from Invelio, startup from Cologne, meanwhile involved with the E.ON Group. You are developing software for digital transformation of energy grids. Is that sort of true? Then you can have a seat, please. Next one I call is Maurizio Bigoloni. Obviously from Italy, but from a German company, can I say that? Siemens. He is in Siemens and he is the head of grid control software. And you will have an opportunity of 99 seconds soon to introduce how an Italian comes to work in a Siemens company and what you want to achieve in Europe. Have a seat, Maurizio. Last but not least, I called Pedro Marquez. Pedro, he should be online. Can we see him?
Here.
Ah, where is he?
Hello.
He is in
everyone.
Portugal. Pedro is a
Yeah.
colleague of Luis Cunha. He is working also at Irides. He leads a great project with a great name, Universal Project. They also work with distribution system operators, of course. and they are after the concept of universal market enabling interface, UMI. If this is correct, you can stay with us.
Okay.
Hi.
Thank you.
Last not least, when I was a young informatics student, long time ago, I grew up with Fortran and Unix. And towards the end of my studies, someone said, why don't we do something that everybody shares, everybody owns? Maybe couldn't we take this Unix to something else? And then some brave people said, yes, let's do it Linux. Sounds a bit like Unix, but it's open. Now I'm happy to have a person here after, is it 40 years? Anto, I need not introduce you as a person. You have been introduced already. But Anto also has a role in the Linux Foundation. He is a representative, and he is the chair of the Technical Activity Council at Linux and also reporting to the board. So, how far did you get with Linux?
Yeah, thank you. So, sorry, it's me, but with a different hat. I'm here representing the Linux Foundation Energy, and I should have a couple of slides if they could be on the screen as Linux Foundation. I just want to briefly introduce what Linux Foundation Energy is about and what it fits in the discussion we are having here. Could I have the slides on the screen, please? Yeah. So, like I say, right now I'm not professor at WTH, sees me as Linux Foundation Energy representative and actually chair of the Technical Activity Council. The Technical Activity Council is the group that overlooks all the projects within the Linux Foundation and directly report to the board. So I'm the person reporting to the board what are the technical activities. And I want to do just a couple of slides about what the foundation is about, but also why and how the open source makes sense. And just to start a very important point for the discussion, it's already there. So we are now talking about something that will happen. That you know it or not, the majority of the software you are using is based on open source. The question is only what percentage, and the percentage changes with the sectors up to the cloud services, which are in the 90% open source, to other sectors where the penetration is lower. But every sector recognizes how critical and beneficial is to incorporate open source component in the system. But going to what will be a key topic of the discussion, there is also here, there is custom code. So it's not about one or the other, but it's about building synergies in communities where we share what it makes sense to share, because that's the best way to go together and to accelerate the transition. And that's the key point. And the other important point is to clarify when we talk about open source, what is open source when we come to the Linux Foundation. So there is a huge number of open source projects. If you browse around this immense number, there is a part that has value. And the key part of a foundation is to identify those projects and to build ecosystems around them. Because it makes sense if you have governance and if you have communities around. So this is Linux Foundation Energy members. We have 3 levels, the strategic members, the general members, and the associate. Those numbers are old. We celebrated 70 members just a couple of weeks ago. It's growing like crazy, which is a great result. And we have a lot of key partners. Some are sitting here, which are partners are not represented, like Areti was not in this version of the slides. I apologize. And this is, a great success story. The foundation more than doubled the budget in 1 year because everything is, people are buying into the picture. And we have a clear constellation of projects. And those projects are community with rules and very strict rules on software management. And I can tell you the TAC, this is the group I'm chairing, kicks project out. I was there. If a project comes, it doesn't meet the requirements of quality, we just simply say, can you fix the problem? No. Then thank you. You are not part of the family. This is the philosophy. We're not talking about putting some software in GitHub. We are talking about serious community of software developers working together with rules. This is what LF Energy is about, and that's why it's important to have a governance. So we have the technical steering committee, which is then the one I'm chairing. There is a governing board, and also the communities, which is the real life of the foundation, and then marketing, because we need to bring people on board. So it's a very structural system, and there is a clear project life cycle. That's how project may survive or fall out, and we have constant review. We have rules on how projects should be managed, and you have to follow them if you want to stay and to walk through from incubation to a graduated, recognized LF Energy activity. And transparency, this is another point. We all work together, and that's what increased dramatically the quality of the software that we manage and make sure people can trust. And also LF Energy wants to be a label that people can trust. And this is another important aspect. And let me conclude, just want, in celebration of everything, to put some word for the person who made this possible. Shuli Goodman, she created everything. She made everything. I mean, she was living for the foundation. Unfortunately, we lost her at the end of 2022. And in the foundation, it's 6 months, we couldn't find yet a person that will take position. We are now close. We will have a new director, but has been a shock for the foundation because her dedication, her passion was unique. She was the one that brought me into this mindset, and I owe a lot to her, and just want to remember her, because if we are here talking about LF Energy, it was just because of her dedication. Thank you.
Thank you. Have a seat. Stay with us, please, Anto. Well, the big questions of open source is, does it do something? Obviously it does, otherwise the foundation wouldn't exist anymore. So does it bring some uptake for solutions? Is there a business case? Otherwise, at the end, it wouldn't survive for now 40 years, 30 years. And maybe there are other benefits by doing it the open source way. We have 3 panelists. I would ask one after the other, maybe starting with our online guest to make sure that we hear you. Pedro, 99 seconds. What is your position to open source? Why do you talk about it? How do you use it? And what is the benefit that you expect as ERIDES from it?
Okay, thank you very much, everyone. In 99 seconds, let's try. Our project is a sister project of Platone, and we've focused on something specific, which is having an interface between us, the DSOs, and the market, already existing market platforms and FSPs. So we didn't go for an intermediate platform. We tried to do it directly between us, and not waiting for a future standard that we don't know when it's going to be ready. So being urgent, this flexibility need of using the European need of us to use flexibility on our behalf, we thought that open source would be the way out to have it quick up and running. And that's what we did. So our project explains our position. We wanted to do it as fast as possible, as quickly as possible, to do it in the easy way, being easy for mainly the DSO, but also for the market platforms, but mainly for the DSO, because not all DSOs have big enough structure to have IT competence. And so that's what our aim was, to have something quick, up and running, able to promote and use flexibility the following day, and make it easier for everyone.
Thank you. That was close to 99 seconds and still very informative. Maurizio, Siemens. My eyes are bad. Have you been on the list of the Linux Foundation Energy?
Not yet.
Not yet. You will go after this session. But what is your position, your personal and Siemens position?
Yes. Do you hear me? Okay. Now, let's say Siemens does proprietary software, no? But I'm here to talk about open source. But it's not a contradiction. Actually, Siemens has a clear open source strategy. We even have an open source manifesto that is public available, where basically we state that the company encourage all the developers to look open source first, to see if there are a component available in the community before writing custom code. At the end, also in the slide, it's quite clear. All the software we do already contains a lot of components, library based on open source. So I think that is important to leverage on this. But also, we see open source not only as a reuse of components, but also as a culture. And the culture can be used in the community, but also for the internal projects. So we have an internal organization that also for the proprietary software use the open source best practice. So we have, for instance, a common repository, code.siemens.com, that is available to all developers in all the businesses, that basically is based on GitLab, and it uses all the common practices that are used in the open source community. So from the company point of view, we see these two aspects in parallel. No? We participate to the open source projects. We are a contributor of a lot of projects. And then we adopt the best practice also for our internal development. So this is our approach.
That's the direction. I think we can talk about two sides of a coin. It's not two different monetary systems, it's two sides of a coin, and we will talk about that. Mark, Envelio, are you open source or proprietary?
So we heavily use open source. So our platform, in the end, the heart of our platform was proprietary, because that's our business case. But if you open up our coding guidelines, one of the first things you'll find there is don't reinvent the wheel. So whenever we need to implement something new, let's say a management system for smart metadata, as we currently do, we would not start implementing it ourselves, but first see are there any other software solutions already existing. And there, for instance, we chose an open source project, which we based our platform on. And by doing so, we can benefit from the latest developments, and we can focus on bringing customer value in the end. So we don't need to, because we don't need to implement everything that we need in the end.
That's obviously a benefit. Don't reinvent the wheel. So this is wisdom in innovation. But when I was young and I needed software, I found a company and I bought it. Do you buy the open source software?
No, certainly we don't buy them. We try to contribute to them. For some of our packages, we also plan to open source them. But usually we just rather use them and also contribute in a way that we give feedback, or if we find bugs that we also can support in resolving them. And also we add our perspective to the project, so that we say, okay, we have certain needs which are not yet in that project. We can also communicate this, and also by doing this as a user, we can contribute to the open source project.
So it's more or less also a bit a question of, I don't know, collective action. Anto, is it even about democracy? You know, we have been discussing a lot about the name of this project. We started with Socrates and we ended up with Platone. Maybe we should talk about Aristoteles. I don't know, I don't want to bring this philosophy here, but at the end, what is the relation of democracy, participation, and open source? Can you comment on that?
I think one important part that we get with the open source is that all the stakeholders can work together. In that sense, you can call it democracy. And in what is particularly important at this stage, what we are living in the energy sector, is that in those communities, we solve interoperability before the problem comes. Mm-hmm. So in the old-fashioned way, people were working on closed silos on their solution, and then working in committee to build interoperability. Now what is the other way around? We work together on the foundations, we make them interoperable, and then we build on top the product that Siemens and so on can sell. So the face of the product is different, and that's how you say, I like Siemens product because there's this way to interact with the user. But we are sure that in the background, there is work which is shared and automatically interoperable. So the standard emerged from the community instead of coming from the work down. And that changed the speed of innovation a lot and allows innovation and interoperability to work together. And that's vital with the timeline we have in the energy transition.
We will talk a bit about the benefits for the development ecosystem, and we will, at the end, also talk a bit about the business scenarios of open source. But can we quickly give an example, maybe everybody, or at least some of you, good examples where it worked? I taking you, I mean, we together have been in the FiWare development, for example. Is FiWare, what is FiWare? Maybe you explain it, but is it a good example?
Well, I would say yes. FiWare is now the standard for smart city. In Germany, there is no alternative. And the foundation has been really successful. And there are hundreds of cities using the same API from FiWare. They're all commercial platform. Again, it's a very good, if you look at the partner, engineering is one sitting here. And they've been one of the promoters of this idea. FiWare was pioneering and it struggled at the beginning because it was really new way of working. And at the end of the FIPPP, there was difficult time to get arranged, organized. But then when the organization was solved, the community were created, it was a rebirth. And right now, as far as I know, is the standard for smart city.
To what degree is it open source?
The API are all open source. There is also a full version available of all the generic enablers as open source. There are also versions of the same software which are closed. And I think that's exactly the same philosophy we have here. It doesn't have to be all open source, but the key point is interoperability to me, and that's where it's key.
So it's not only that we talk about openness in the software as such in the modules, we are also talking about interfaces between modules.
Yes.
So we come to interoperability later.
Yes.
But Maurizio, can you give us a good example? I mean, you are saying it's two sides of a coin and that you consider to do it. Does there any good example come to your mind where your proprietary part and some open source jointly brought a good solution?
Let's say, no, we have several examples. Indeed, if you look to the Siemens projects that have been published on GitHub, you see some example of this, no, where part of our product have been released as open source projects, no, to allow this sometimes to allow the community to take a look and expand. So at the end, for instance, in our case, that we are also an hardware producer, so to be able to release some of the software platform that runs on our devices, to be able to be taken from the community and extended, this is also a business model, no? Because the intention here is clearly to spread the usage of the device and the knowledge of the software that runs on top of them. So I think this is one of the examples, and we have, let's say, a lot of projects that have been released with this model. I like also to underline one of the internal projects that is, in my opinion, a big success of the open source implementation. No? As I said, few years ago, in the different business unit, but even in the different teams, we had different solutions for the continuous development and continuous integration. No? With some open source solutions, some commercial solution, and at the end, there was a decision to harmonize, and this was a really global decision. So now we have thousands, I would say 20,000 developers connected to one GitLab implementation. And during this introduction, at the end, Siemens is now one of the major contributors of GitLab. Because, of course, we need to adapt, we need to change. At the end, we contribute. No? And I think this is a nice success story. and also allow us to save, I mean, to optimize and to save a lot of money for tools, different tools, maybe also hard to maintain with in each country or maybe even each business. I mean, I think about 10 years ago, each business has its own technological stack with the different choice of different components. No?
We come to business later. Maybe just collecting a bit of good examples that we can talk about. Pedro, is there a good example from your side or the people that stand behind you? Good example of open source or open source together with proprietary software? Ooh, yes.
Yes, I think we have a good example. As I said, we built this open source together with the market platforms, and so, but it was not a specific market platform interface. So the UMI was built around the experience each one of us had, mainly more the market platforms than ourselves, DSOs. But then we discussed everything to put it as simple as possible, as open and agnostic as possible. And so we wouldn't be locked to any, us DSOs wouldn't be locked to any specific market platform. And so while developing, we focused on that to make it open and independent of the specifics of its approach from the market platforms. That made us understand what were the issues, both from market platforms, FSPs, and DSOs. For instance, as I said before, we found out that it would be easy for smaller DSOs. For us, it's not that difficult, but for smaller DSOs who don't have enough IT skills, to make it simple, and so make it hosted. The interface, we decided to host it in the market platforms and not otherwhere, in another place. So by doing that, we relied on the IT competence of market platform engineers. And that's an answer for the smaller DSOs.
Thank you. Mark, last not least, I mean, you said it. You don't want to reinvent the wheel and you take what is there. Often it's said that open source community creates, how do they call it, a vibrant ecosystem of developers and contributors. I mean, do you just take the software from a shelf, or do you cooperate with the developers? So is it a community of these open source developers?
Yes, it certainly is. So I would like to show this at the example of one of our main programming languages we use, which is Python. And that's really easy to install new packages. So whenever you need something, you will just type a few lines in your console, and you can install software from wherever you want and directly start using it. And this, of course, attracts many users because it's really easy to build something from scratch really fast by just using existing software. And with that ecosystem of developers which come to this programming language, for instance, or to other projects as well, you will also have contributors.
Come on, when I was young, we were meeting over a beer in the beer gardens in Munich. How do you meet these developers? How does that work in practice?
Yeah, on these platforms like GitHub, for instance, where you can also do a merge request. So you would say, okay, I need this feature, I have a proposition for this. So you raise an issue, which is then basically a ticket, and then you describe the problem you want to solve. You have, you can propose an idea on how to solve this, and then a discussion on this will start. People can contribute, discuss, and in the end, one solution will be implemented.
Is that something you feel? I mean, you are working a lot with open source people in the university, at Fraunhofer probably, but also in Linux. Does it create this milieu of creativeness? Does it somehow unleash the potentials of the developers? Or can you prove that?
Yeah, well, I would say there are two things, and that will allow me also to bring another important example. So yes, when the project, there are two levels. One challenge is the project is there, you want to have a community, and that's where having structured things like a foundation makes the community work, because there are meetings that are called periodically. The people sit and talk. This is what we need. And then somebody say, oh, I have to do it anyway. I will do it and put it in the community. So, if, for example, I manage within the foundation the Sonia project. We have every month a meeting, and all the developers are invited to talk about their problems and see what can be done in the community. But that's for the existing. I would like to mention another experience we are just developing, which is called CRESIM. Again, we have to thank RTE, the transmission operator of France, who created the Linux Foundation Energy, now also this idea. And that's solving another problem, is how to start a new community. And what the CRESIM is doing is associating grid operator, in particular. We have, for the moment, mostly TSO, but we want to expand to DSOs. Sit together and say, this is a project we need. Everybody contribute, now also economically, because when you start, there is effort. We create pot, and we start project. And then the research institution deliver open source software for new software we didn't have before, because that's also a need. And they're focusing on particularly modern simulation aspects of the grid, the new things we need. And there you start up a community, but it's a community effort anyway. So this is a new model as well.
I get it, and I understand that it works nicely in academia. But does it also work in Siemens? I mean, you live off software. Software pays your salary. I mean, but first, how do you deal with these developers? You say that you communicate, you cooperate in Siemens with open source developer communities. How does that work in practice? Is that different mindsets in the software engineers in Siemens and the software engineers in this open source community? Can they talk to each other?
Yes, at the end, as I said before, now we try to adopt the same best practice and the same culture, no? And then, I mean, sometimes in literature they call this inner source, no? The fact that you use open source methodology and culture also for proprietary software. At the end, there is no difference now from the developer point of view, working, because the tools, the way of approaching, it would be the same. So if they work for proprietary software in the internal GitLab implementation, or they publish something and they take something on GitHub, at the end it's the same, no? It's the same. So because at the end we need in the same way to share also know-how and competence among the organization, no? And this can be done for an internal project of proprietary software, but can be done also in the community. So, and this is why there is this manifesto that encourages developers to use and to contribute. Of course, not contributing to any project, it has to be related to the business. No, but if I need a component or a library that will be a key for our product, why not contribute? So this is an investment, you know, on something that we reuse. So this is the concept.
It is said, I mean, this vibrant community, not reinventing the wheel, etc., it is said, or it's meant to speed up the processes, of course, yeah. But does that really work? I mean, I understand that if you have different mindset, different philosophies, different business approaches, this could also somehow give an extra burden on the development. Isn't that the case also?
Yeah, but it could happen, of course. But I think what happened is that those communities are built about software people already agreed to share, so they have no problem in that specific. So that's critical how you define the project. It's a very important aspect. What is the project covering? But if you look at the, what are those communities? If you look at the list on the Linux Foundation, they're all major software manufacturers. They're like Microsoft. Microsoft is one of the major advocates of open source. But they're famous for selling software, not for open source.
Mm-hmm. Pedro?
Yes?
Did I see your hand? Sorry. I mean,
No.
The question is still, I mean, you are responsible, your
Yeah.
company is responsible for supply of energy, grid operator. I mean, you have the choice to either join a community, people that jointly develop something that you may or may not be able to use, or you go to a shop and you just buy it You are said to be rich, you can buy it. You don't want to develop it, you don't need the community. It's not about democracy, it must work, and you have the money to pay for it. Why would you go open source?
Well, for early stages of my work in REDS and EDP, we always went for open solutions. So we don't want to be locked in with anyone. And so that proved to be the solution for the future. And that future is now. While we did the development, I saw the work between our technicians, the market platform technicians, both from end-side and nodes, and their approach was quite pragmatic. They wanted to have a solution as soon as possible, but they were open to make some assumptions open, really open, in order for both platforms to work. So that requires some discussion and openness to be available to give up some of their specific specifications, but it works, meaning it works, the interface works with both of them, and it will work with other market platforms for sure, because in the case of doubt, we left it open. And then this experience is very interesting, and as Anto said in the beginning, this way of developing open source is mandatory for a smooth following specific standardization, because we have already tested a lot of assumptions. We don't need to assume everything.
Okay, thank you. I'm watching here. Andreas, did we get a question from the audiences outside? I mean, I can also take questions from the audience here. Do we have an extra mic?
Just a second. Okay, should be okay. Right.
Thank you. Good morning, citizens. My name is Angelos Harlaftis, Epavos Advisors, who represent the EcoWaves movement, a pan-European and Mediterranean regional movement which is based in direct democracy in science and in ecology. It happens, and I'm involved in the open source community, the European open source community, not of the energy, because it's the first time, and I'm very happy I meet you, that I meet an open source community with the energy sector. We are very well organized. We are very good on the cybersecurity. The Germans mainly. We organize 1-2 times a year meetings, European meetings. And what we are trying as movement to encourage is to encourage another perspective of the open source communities, the European one, because the other perspective it's over the umbrella of the Linux organization, or let's say it another way, Red Hat. You are very welcome to exchange information so that we can assist your work.
You will be the next one on my panel, next time. But you point to something, and I'm asking you guys, we are coming a bit to the risks also. I mean, not everything is shining, also not in open source. The question is cybersecurity. If I know exactly what your source code is, when it's open, I can also try and get into it. Is there more risk when you do or you use open source? Or is it the other way around? Cybersecurity and open source?
It's, again, we have to talk about serious open source, not whatever developed by university put on GitLab. That's better from security because it's the multiple eyes principle. If there is only a couple of people in a company looking at the software, they will not find all the back doors. You see it with all the, how many emergent updates you get on your phone because something was found out, but after how many years? And having many people working on the same software makes it safer. And also, you know what you're installing. The majority of attacks are related to compiled software that you don't know you're installing. And that's one thing that in the US has been changed. The President of the United States made this law on the so-called SBOM, which is a sort of list of what you're installing, a formal management as a product, as you have a packet list. And it's hard not to include open source in that case to protect this list and be sure you know what you're installing. All the major attacks on grids, like the famous Ukraine attack, it was software installed. They were not entering. They create the backdoor and then they enter. And that's what open source is really strong about.
Would you agree on that, Maurizio?
Let's say yes, but I think that the first sentence was very important. No? He said about if you take serious open source and not any library on GitHub. And this is the risk, no? Because I think that one of the major risks that we have is exactly this one. We have hundreds of developers that can look around and take any libraries and put in your code. No? So I think that for a company that does software, this is a really important aspect. How to make sure that security or even license infringement is not caused by a developer that take a library, download it, put in the code, and you are not aware of it. No, this is an important aspect. No? For instance, we have a process that is called clearing process that has to be, so we have automatic tools that scan the code and they get all the libraries and they compare against a repository to check exactly this. No? The component, for instance, one important aspect is license. We have a bunch of different kind of open source licenses, and you have to make sure if you do commercial software that you can use that component. So this is, for instance, one of the aspects that you have to make sure. So we do this clearing process, and we find if the process find a component, the libraries that is not, let's say, allowed or is not been to say certified or validated, you are obliged to change it before releasing. So there are some aspects. So it's not so.
You as the supplier, you take the responsibility. But I'm asking Pedro. I mean, you are responsible for supplying people with electricity. How do you make sure that your systems work, cannot be infringed, are safe and secure in relation to open source?
You're right. We have that strict measures around. Our cyber team is always attentive on what's happening and how the result of the software that has been developed. But all of them have solutions. If you're not able, for instance, to control 100% the security of the software itself, you have to control the doors on your company. So there's always a solution, and I agree with Anto that it's better to do it with everyone available, because just like we do, for instance, in our projects, we test this open source software in different environments, different countries, different regulation measures, and so that makes it more robust. And of course, we rely upon the knowledge of the IT developers to make it safe.
What's your experience? I mean, you obviously in Velio, you create software and you sell it, and you live off it. And I guess you don't only give it to E.ON, but also to others. What do people tell you? How can you prove that your software is functioning and that the underlying and the used wheels that you didn't invent, that they run? How can you prove, or what is the process of proving that?
First of all, we also have many measures in place, which Maurizio also mentioned, like code scanners that scan the security of the code that we use, that we implement by ourselves. And on top of that, what we also do is before we use an external software or open source project, we also make very sure that we analyze it beforehand. So we just don't take anything from GitHub and just use it. But before that, we would check, has it a community? How big is it? Is there a roadmap? Is this whole project a professional project that we can really rely upon? And only if this is true and we come to this conclusion in the end, we will use it. And with that, we can also be confident and that our solution in the end is secure.
How is that in practice? I mean, the source is open. You can read the source. But typically, a Python source is not so easy to read. So it's big. I cannot read it anyway. But do you read the software, the sources, or do you just somehow test that it does what it says?
So I can't tell what everybody from us does, but usually we always test what it does. So that's like the baseline. That's something we never change. For some of the project, we might also look into the code base, but many things of this also like trusting into the community, that we know, okay, people have access to it and they can read it, and therefore it's open and we can trust also in the code base.
Yeah, the key point, there are tools, as you correctly say, there are tools for automatic scanning the software, checking the security and everything. So the Linux Foundation has a huge set of those tools, and they automatically go to the GitHub of the project, check and send you a report. And that's what I was telling you, it's job of the TAC, the group I'm chairing. The project comes to review, they have to show the evaluation from the software, and they may say, there are some criticality. You have 2 months to fix. And so that's where those communities are important. If they have governance and rules and they use tools, that's how the quality is achieved. But there are tools, that's the point.
Anto, as you're talking, I'm coming to many, many more questions. Can we extend it a bit here? You said it in the beginning. It's not only about the openness of the source code. It's also about the openness of the API, the interfaces. What is more important, that you have an open interface or the open source? You would say it's both, but...
I see the interface critical because, for example, I use my project, Sonia, as reference. It's a modular system. It allows them to say, for example, I have a service in the platform, could be state estimation. We have a version as an open source. It doesn't mean that every operator should use that. They can have maybe Siemens coming with a better full version. There's something, a feature. Then the interface is critical because you remove, let's say, the open source, they put the Siemens state estimation, and nobody realized the difference. And you fit in the overall architecture. And this is key, is how those things, those pieces work together, because that allows you to grow, to change, add services, remove services, substitute with new version proprietary from one company another, and create a bigger ecosystem of ecosystems that allow the overall picture.
But does that mean from a software architecture point of view? I mean, when we talk interface, you can say, okay, it's written in a standard or somewhere in a document, that's the interface. No, the interface is also software.
Software,
it's
yes.
More or less an interface is a translator between this world and that world. Okay, so the interface could be open source, so everybody knows what the interface, I call it translator, does exactly, and then you can rely on from the both sides that they can be combined. Is that how it works?
Yeah, I think this is a key point to build very flexible architecture that can grow. Because, I want to quote Andreas, they refer to the sentence of Plato that actually came from Socrates, that the best knowledge is to know your limit, and we know we don't know the future. That's the point. How the system is evolving at DSO level is still with a lot of question mark. So we don't have something we can freeze today, say this is what the DSO need, because it will change in 1 year, 2 years. And that's where this openness and interfaces is key, because we can change with time.
Before we come to close the session, question to you guys. We are talking a lot about interoperability in the energy system. What is the relation of interoperability discussion and open source discussion? I mean, we are now discussing a bit the interface discussion, but Pedro, Maurizio, would open source give you more chances for the interoperability?
Yes, at the end, the key is, in my view, the interoperability, openness, at the end are synonymous, no? And for us, nobody now can think to go to a customer, I mean, being a DSO or any other customer, and try to have a monolithic end-to-end solution that covers all the needs. No, this is maybe 15, 20 years ago that was maybe the case, but it's not anymore. So it's not that we can go. So also for us that we do proprietary software to be interoperable and open is the key. No? We have an end-to-end platform, we load the components, but we know that probably we are going to sell to a customer some component that will integrate in an overall architecture that maybe is based on different products or an open source, because the interoperability is not only between proprietary software and open source, but is of course between also different vendors. No? At the end, each customer will create its own ecosystem, and if you are not open and interoperable, most likely you will be out, no? Because you cannot go there and see everything or nothing. No? So you need to, and this is I think this is the strategy, and this is also, I think, good for the market, no? Because at the end, the customer will select the ecosystem that fits the needs.
If it's adaptable and pieces are exchangeable, and so
So from my point of view, the openness of the PA or the interface is absolutely the most important thing.
Pedro, a sentence from you: interoperability versus open source.
Yes, I think a good example would be another project, European project. It's called Interconnect. They don't work directly. They're focused on the customer side, and so their appliances interconnection with the FSPs. They work with a set of manufacturers, equipment manufacturer, white, so Bosch, Siemens, Mill, a lot of them, and so they're aiming it to the same. They're all together working, not locking to each specific brand application, but they're doing it together to make it interoperable between all of them, and so this is another example in a different level of the energy system, but again also important. And so I think that's the way to do it. We don't need more proprietary software. We need to leave it open, and then the market will decide.
Mark, when you take such a wheel, I mean, you have probably some indicators that let you decide which wheel you take. There are many wheels in GitHub. Is that a question? How interoperable is it? How does it fit to the standards, the data models that we have agreed upon, and so on? Is that a quality characterization question?
Yes, definitely. Solely from the point of which data formats are available, for instance, in terms of interoperability, it's really important for us that we can use it also for other formats or for other applications or algorithms. So when it's not open, we would need to implement something ourselves to make it open to have this adapter. So in the end, we would take something which is open source, but then not have the advantage of using it. So it would be a broken wheel. So that's really important. And second, also to me, would be sign of quality if a system is open and interoperable.
So it's a characteristic of open software also that it obeys to some common rules, standards, data representation, and so on. Anto, you see what I'm doing here. I'm leading into the next project, the internet project that you are doing together with us. But no, we are not doing that. We are coming to the end of the Platone. At the end of the Platone, and we would not sitting here when open source would not be a discussion in Platone. Can you summarize a bit again, maybe to what degree will it be open or not? Or is there still decisions to be made in Platone? What is open source, what is not open source at the end?
Well, for sure, many of the components of the DSO technical platform, particularly all the Sonio elements, are already open source. One of the two blockchain access layer from engineering, if I'm not wrong, is open source. And I think also there is the marketplace from engineering are open source. So you can build the full Platone implementation as an open source, but inside the project directly, the access layer, we have an alternative, which is not open source, that fits in the platform. So what we were saying of this composability, It's just already in the project available as options. And also in the technical platform, we have a combination. There are implementations which are full based on Sonio in Greece in combination with the Siemens solution in Rome. So you can mix and match what you prefer.
Okay, I know. You like the Lego. You like the Lego, I know. Okay, coming to an end. We have the opportunity to have 3 people that deal to this or that degree with open source or the 2 sides of the coin. Anto, shall we ask these people for a last advice to the Platone? Some decisions can be made. We can at least advertise what we do and did in Platone. Last sentences from our 3 panelists, some recommendations, some advice. We also take applause for Platone. Who wants to start? Our remote. Pedro.
Okay. I must congratulate you on the solution you had with this inclusion in the Linux system. At least it was the one that you chose, but the important thing is that you have some entity that's taking care of your babies, and that's very important because projects are limited in time, and so you've found out a solution to make your open source available and ready for future developments, at least for a short term. And so that's the main thing I would highlight.
Thank you. Mark, last advice for Platone.
So to be honest, when I came here for the panel discussion, I didn't know how much of the project is actually open source, so I'm positively surprised. And so congratulations, so good decision from my point of view. And with that also keep the project alive, keep it going, because that's what it meant for.
So that was an advice, we need to advertise it better.
I know if better, but I would say
more.
Continue, go on. Yes.
Maurizio.
I think that Platone sets a reference architecture, no? That it would be very important. It can be really a reference for DSO looking to the introduction of the flexibility in their how to say ecosystem, no? And I think this is, I would say, the fact that also then is related to the Linux Foundation project. I think that is something that continues. No? Sometimes the risk of the European project that you arrive to the end and then everything more or less stops. No? So here I think that the result is that for sure it will continue. There are other projects related, and that reference architecture can be really adopted by any DSO. Then you can pick, if you want all the components open source, if you want to mix up, as we said before, it's an ecosystem and the customer will decide.
Can you switch off the camera, please? I need to ask a last question to Maurizio. Can you switch off? Maurizio, will you join the Linux Foundation now?
We will for sure evaluate.
Thank you, Maurizio. Thank you, Mark. Thank you, Pedro. Thank you, of course, Anto as well. Thanks for joining us. Thanks for sharing your insights and your recommendations. I'm handing back to my valued Andreas.
Thank you very much, Ludwig and all the panelists, for this very insightful discussion. Maybe a small anecdote from my side also regarding this topic. I heard an input from a representative from LoRaWAN, if maybe some of you know this company, also open standard IoT. And I approached this representative and asked, okay, I heard that you created your business model strictly on open source. Why did you do this? And she said, well, we understand that software is never done, so it's an ongoing process that basically doesn't have an end, and we cannot employ as many programmers as you can find them out there who are willing to contribute. And if you want to do this, you just need to create a community and a platform where they can interact. So for me, it meant, okay, you can also approach it a little bit differently, engage, get them participated and motivated to do so, and maybe we'll find the crowd that is willing to work with you on these things. And I think it was also resembled in this discussion that there are possibilities to do so. But now I want to jump onto something else. And Antonello showed before, or he tried to show the big picture of all the things that were done in Platone. And he said it's very hard to draw one picture. and it's even harder to explain everything in one picture. So the next session will contain a lot of short pitches describing a lot of things that were developed in Platone. And we will hear 8 pitches. We'll try to keep it within 3 minutes. You have some leverage room, but if you see me coming up, then you know you should wrap it up. So just try to be more or less in this time frame. And the first pitch that we will hear is about the DSO technical platform from Anto. So if you are ready and I can call you up again, it hasn't been a while, then the floor is yours again, Anto.
Can I have this? Okay. It was mentioned several times in the previous discussion, the DSO technical platform is based on the Sonio platform concept that was developed in a previous EU project. It's a microservice architecture. This is one of the key innovations that makes the system modular and that allows to mix and match, as we were saying. The version that we have a version which is completely open source. We based on 2 different standards for data acquisition. MQTT was the original one, but now we have a version with Kafka. And this is exploited, if you like, because it's now a project in the Linux Foundation Energy, so there is a community which is growing. We have people that were not in Platone now contributing, and has been already adopted as a commercial solution. So yeah, you're welcome to come ask questions how you can be engaged and expand the experience of this technical platform. Thank you.
Thank you, Anto. That was faster than anticipated. So I see already that the remote control is handed over to Fernando Bosco, Senior Researcher in Solution Architect and Engineering. And you will have, in fact, 2 pitches, if I understand. So just do it sequentially. So I will just wait until you're done. Is that okay for you, Fernando? Yeah. Very good.
Thank you, Andreas. So good morning, everyone. I'm going to present 2 of the key results of the Platone project and 2 components that are part of the overall Platone Open Framework. So the first one is the Flexibility Market Platform. That is the components that enable the fair and transparent flexibility market in Platone for the DSO. The main characteristic of this Flexibility Market Platform is to involve any kind of market participants at the same time. So TSOs, DSOs, aggregators, and customer. And using blockchain technology for create this fair and transparent market. The main 3 features of this platform are to collect the flexibility request and offer from the market participants, calculate the results, so matching the flexibility request and offer for providing these results to the market participants, and then validate the flexibility services and provide a settlement mechanism for that. So this is the main description of the KR. You can find later more detail in the showcase area if you want. But we implement a completely open flexibility market that allows the creation of intraday and day-ahead market session. And we use blockchain technology for all the processes inside the platform. So we are able to certify the market results and also the requests and offer and to validate them. And we also implement, using blockchain technology, a settlement mechanism based on tokenization that incentivizes the customer engagement because you have an innovative mechanism to involve the customer in the flexibility. About result, I'm proud to say that the market platform was selected by Areti for 3 years experimentation for implementing a real local flexibility market in Italy. And I think it's a very good result for the market platform. So the second one, and continuing, is the blockchain access layer. As Anto said, we have different implementation of the blockchain access layer in Platone because we promised a reference architecture and is an open reference architecture. So we have 2 versions of the blockchain access layer. And we provide the open source version of the blockchain access layer. As you can see, of course, by the name is blockchain-based platform. And the main goal is to connect the physical infrastructure, so the network grid, to the other systems that are, let's say, need the data coming from the physical network. So we create a link between the physical infrastructure and the other system using blockchain technology for certifying the measurement, for identifying the data ownership and the data governance, and we share all the data to the other energy stakeholders using blockchain technology and a flexibility register. So essentially, it's an IoT-based platform. We use more standard for IoT integration, for connecting the physical infrastructure. And we use blockchain for data fingerprint, so for have a certification of the data and unique identification of the data ownership. So we are able also to improve the data governance and enable data access management for all the data that are shared to the flexibility register to all the other energy stakeholders that are interested to connecting the data. Because the data exchange, as we already see during the previous presentation, is crucial for the digitalization of the grid. And it's all from my side. Thank you.
Thank you, Fernando. Yeah. Maybe this one too. Next one will be, and we see it here already, Blockchain Access Layer 2 and the light node and the local fax market, as far as I understand it. Olivia Cicala, project engineer at Areti. Please join me on the stage. This is your remote, and this is your microphone. Have fun.
Good morning, everybody. I'll talk about local flexibility market, which is a multi-platform system which involves the distributed energy resources connected to the grid to provide flexibility services to the system operators. This system, this solution is based on a market approach and implements all the phases foreseen in ancillary services such as procurement, planning, forecasting, activation, and procurement. The TRL was at the beginning of the project 3, and now it's 7. And what's the added value of the system? First of all, market platform, which guarantees standard product, and secondly, we have a unique database which collects all flexibility data and measurements. Then we have a smart edge device which can enable customers to provide flexibility resources to the grid. And last but not least, blockchain to certify measurements and payments. The main barriers we encountered are the required to adopt the solution, to adopt technology, technical specification as APIs interfaces. And the target group of this system are aggregator, DSO, and TSO, and distributed energy resources owner, and flexibility service providers. And the implementation of this system required user actively contribute flexibility and benefit from this process. So that's all for local flexibility market. Thank you. Mattia now will tell you about light node.
So good, thank you. Okay, so the second part of the pitch will be presented by Mattia Alfieri, who is joining us online. So, Mattia, are you there? Can you hear us?
Yes, can you hear me?
Perfect, perfect.
Okay.
So the virtual floor is yours, and you will be presenting then the second part, so to say, of the Italian demo. Is that correct?
Yes, thank you.
Perfect.
So, good morning, everyone. And let's start from the light node. The light node is an edge device that is deployed on the end user's premises, and it acts as a contact point between the metering and the customer's activation system, or in general, the energy management system, to achieve flexibility. Furthermore, it is the access point, the contact point with the blockchain access layer, and I'll talk about that later, and through which the metering, the activation data can be exchanged with the rest of the platform. And the main added values of the light node are the device standardization, because standard protocols and APIs were used in the light node, and also it unlocks flexibility for all the small distributed energy resources. And before sending the data to the blockchain access layer, it certifies measurements and the flexibility requests. But the main barriers are related with the fact that the light node has to communicate with several vendors providing EMS and distributed energy resources. So several implementations are needed. The target groups for the light node are mainly aggregators, DSOs, and FSPs, but also distributed energy resources owners and device manufacturers. The light node, in the context of the project Platone, has been already used, provided, and installed on the end user premises, and it was heavily involved in the experimentation. And the TRL level went from 6 to 8. And next slide, please. So as I said, the light node communicates with the blockchain access layer, and the blockchain access layer is the component between the distributed energy resources and the local flexibility market. And it acts to increase the trustworthiness, the security level of the measurements and requests coming from the field. The layer receives messages from light nodes directly, and it verifies the signature and it certifies the data on blockchain. The measurement, the main added values of the blockchain access layer are the measurement verification and certification, also for the flexibility orders, and also the increased transparency, because thanks to the blockchain technology, everyone can verify that a certain measurement was declared. The main barriers related to the blockchain access layer are linked to the legal recognition of the smart contracts deployed on the blockchain, and the scalability linked to the fact that we have to certify huge amounts of data. The target groups for the blockchain access layer are DSOs and market operators, but also distributed energy resources owners and FSPs. And regarding the implementation in the market, the blockchain access layer has been tested thoroughly during the Platone project, but by Areti, but also the experimentation is being promoted by the resolution 352 of the Italian NRA. And so the TRL went from a starting level 1 to a level 3. And thank you.
Mattia, thank you very much. The next pitch will be from Benjamin Peters. He's a project manager at Avaconet, and he'll be introducing and talking about the German demo. Benjamin, please join me on the stage. This is your microphone and your remote control.
Thank you. Yes, welcome everyone and good morning. My name is Benjamin Peters, and today I'm showing you the key exploitable results of the German demonstrator. And what we have implemented in Platone is the energy management system that we name Avacon Local Flex Controller. It is like a small flexibility management control device for assets which are allocated in low voltage distribution grids. The development, or to focus a bit more on the motivation that we have in Germany, we are facing a large increase of small-scale generators and loads in low-voltage grids due to also some political discussions. But currently we are facing more and more households owning a rooftop photovoltaic system, which is operated in combination with battery storage system. And yeah, we would like to access these flexibility to enable some use cases that are a bit at the corner of the regulation, but we want to show that there are some use cases, technical applicable in the grid, which have benefits to the DSO, but also to the customer and the communities. So we have implemented a community in the low voltage grid. We have implemented the local flex controller, and we apply the use case virtual islanding. It's a use case in which we enable a community to improve the self-consumption of PV generated energy. We apply with this scheme a coordination scheme for the activation of flexibility, which is requested by DSO, TSO, markets, or aggregators. And we apply a bulk-based energy supply scheme in which we separate like demand-driven networks and generation-driven networks. We want to apply a bulk-based energy supply scheme in case a community shows energy higher than a demand higher than their generation, and you want to apply an export bulk energy scheme for communities which display more generation than actually consumption. For this purpose, we have implemented the energy management system, which is applying or enabling different services like monitoring services of generation, consumption, and the availability of flexibility. We have implemented forecasting features for the prediction of generation, consumption, the residual load and energy demand of a whole community. And we have applied with the help of the integration of the system into the DSOTP framework with services provided by RWTH Aachen to implement local balancing schemes on rule-based and schedule-based approaches. And we also were able to use battery storages in the grid with optimization features so that we can minimize load peaks in the grid. Meanwhile, we are enabling customers to increase their self-consumption.
Thank you, Benjamin. The next speaker will be Themis Xikis. I'm doing my best with the names today. I'm really trying hard. He's researcher at National Technical University at Athens, and he'll be talking about the Greek demo. Here's your microphone. The stage is yours.
Good morning, all. So, a few words about the state estimation tool. Some general words about state estimation power systems. It's a real-time data process which actually has as an input the grid model, the topology of the grid, and the measurement data. And its output is the estimated state of the network under study. The data may be conventional data, for example, from SCADA systems, or synchronized ones from PMUs. The basic methodologies, the well-established methodologies are maximum likelihood estimation methods. And the application of state estimation to distribution grids is a bit more complicated compared to the application of the method to the transmission systems due to the structural particularities of the distribution grids and the few actual measurements actually available for processing. So the state estimation tool comprises a distribution system state estimator. It is based on the WLS method, and it provides the most likely, which is the closest to reality, operating state of the network. The grid observability is ensured by means of pseudo measurements, which are produced by a load estimation training-based model, and it can process both conventional and synchronized data. Its application is on the Mesogia pilot site, which is owned by Hedno, and comprises two medium voltage radial feeders. The data set comprises of both actual measurements and pseudo measurements, since observability cannot be achieved by the actual data available. So this is the flow chart of the state estimation tool. As you can see, we have the core algorithm, which is in the dashed lines. And at the bottom of the flowchart is the algorithm for the production of pseudo-measurements. All modules are developed in MATLAB using features from the MATLAB toolbox. And the offline simulation showed reliable convergence properties for the solution algorithm and high accuracy asynchrophasor data are integrated into the algorithm. As regards its integration into the head node DSO-TP, we have two converters for the data, one for the grid model and one for the measurement data, which are both developed in Python. And the state estimation tool is executed in Octave environment. It's going to be installed at head node premises after the completion of final testing. This is an output example from the online operation of the state estimation tool. And the related innovations are it comprises the first implementation of real-world distribution system estimation by head node. It is the first installation and deployment of synchrophasor units, actually RWTH synchronized measurement units in Hellenic distribution grids. And the state estimation tool acts as a key enabler for harvesting flexibility, since it delivers estimates of power injection for all network buses. And this is the essential input for the network tariff model of the Greek demo, which is going to be presented in the sequel by Panos. So thank you from my side.
Thank you very much. And last but not least, Panagiotis Pediaditis will tell us about network tariffs. He's joining us virtually, so can you hear us? Are you there?
Yes, yes.
Perfect. So you're the last one. Have fun. Everybody been very generous with time, so you don't have to rush really. So just tell us what you have to tell us. The floor is yours.
Thank you. Thank you very much. I will share my screen. Please let me know if you can see my screen. No, you can't, right? Okay, now you can see my screen, right?
Yes, but not in presentation mode yet. Yeah, now it's working. Perfect.
Okay, okay, good. Let me just... Okay, that's better. Okay, hello, I'm Panos from NTUA. I'm a researcher at NTUA, and I'm going to talk about the tariff design tool we developed for Platone. So I'll first give you an overview of where we stand. This is an outline of the Greek demo solution, where we combine the state estimation tool with the tariff design model. And the diagram here tells you that, okay, you can make them cooperate, you can put them together one after the other, but you have to have a way to test and validate and measure the effectiveness of what you do. So this is what we developed, not only the combination of the two methods, but also a way to validate and quantify its efficiency. The basic idea here is that using the state estimation tool, one can have a combined method that can harvest flexibility and is ready to use tomorrow by a DSO with minimal upgrades in infrastructure. Yes. So first, I will talk about the tariff design model. This is the core of the algorithm, which is a stackable game, which we model with bi-level optimization. And as you can see, if you are a little bit familiar with this kind of models, the prosumer response is anticipated. So in practice, the DSO has a model to simulate, let's say, a consumer behavior and anticipate the response when designing the tariffs, which is one of the most important aspects. But also, the tariff attributes that we are all familiar with are retained. So in this case, revenue adequacy. There is simplicity in the tariffs because we are not talking about energy pricing. We're talking about use of network tariffs. So we have discrete tariff levels, and the model allows for all kinds of granularity combinations since it's a bi-level model. So the user can choose how much granularity there will be in the setup that they design. And here is the entire method, the entire framework we propose. So on the upper part, you have the DSO yearly, or maybe in shorter time periods, but here it's yearly, taking historical data, going through state estimation, getting all the injections from all buses, going through analytics, producing enough features for a good quality clustering, and then on the clustering of a few day types that represent the different situations in the network, design tariffs that are few, simple, and then take them and use them throughout the year. And then on each day, on daily operation, the tariff type is chosen based on forecasts. The users now know what tariff applies this day. They are prepared for this kind of tariff because they're familiar with it throughout the year. They react to this tariff, and then the DSO has to do any remedy actions that are necessary. And from that, we obtain representative costs of the operation to quantify how well the tariffs do. And this is a validation setup we built for Platone because we not only, as I said in the beginning, we also tested the whole thing and tried to measure its efficacy. So, okay, I talked about the design phase. What we do practically here to approach reality is that in order to test this, you have to know the full state, which is impossible in the current conditions. So what we have is that we take a situation where we know the full state, using artificial data, not artificial data, real data, but an artificial situation. We redact it to simulate what head-node knows right now. And then we apply state estimation, then data analytics and tariff design, as I described before, and then we get the tariffs. And then we do this kind of triple experiment where we compare the tariff effectiveness with the business as usual, which is flat tariffs, which does not motivate flexibility, and a theoretical optimal, which is in practice a centralized OPF where a godlike DSO will have perfect control and perfect knowledge over everything. So this is the maximum effectiveness you can get. And we try to find out where the method stands in between those two extremes. And this is where the method stands. So the entire case studies we did and the validation framework we built for the Greek demo shows us that, okay, assuming for a moment that we have knowledge of the perfect state, we can get with the tariff model 78.5% of the cost efficiency. So we get up to 78.5% of what the godlike centralized mode can do, the optimal mode. And then when we apply state estimation and we implement the tariffs using state estimation, we lose 12.7%. So you see, we go to 65.8 using the tariff patterns that we design. But an important detail is that all of the efficiency is lost during the daily phase. The efficiency is lost when the DSO is trying to do the remedy actions, which are not very precise in the daily operation, which tells us that the tariffs are indifferent of whether you use an estimated state or the true state, because the tariffs are designed on clusters, which is by nature an average of situations. They are not affected from the random error that the state estimation is having. So the tariffs are indifferent to this. The tariffs can be implemented tomorrow. They're just as effective with or without the estimated state. So this is a very important conclusion that we found. And yes, this is pretty much the tool we built. Thank you very much.
Panos, thank you very much. We do have two questions here, what I can see on the tablet, but you can also ask more questions. So I'll just read out the first one. It's about the market platform. So I think it addresses you, Ferdinando, but I'm not too sure. You'll find another microphone. Laia has it, and you come here, but it would be good to stand up and look into this direction either way. So the question is, are there any coordination or prioritization mechanisms implied by the market platform?
Yes, there is a prioritization due to the fact that the Platone project focuses on the DSO needs. So the prioritization in the market platform for Platone is based on the priorities and the needs of the DSO. But it's a simple mechanism that you can change and implementing whatever you want inside the market platform. So if you want to prioritize in a different way or you want to change the algorithm for the clearing, you are able to do it.
Thank you very much. In regards to the market platform, we have another question over there. Maybe just give, yeah, she'll do it. Thank you, Fernando. I think we can sit down for now. Only if it addresses you directly, then we will see. But I have another microphone here, don't worry.
For those who are using the blockchain technology, do you face any problems with the energy consumption with the layers you are using? First this, and secondary, do you find any kind of cybersecurity issues with the blockchain? Thank you.
I think it's also for me, I can answer, but also the other part that working in blockchain technology. In the Platone project, we use the private implementation of the Ethereum blockchain. So we don't have any kind of mining in the blockchain, so we don't have any kind of energy consumption because it's a testing environment. For the public installation of integration in the public blockchain, in engineering, we are working in different approaches. The first of all is to use different mechanisms for the consensus that not, let's say, apply the proof of work, allowing to have a less energy consumption, for example, proof of stake that is now implemented in Ethereum, but also using different layer of blockchain, for example, Polygon, that is a layer 2 blockchain that allow to have a more efficient and scalable blockchain, reducing the cost and also the energy consumption. So there are a lot of approaches that could be implemented, and the solution that we provided, it's open to be extended, this new solution. So this is our approach.
Thank you very much. More remarks to the platform over there? Yes? Maybe someone can help just distribute the microphone. And I think Fernando can just stay here.
Thank you. Well, I have a couple of questions. For the settlement, do you consider baselines methodology to compute the settlement and the flexibility delivered, and which one you use?
In Platone, the settlement, the baseline is provided by the BSP, and we use the same baseline at any level. So all the stakeholders involved in the Platone architecture use the same baseline, and we use the baseline provided by the BSP for validating the flexibility, calculating the difference between the baseline and the effective production or consumption of energy. And at the end of the settlement, we produce the token, because the settlement is based not an economic token, let's say economic settlement, but based on blockchain tokenization.
Can you also on the consensus mechanisms and the energy used also, were you able to compute that? Because depends on, as you may know, well, first the consensus mechanisms, because some are very energy intensive. And do you look into this?
Not in Platone, because as I said before, we use the private implementation without the mining, so without the consensus at, let's say, public level. So we didn't investigate in Platone. We have done in our laboratory in engineering, because as I said, we are working also for a more scalable solution using public blockchain. At the moment, the best solution from our point of view is to using layer 2 for ensuring scalability and reducing the cost and also the energy consumption. So I think this is the best way for approaching this kind of solution. But the evolution of the blockchain technology is changing a lot in this period, so probably we will have also other investigation on that.
Can I ask another?
we have time indeed, so we ask. We have another question, but maybe keep the topic for now hot, and then we'll change to something else. So
sure. Okay.
Feel free to ask.
By the way, I didn't introduce myself. I'm supposed to be part of the advisory board. I'm a research professor from Comillas University in Madrid. I'm all involved in other projects, so that's why. On the customer, were you able to measure like the customer experience or the FSP experience using the blockchain platform? Because somehow you said that it was an element that helped on the engagement. So how, if it's measured, I just because this is a challenge, I will say, to see the customer perspective. Just wondering.
Yeah, I can answer, but better, maybe this question could be better answered by Areti that followed also the customer engagement, and Asha Energy that followed the customer engagement. Because we have in the Italian demo, I don't know where is Acea, an application, a mobile application for the end customer that allow us to manage and monitoring all the services that are provided to them, and also to monitoring at any time the flexibility offer and also the token achieved and so on. So they are really involved in the flexibility provisioning, even if they are part of the BSP or the aggregator for participating into the market. I don't know if Acea would like to add something. I don't see
Maybe it comes later with the presentations. I don't know if
Everyone feels eligible to give an answer?
Yep, it's about the customer engagement and how the feeling with the BSP and the customer inside the Italian demo. So maybe you can answer to, or if you want to repeat again the question, Jose Pablo.
Yeah, my question was if you were able to measure the customer engagement using the blockchain and how the customer feedback on their experience.
On the blockchain?
Yeah, on the platform, the market platform.
I think we have a panel after where we speak about the customer engagement.
Perfect. So I think we can leave it and wait for the panel if you want.
Yeah, if you want some feedback about the blockchain, they are not too aware about the technical issues of the project because it's a level more, a lower level of knowledge. But after we can. Okay, thank you.
All right. Then more questions?
No, for the I have just one for the tariff. If you allow me, if it's
there is time, please.
Panos, I don't know if he's still in.
Panos, are you still with us, or have you closed your laptop and left?
Hello, can you hear me? Okay, you can.
Maybe you can hold it for later. We have a few more questions. If he shows up, then address him. Otherwise, I think we can connect you to another channel. We have another question. I think it's for you, Benjamin. It says, can the ALFC already be used under the current legislative framework in Germany? And is it intended to use it beyond the Platone project?
Okay, yeah, that's a very interesting question. So, yeah, the use cases that we have applied in the field, they are not in line with the current regulation because what we wanted to investigate is the grid positive effect of battery control in communities. However, due to the open interfaces that the ALFC provides, it could be integrated into future control schemes. So, but there in Germany, we still waiting for the large rollout of the smart meter and the smart meter framework for measurement and control. The interfaces that this framework is providing are currently in implementation. And yeah, well, if there will be a possibility, then we probably will also check whether we then can integrate it in such a scheme, or if we need to build up like a new system which at least uses some algorithms that we have implemented in this energy management system.
Okay, I hope that this answers the question. Maybe now we see Panos on the screen. If the microphone finds the way to you, thank you, Benjamin. I'll just take this from you.
Okay.
Then you can direct your question again to Panos.
Okay.
Can you hear us, Panos?
I can hear you. Can you hear me?
No, we can hear very far away.
That's impossible. Yeah, I don't know what's happening. Possible that you change the sound settings?
Now it's better. Now it's better. Now it's all good.
Okay.
So
I was here. You couldn't hear me before.
Okay, thank you.
Yes.
Sorry, Panos.
Yeah.
Just, well, this is a topic I do research, so I just wondering if in the methodology, first in the methodology of the tariff design, if it's based only on operational cost, or you consider long-term investment costs or long-term marginal cost for implementing the tariff? Sorry, I couldn't get from your presentation.
Yeah.
And also...
The one...
Go ahead.
Yes. Oh, please continue.
No, the other question is because you implement both in the tariffs and also the market, if you have looked at the interaction between these two, or in the Greek demo only you use the tariff and then in the, for instance, in the Italian demo you look for the market solution?
Okay, to answer the first question, yes, it's not part of this setup I showed, but yes, we have done the investment problem, and it's going to be published. Going to be within the summer. So you're going to see this version too. With regards to the market, I have done an experiment. Let's say I sent it last year. There's another publication with the market, but not an energy market. Because it does the setup with the capacity market, capacity limitation market to be precise, because it doesn't fit well with energy markets if you have granularity in the tariffs. Does it make sense what I say? Yeah, I cannot hear.
Okay, now I imagine you can hear me. I was wondering, not with the wholesale market, but more from the flexibility markets that are, I think, to solve congestion at distribution level, and as tariff are also intended to provide incentive for distribution flexibility. These two tools, they in practice they interact. I'm wondering if you have looked at this interaction also, because I'm doing this kind of research. Thank you.
Yes, with the setup I showed and the granular tariff that is relying on machine learning to get the patterns, let's say, it would be a very interesting question to see with the real flexibility market, which is, let's say, an energy market, flexibility market. Because then you will have to capture the market dynamics in the clustering step, which is very interesting as a research question. We can discuss further if you like on this topic. I'm not going to this direction, to be honest, right now. I have done only part of the work on different kind of markets, not flexibility, but capacity limitation markets, which do not interact on the same time granularity as the network tariff that I showed.
Okay, thank you very much.
Yeah.
Thank you.
Welcome.
That calls definitely for direct call between you guys. We have two more questions as far as I can tell. One is very short, but maybe not less interesting, from Hans Blutzweit. He asked, how much does the light node device cost? Who can give an answer to that? Or is there an answer? Light node, the light node device. Who can give some indicators, maybe? Yeah, then Hercule.
Of course, at the very beginning, every technology can have an higher cost or can be not that cheap. But since the scope of this innovation research projects and the first Platone is to make a standard, and possibly a standard using open source, and a standard device, the price of this equipment will be lower and lower in times. We are looking as a target in Italy. The target is less than 100 euros in the early years and less than 80 and 60 euros later on. Of course, we are very close to that, and as much as concurrency and technology providers will start, as you know, like our mobile phones at the beginning were very expensive, then they became very cheap, and now becoming very expensive again. I don't know why, but okay, that's another story. Of course, this cost will be lower and lower. So it will be a cheap and very diffused equipment for all of us. Thank you, Andrea.
Thank you, Hercule. And we have one more question. Beyond the technical questions, will energy communities play a role when rolling out the Platone solutions? I think we have a panel describing a little bit around this topic, but maybe someone wants to give some takes or answers on this question. Who feels comfortable? Benjamin, very good.
Yeah, so we are basically addressing this topic in our demonstrator. So the question is energy community in what sense? So as a DSO, we are mostly speaking of low voltage grid section, like small villages that are showing a high number of generators and consumers, flexible loads. And there's the idea also addressed by the European Commission that is saying households shall be enabled to improve their local self-consumption, also community level, so collective self-consumption. And at least, I mean, in Germany, there is like this topic from a regulation is not addressed directly. Communities or households are allowed to form like local initiatives, but energy communities on a large scale that practicing collective self-consumption is, I mean, at least not in Germany, foreseen by the regulator. But we as DSO, we see as a big potential for improving local self-consumption, and we need to see to what extent these communities can also provide flexibility to the distribution system operator to improve the distribution grid efficiency.
Thank you, Benjamin. Any other last questions maybe for this specific panel? No? Very good. Then thank you very much for all those who have given us some pitches, and we can move to the next part, from digital to analog again. The next will be a keynote given by Manuela Oyan. She'll be joining us virtually, and I'll just give 2-3 sentences about her. So as far as I understood, and the internet has given me the opportunity to find information for her, so if there's anything not correct, please correct me if I'm wrong. So Manuela Oyan has an extensive professional background in the field of environmental sustainability and sustainable development. She had held various leadership positions in renowned organizations and has been actively involved in climate protection, energy management, and sustainable construction, also circular economy initiatives. Currently, she's the head of environmental transition of Milan's Agency for Mobility and Environment, and she will today talk about the value of demonstration projects. Yeah, you are there already. Perfect.
Yes, good morning, everyone. Thank you for inviting us at this conference. We are not part of the Platone demo, but we are very much interested to understand and learn more about the market flexibility, as well as I think we can bring you some ideas about future demos in the follow-up of the Platone project. And now I will introduce a little bit about Milano. I'm running slides, or you are? Okay, so about Milano. As you know, Milano is a really dynamic city. We are somehow the economic driver of Italy. And also we are now started a transition towards carbon neutrality. Our city council set a target to 2050 to be a carbon neutral city. And to reach this goal, we are engaged in a few initiatives at a European and international level. Like the C40 Cities for Climate and the Eurocities network. We have set an intermediary target to 2030 to reduce our CO2 emission to minus 45% towards 2005. And as you know, the main lever to reduce CO2 emissions is to be energy efficient and reduce the use of fossil energy. Last year, we have been selected by the European Commission to be part of the 100 climate neutral and smart cities in Europe. This kind of platform promotes joint initiative to speed up the carbon neutrality at city level, also providing some kind of financial funding from the European Commission project like Horizon project or from the European banks. Of course, we cannot reach the carbon neutrality in 2030 at city level, but we are promoting some carbon neutral areas that have been identified within the city. So there we will try to speed up the process. Furthermore, we are electrifying as much as possible the public transport, and we will be full electric by 2030. On top of this, we promote also sharing mobility, electric sharing for bikes and for cars. So we put in place, that's the next slide, an action plan. That is the Milan Air and Climate Plan, because we need to face the both topic, the one of climate change, but also the one that is really much connected, that is the one of improving air quality. Our vision of a city is a city that is healthy and inclusive. So we really want to pay attention to the topic of inclusiveness. So also from an energy prices point of view, we are pretty much attentive to the and worried about the increasing price of energy and electricity. We want to have a city that will be highly connected and accessible. This is so about promoting sustainable mobility. About energy, we are even highly ambitious because we want to get energy positive. This means reduce consumption as much as possible and promote the use of renewable energy. Our city will have to adapt to climate change, and so we need also to apply natural-based solutions to the city. And last but not least, we are putting in place some specific actions to engage citizens and as much as possible and promote behavioral change of our citizens. If we want to go into a little bit more depth about the positive energy Milan. This is the next slide. As said, we are looking on one side to the energy consumption, and we have a goal by 2030 to reduce by 50% emissions in the public building, but also we would like to promote acceleration of energy renovation of existing of private buildings, as well as promoting some specific projects in some regeneration projects, so in areas, urban areas that are being refurbished. This is about the demand of energy. In terms of energy supply, we would like to promote new ways to produce thermal energy and use as much as possible heat pumps and district heating, but also to advance the use of renewables, promoting energy communities, and also helping the tertiary sector, so for example, commerce or small and medium enterprises, to be more efficient from the point of view of electrical uses. In practice, next slide, we have a strategy for energy transition and electrification. This is based on working in depth also with our universities and the research centers and with business in terms of technologies, promoting heat pumps, electrification for public transport, and spreading around the city the recharge point for cars, and said also promote shared bikes and vehicles electric. We have put in place now since a few years an energy help desk that promotes initiatives by the citizens to save energy and apply energy efficiency measures. So we give recommendation and practical support to citizens on the topic of energy. And I think that also this topic of energy flexibility could be one of the topics in the field of action for the energy help desk. In terms of policies, now we are refreshing our city master plan, and there will be a specific topic on the energy grids within the city master plan. And we will discuss there also about carbon neutral communities and positive energy districts. So we will give there some regulations from the municipality side on how to promote the positive energy districts. About the renewable energy communities. Next slide. We are bound to, we need to follow the regulations that are now in place in Italy that are not finally set because we are waiting for some additional criteria to be specified on how to build the renewable energy communities. And to set our strategy, we took into consideration the fact that the city is divided into 9 municipalities. So we need to use the dimension of the municipality to put in place these communities effectively. And within these municipalities, there are overall 98 administrative communities. So this to us is the right dimension to get the citizens involved and also to make capacity building and engagement of the citizens. From a purely technical point of view, the Italian system is based on the primary electric cabins. So you can build an energy community within a primary electric cabins. And we have 19 of these cabins in the city. So these are the influence area for the energy communities. Which is our approach to the energy community? That's the following slide. It's for us an opportunity to make the transition happen. Next slide. So from our point of view, first of all, the energy communities are a way to organize and manage together sustainable production of energy and also aggregate the demand. So the bigger is the size of the community, the most is the benefit in terms of social and also in terms of economic. So we promote as municipality also solidarities, because we think that the incentives that are given from the government to promote the energy communities should be used not only to recover the investment, but also to apply social projects. We are running as municipality some pilot initiatives just to make research and learn. Currently, we have 5 main communities that are being put in place. A few are in the central area of the cities and the other are in the outskirts of the city and also in the rural areas. I just mentioned these 5 main communities because these are initiatives from the third parties that have been supported by the municipality, and we work together to submit our proposals within a call of the regional authority. In fact, the regional authority launched a call to make a short list of renewable energy communities that were interested to get some kind of financing by money made available by the region itself, and then we submitted these 5 projects. Next slide. I said before, we have a strategy on renewable energy communities. So first of all, concerning the public buildings, first we want to understand if we can have a mechanism for self-consumption. So try to see if we can use the electricity within the building itself, and so or we can share the electricity produced by one building that is used as a producer with a photovoltaic equipment on the rooftop with other municipal buildings that are just consumers. So this is kind of collective self-consumption. Then the other approach is for social housing. We would like social housing to produce and use electricity by themselves and use this electricity also for the occupants of the building itself. This will allow also to reach this objective of solidarity by the municipality. For all the other cases, the municipality will make our own building available for the community to enter into the renewable energy communities. And then we ask to the participants, to the communities, to use their revenues for social or environmental projects. So this is, in our view, the right approach that the municipality needs to take into consideration to ensure the inclusiveness of the process. So these are the main principles. Then if we go into practice about the 5 focus cases, about the 5 cases that I've mentioned before, one of them, that's the next slide, the following slide. One of these 5 projects is the Polyme renewable energy community, where Polyme is the Polytechnic University of Milan. This is a very special project because we have a mix of public buildings. So we will have 5 photovoltaic plants installed on primary, secondary schools that will join additional plants, 6 photovoltaic plants that are owned and run by the Polytechnic University of Milan. This is a campus that is hosting 20,000 people. They have even 30 buildings, including a sports center, but they have also quite advanced in terms of energy management because they have already installed an advanced cloud architecture. Politecnico is also joining a pilot project by the Italian TSO about mixer-enabled virtual units. So this is, for us, as a municipality, an opportunity to learn how a new additional photovoltaic plants could be added up to this existing system and to this existing architecture. I will not explain how it works with the cloud architecture because I'm not directly involved in it, but in the next slide you can see a scheme on how the system works. So they have part of the system already in place because they are using district heating, and that is produced, that is connected to the main district heating system of the city, but they also have own heat pumps that are using groundwater. They have a CHP system in place for also producing of thermal energy, and they also have a photovoltaic in place, but they will add additional photovoltaic, 1 additional megawatt, and this will be part of the renewable energy community project. So we will learn from them since they have a system of sensors installed, they have databases, data lakes, and they are able to have real data monitoring of the functioning of the whole system. This will be for us a learning experience. Next slide. So the vision of us as a city is that renewable energy community have many different benefits for the city itself. They will help us move towards climate neutrality and also bring us forward to the smart city. We will be able to promote solidarity because our communities will be mainly social. And also we will be able to make experiments to operationalize innovation and use, like you have seen what they are doing at the Politecnico, some demand response system and grid flexibility systems already in place. Looking at the future, we know that our DSO is working on the topic. We heard about this MindFlex project. So we are open to experiment, and we are waiting for proposal about the new market approach and the market of flexibility. Thank you.
Thank you very much, Mrs. Oyan, for the interesting insights to Milan's vision for 2050. And to jump into the next session directly, which is moderated by Ercole De Luca, Head of Electrical System Development at Areti and the leader of the Platone Italian demo, and Roberto Zangrani, Secretary General EDSO, who will also be joining us on the stage. And the name of the session will be Thinking Regulation and Innovation Together. The floor is yours.
So where do I sit? There. Good morning. Good morning, and welcome to all of you to this panel. The title of the panel is Thinking Regulation and Innovation Together. And the first things I want to say is what we are not going to discuss. We are not going to discuss if innovation and regulation should work together, because the answer is very easy. They must work together. What we want to do here is to know how this virtuous process can be implemented, looking at how it was done in Platone and in its related projects. To do that, we are going to ask it to some of the key figures of this innovation project and of the energy sector in general. And so that I ask you to help me to welcome our panelists. They are, you see some of them on the screen. First of all, the CEO of the DSO of Rome, Areti, Mr. Massimo Bonato. Welcome, Massimo.
Good morning, everyone.
And then the head of asset management, smart infrastructure, the multi-utility of Milan and Brescia, A2IE, Mr. Luca Cavalletto. Welcome, Luca.
Good morning, everybody. Hi, Ercole.
And then the head of subsidized programs in Enel Grids, Mr. Marco Baron. Welcome, Marco.
Good morning, everybody.
And then close to me, the very well-known to all of us, Secretary General of EDSO for Smart Grids, Roberto Zangrandi. Okay, we can start, and I want to start from Rome. And I want to ask to Massimo, since Areti is strongly committed on decarbonization, and to reach this goal in these years, we applied the strategy to heavily invest in innovation following the ongoing regulation evolution, and at the same time quickly industrialize these outcomes and including them in our development plan and operation schemes. So Massimo, the successful story of Platone and its legacy, RomeFlex, that as most of you know, is the pilot project for the local flexibility market issued by the ARERA, the National Regulatory Authority of Italy. Those projects are brilliant examples of the Areti innovation strategy, isn't it, Massimo?
Yes, Ercole, thanks for the question. I will do some consideration. I will try to answer to your question. Due to the decarbonization needs and geopolitical events, DSO rules is changing very quickly. DSO are working every day for continuous improvement in performance in terms of SAIDI and SAIFI, in financial efficiency. We are working in new functionality that never provided before, like running flexibility markets. This means for us to speed up innovation, and this means also new competencies and new technology that we must learn how to manage. The driver of this change are regulators. The enabler of this change is innovation. Our task, DSO task, have to be the bridge between regulation and innovation. Areti's strategy has been to cooperate with the European and the national regulators, trying to understand from the very beginning the direction to follow. And at the same time, we apply in research projects like Platone, all these kind of indications. The results have a double value. From one side, give to the DSO an early compliance to its new duties. And on the other side, give precious information to regulators on how new provisions work in the real working life, enabling them to fine-tune rules. The Platone experience is, I think it's a brilliant example of this strategy. Areti actively cooperates in writing the 943 and the 944 of 2019 directives. We implemented a full integrated TSO-DSO flexibility market, including all stakeholders, and all needs technology accordingly to these directives. We had the fortune to have the Italian National Regulatory Authority, ARERA, very active on this new regulation, and open to work with Platone and its Italian demo. And about this, I must give a special thanks to Luca Lo Schiavo, that was so important in the Platone advisory board. He has been the link with the other ARERA structure. I want also to thank Andrea Galliani, who closely followed Platone evolution and prepared the Italian regulatory framework for local flexibility by publishing the 352 of 2021 provision. That is a milestone for the local flexibility market in Europe. Now Areti is industrializing Platone in the ARERA 352 framework in the ROMFlex pilot project, reusing all the platforms, technology, and all the processes developed during the Platone project, sharing the developing and putting all the knowledge at the service of all the Italian DSO. So in this way, they are immediately ready to run flexibility as well. The first DSO coming on board of Platone and ROMFlex was Unareti, Milano DSO, with his Mindflex project. And I think that after me, Luca Cavalletto can give some more, will better explain what they have done and what they want to do. I want to give also a special thanks to Unareti for the excellent cooperation and the help that we give each other on this important matter on real cooperation between DSO. Finally, Areti is proud to have given its best to Platone, and we are grateful to Platone and to all its partners to have helped us in designing our common future. That means thinking regulation and innovation together. Thank you.
Thank you, Massimo, for this witness of how a manager of a so important company like Areti really hands every day innovation and regulation to make the best for his company and, of course, for all the energy sector. So thank you, Massimo, for this testimony. Thank you very much. Now I want to move from Rome to Milan, still stay in Italy. And I want to ask to Luca, A2A Unareti is one of the main Italian energy sector player, and is very active in the innovation and very well positioned into the Italian DSO framework. And as Massimo mentioned, what about your experience in competence sharing with Acea Areti and your decision to launch the Milan project Mindflex in synergy with ROMFlex, Luca?
Ercole, first of all, thanks for the invitation to this event. As I told you, I think Platone project is a milestone for the future of electric market, and it's very important for me to be involved where the future role of DSO is being writing. A2A, in particular Unareti, for the electric grids, is active in many projects to provide energy transition, decarbonization, in order to make everyone able to connect it to the grid as consumer and producer. It's not important to mention the name of the project because each DSOs more or less does or try to do the same things, calling them differently. With Areti and other DSOs, we know this. And we have started sharing our experience, and we have understood that our grids are similar, not only in physical terms, but also with the same issues and the similar customers. We started talking about how to become more resilient, an example to heat waves, how to digitalize networks, and how to become flexible now. 3 years ago, when Ercole, you told me about this project, I understood that Unareti needed to embrace this solution. Because in the future, in a fast future, we have to change quickly, not only in terms of investment plans, but also to solve daily problems the DSOs have. For example, when I have to maintenance in my grid, now I just change the grid configuration to minimize power outage. In the future, with this technology, I can request a service to balance the network without electric outage for customers. And perhaps in the future, we'll be able to use this solution for other services that we don't know now. And another thing that is important, and I want to underline, is the need to use the same platform, the same architecture. With the architecture of Platone, the same architecture of Romflex, and the same architecture of Mindflex, Areti, Dunareti, and other DSOs in Italy have made it possible a request of Italian regulator. All DSOs and TSO have to collaborate, simple. And collaborating, from my point of view, it is only possible using the same language and the same platform or architecture. It is also important to remember that we do a service for our connected customer, and in the near future, we have to explain to our customer this new possibility. The possibility to being in a new market and the possibility to being more efficient. In our cities, Milan, Rome, and the other cities, the future is now. It's normal to have new full electric houses with renewable generation, storage system, and electric vehicles, the perfect condition to join in this market. As we have seen in our presentation, Tech for Engineer Oyan Formation Mindflex project, cities are ready for this technology, and citizens are waiting us. They are waiting for a single user-friendly platform for Milan, for Rome, and other cities. For example, in our project, we study the possibility of finding flexibility in Unareti grids, Milan and Brescia, now and 2020-30. We study behavior of customers, both domestic and non-domestic, and we find more than 200 megawatt of opportunity for flexibility. We don't think about only energy communities or aggregator, BSPs. We think of normal users such as supermarkets, big commercial buildings, charging point for electric public transportation, or efficient cogeneration system. This type of customer is already technology capable to join in this market. I think we are only at the starting point of this journey, but the direction seems correctly. And finally, I want to take thanks to Areti, Mr. Bonat, and you to do this journey together with us and with other DSOs in Italy. And also thank to Arera for this possibility.
Thank you very much, Luca, for this really important interview. I want to stress what you said at a certain point. You said, in some way, we have these platform technologies and so on, developed in this case by Platone project, the importance for DSOs to use in real life the products of these EU-funded projects. This is the scope of European Commission when paying us for developing a research and innovation project. What Luca said is we decided to join this framework of existing platform to reuse and make Italian DSOs immediately able to run flexibility. So thank you very much, Luca, for having stressing it and for all you are doing in the Italian flexibility framework and the European one. And then I want to move from Rome to Milan, from local utilities to a global company, then to Enel. And then I welcome Marco Baron, and Marco, you belong to a global player, that is Enel. And then in some way is driving grid innovation in Europe, but I would say in the world. due to its presence almost everywhere. After the success of Coordinate, you were the coordinator. Congratulations for that again. And the success of Platone, you have been involved in the advisory board. You were very active as usual. I want to ask you, from your point of view, which was the main contribution that these two projects gave to all the following activities in which we are involved together, Marco?
Thank you, Ercole. I hope you can hear me. Good morning, everybody. It's nice to see you again after a long time. We finished Coordinate a couple of weeks ago, and unfortunately I cannot be there, so I'm sorry for that, for internal policy issues, but we will see each other very, very soon. Ercole, first of all, thank you for the invitation. Let's start with the photograph, okay? It's nice to see the huge outcome of Platone and all the other projects. Since you remember that when we started this type of project 10 years ago, in our companies, they look to us as, it seems that we work on niche initiatives. They were a bit worried about the timeliness of such initiatives. And then I can say that after many years, especially in the last years, starting from the clean energy for all the Europeans package up to the initiative of the European Commission on the digitalization of the energy system, we saw that our projects really have an impact on the discussion at European level. I will mention not only Platone and Coordinate, but also Universal, OneNet interface. It's not my opinion, but it was also highlighted by Mark von Stipau during the last grid event a couple of weeks ago. So thank you very much for the work you've done, Ercole. Looking into Platone, we didn't agree on the speech today, but I saw from the list of key exploitable results, but also from the slides of Antonello, that you mentioned a lot of results from this project. All of us are familiar with the DSO technical platforms and the market platforms, because practically with different approaches, all our projects focus on them. So no need to discuss about them. From the beginning, I was a bit impressed by three main concepts. One was the open source blockchain layer, honestly, because when you start this project, the application of blockchain was still something new. You know that in literature, researchers are a bit, the opinions about blockchain are still controversial, but of course, the approach that you made in the project and that type of initiative was really appreciated by us, since you try to make processes more transparent, and this is a value from this project. In addition to that, you mentioned in the key exploitable results, but the light node was something really interesting and useful for us, even at national level. For the fact that this device collect data from the meters, receive and send set points. So somehow, regardless of the actors that will have the responsibility and the ownership of this device, we use the light node as a mean to stimulate the discussions about the increased need for observability and possibly also controllability of our networks, whatever it be the actor responsible for that. This is a value for us in Italy, but I think also in Europe. And that's why, and then I will mention that, we continue to discuss about that in the following projects, the projects where we are working together. And then, although from an innovative point of view, maybe it was not so challenging, the concept of this shared customer database is really relevant for us. And we will continue to discuss about that in the following projects, because there's a need to make processes transparent, even for external stakeholders that should monitor somehow, for example, the acquisition, activation of flexibility services. What are the gaps that we have to work on? Platone is not guilty for that. I mean, these are gaps that are valid, in my opinion, for any project. I will mention some of them. Maybe you already mentioned during the previous sessions. One is about scalability, Ercole. But this is quite obvious. I can skip this point, since by nature, you know my opinion, the Horizon projects are really essential for us to bring on our point of view, but of course they are limited. in resources and in technical capabilities. The second point is, and it was stressed also in the previous session, is the social and customer engagement. And this is particularly true considering what type of complex scenario our users and our customers are facing. I'm referring to COVID, I'm referring to Ukraine conflict, and for this reason, for example, what happened to the energy price volatility. In that sense, in Cordian, we try to, use a mechanism by European Commission called cascading funds to engage. I got an echo here, maybe.
It's okay. It's perfect. We listen to you perfectly.
Okay. No, now it's better. Thank you. We use that mechanism to engage stakeholders that were not included in the consortium, because at the end they are really the users of all the architectures implemented in our projects. And in that sense, I will not comment regulatory issues because Luca Loscavo will follow us. But regulatory sandboxes are welcome for us because it's a way to extend what we already implement through the European projects. And then the last point is about the impact of flexibility on grid planning. For natural reasons, for obvious reasons, all our projects focus on operation and operational issues and operational planning issues. Probably in the next projects, and we are already working on that, you know that, we need to focus more on this domain because this is an essential domain for at least for the distribution system operators. Being aware of the work to do, some of the partners involved in Platone, in Cordian, and all the other projects are already working in new projects. I know that at the end of the event, there will be some presentations about flow and be flexible. Let me thank you, Ercole, and all the Italian partners, because for the Italian operators and for the research institutes in Italy, Platone, Cordian, and all the other projects were an opportunity to gain experience. And for the first time in our history, in the Horizon and FP7 projects, most of the Italian stakeholders work all together in these projects to bring on discussions about coordination schemes, solutions, and market design. So this is a stunning result, and I have to thank you, Ercole, for the work you've done in these years. Thank you very much.
Thank you to you, Marco, for this really excellent speech. You gave us this your time sharing your great experience and knowledge, very deep, let's say, specialized, and at the same time able to make an overall view. I want just to mention something. You said at the very beginning we were scared, are we going to use blockchain and that this light node? Yes, Marco, as you know, who makes innovation, either management or project managers and regulator, have to be brave in some way. And I have to say personally that Marco is one of the persons that helps all of us DSOs to be brave, since he is in NL, he's a driver, and he's really, really, really a leader for us in being brave and be effective. So thank you very much, Marco.
Thank you.
Now, in Latin we say, dulcis in fundo, and I say in Latin because I'm not able to say in English. Close to me, Roberto Zangrandi. Roberto Zangrandi is our Secretary General, has been leading, has been our referral in following the evolution of regulation and inspiring it and helping when needed. Really our leader in this EDSO association. And then Roberto, from your very, very important point of view here from Brussels, you see how it's going regulation. You are involved in all of our innovation projects, almost all. So you are probably the best person to ask this question. Are we as DSO running in the right direction in merging innovation and regulation together?
The answer is yes, but it could be better.
Okay.
Not that bad. We could do better. The answer is yes for several reasons. But first of all, let me thank Massimo Unaretti and Marco, who are friends and members, or former members of EDSO, and it is more than a joy to see companies that belong to your association joining other companies and developing such a mass of tiny pieces of innovation that make this a giant step forward and beyond the debates about flexibility. And thank you very much to Monica Ojan or Ojan in Milano. I hope she's listening because she opened. Yes. Yeah, Monica, thank you very much. You opened a window on my youth, because seeing the neighborhood where I grew up in Milano featured in advanced electrical futurible and future made real, it gave me a great joy. On that on that soccer playing ground that is featured in one of the slides that you deployed, while I was playing my poor soccer, and then opted for another career, as everybody can see. So this is, thank you very much. It was really very nice. Going back to yes, but we could do better. We are very much concentrated in doing our job, in looking what it could be the legislative impact or the regulatory impact of something that is evolving. We are not brave enough in comparison with the DSOs that have been brave in adopting early solution, in experimenting, in putting courage, technology, and money in this experimentation. We are not, as an association, brave enough to impose a vision for the future. And sometimes we indicate that there is an evolution, but still do leave with the regulation, capital R, so the big regulation concept, as a passive element. So we encourage to consider something, but we are not yet able to go and say, we want a guideline that goes from here to there and that allows all the future evolution that we envisage. And so this is the slowness that is going to be overcome in a way, but this is the slowness that makes me say, yes, we are right, we are on track, we can cope in coupling evolution and innovation, but we do not do as much as we could, and I would say as much as we should, because the innovation is certainly triggered by the researches and the application that we dare to implement on the grid, but it is not yet treated as a phenomenon that we govern accordingly in the dilemma innovation and regulation together. So the first real proposal is, let's look beyond that. When we embrace such a courageous project like Platone, which has delivered, like you mentioned, Interconnect. Interconnect has been acknowledged by the Commission as a very successful project. And this is a real reason to be proud to be in this community. But when we embrace a project like Platone, let's cut a little section of the innovation that we are going to develop. Let's imagine a work package that could, in the future, develop the future beyond the deliverables of the project that we are involved in. And this could be not only fruitful on the ground of the implementation of the early results and the so-called low-hanging fruits that you told me ASEA, Unareti, and Enel are experimenting, but really accompany the institution to imagine what can come next. For instance, nobody so far did answer a question about flexibility. And it is, how do we handle the inevitable financial products that will develop with flexibility and the flexibility markets? We can imagine that. We can say that it's not our business. Our business is the grid and how to manage the grid, how to use the flexibility in the grid, etc. But it is also what this new approach to the grid and flexibility could bring to the evolution of the market. Is a flexibility, is a storage, is the participation of private and active consumers going also to develop into financial tools that we cannot yet imagine, or better, we could imagine, but that we are not in this very moment already able to master and govern. Could this be an element that can distort or improve or push or slow down the use of flexibility, etc., etc. So the lack of this bridging between a possible evolution of societal effects of a technological elaboration and bravery should be compensated by a forward-looking ability from the DSOs to guide and interpret the future regulation and not just wait that the regulation adapts. We have seen that with the metering data. We are now all talking about the sub-metering in the market design reform, and sub-metering was already there. I mean, all what is able to measure anything beyond the meter is a sub-metering, but it is there since 5, 6, 7 years. And that array of data will be difficult to regulate, will be difficult to even to assess and to use for the benefit of the consumer and of the DSO and the efficiencies of the grid. An American regulator told me during a private visit that I had a few years ago in the United States, listen, the regulation issue is just one. When you have 8 million amateur drones flying over your head, it's too late to regulate. So this is the point. Nobody could imagine with the first playing drones for the kids or for leisurely scopes, etc., that would have developed into something so big and so widespread all over the world. And now it's too late to regulate. Well, if this continues happening also in our sector, I think that we shall have problems in the future. I could go on for 1 hour and a half, but I think that we have got a limit. So I hope it was enough for an answer. But just to recap, be brave up to the end. When you embrace a project, devolve a part of the intelligence that you pour in the project to imagine what is next.
Roberto, thank you for these 3 crucial indications, well noted. We'll do our best to fulfill we did. And thank you for this really, as usual, illuminating interview and your capability to give the direction. And I want to stress something you didn't say explicitly, but it was implicit in your words. We said before how much important is for our companies to put together technologies and use technology. In the words of Roberto, we see the importance to have association putting together companies and people. So thank you to our EU association for what you do and for the importance of the role you play in the energy sector. Thank you very much.
Thank you very much, everybody. And thank you very much to the friends on the screen here behind me, and in particular Massimo and Marco, whom I do not see since too long a time. And I will come and see you at Unareti when I come to Milano.
Thank you, Roberto. Thank you very much.
Surely, Roberto.
Thank you.
Thank you. Thank you, Massimo, Luca, Marco, Roberto. And now,
thank you very much on this very interesting take on innovation and regulation working hand in hand and imagining the future. The next input we will receive will be about the contribution of regulation to the effective innovation of the power system by Luca Lo Schiavo. Sorry. I was with the Italian names. Schiavo. So I'll try. Yes. So I will try to put together a small CV. I found a very extensive CV online. It was in Italian. I do not speak Italian, but I used some digital tools. And if I'm wrong at any point in time, please let me know, but I'll try it. So you've been working at ARERA, the Regulatory Authority for Energy Networks and Environment, since 1997. Throughout your career, you held various positions and responsibilities, including assistant to the president and head of the Quality Unit for Energy Services. You also served as an expert in drafting legislative decrees and participated in European agencies such as ACER. And currently, you're holding a position of Deputy Director of the Infrastructure Department, focusing on the electricity sector and innovation. I hope this summed it up more or less. And with this, I give you the floor. Thank you very much.
Thank you for invitation. I'm very happy to be here. I try to talk about a very important aspect of regulation, that is how regulators can help innovation to foster, to widespread, and to enter in everyday life of the power system. I start from short messages from ISGAN about the barriers of innovation. The first barriers are about customer engagement. That was one of the topics treated just before, about the, let's say, too much attention on a research project instead of having a wide vision and focusing on, as you say, the everyday business. And also regulatory systems can be a barrier, although they are not in the very first levels of this list. It's important also to remind that ISGAN has been very active in surveying the regulatory different approach all over the world about what is normally named experimental sandboxes. And I want to remind you two casebooks that are plenty of examples at global level. I must say that regulators didn't have, at least in the last years, a common language about innovation, and different topics, different names, different concepts have been put on the table in different places also, and in different years. But the main common idea is regulatory learning. That is, this kind of innovation initiatives are useful because every part in the system can learn, including regulators and, of course, operators and customers. A recent contribution to this topic has been given by CR, the Council of European Energy Regulators, through this paper that you can find in the CR website on regulatory sandboxes and incentive regulation. The main idea is a toolbox for dynamic regulation. Dynamic regulation is a wide concept encompassing all different ways, approaches that regulators can use to contribute to innovation in the power system. And the toolbox is concentrated in two dimensions. The first is the kind of players included in the experimentation, and the second is the scale of the innovation, of the case, of the initiative. In this box is the most recent approach, let's say regulatory sandboxes that normally are a small scale, but open to grid and market operators jointly. At the opposite, we have what we call the regulatory experiments on large scale, but normally limited to grid operators only. And we have still other two cells, pilot projects for small scale initiatives, and large scale, we call them pilot regulation. I will explain in a few minutes. So the main point is that regulatory sandboxes is only one of the multiple tools available to regulators, energy regulators, to support and foster innovation. Pilot projects, as I said, were concentrated mainly on DSO and TSO. They were limited in scale, typically for a limited portion of the network, and required a case-by-case ex-ante approval. Regulatory sandboxes are sort of similar, but they are also open to retail supplier and third parties, and DSO have typically an enabling role. Then we have a few cases, here in Italy we do have, where regulatory experiments are something similar to pilot project, but on a very large scale. And pilot regulation are probably the most advanced tool because they don't require a case-by-case ex-ante approval, but they constitute an ex-ante framework in which that is put aside the old one, and all interested players, conceptually including also DSOs, can participate, and of course they must prove to have the requirements to do that. A very interesting report has been published recently by the JRC, the Research Center of the European Commission, making energy regulation fit for purpose of innovation. And they elaborated upon the CR paper, so they also used the concept of pilot project, pilot regulation, and regulatory sandboxes. This is the map of how European member states are engaged in sandboxes and other initiatives. These are the topics, so collective self-consumption, electromobility, flexibility, very important, and so on. And these are the countries more examined, that the JRC surveyed and found something, let's say. I use this map to say a few words about Italy. We started from pilot projects that were the first cases, and then we moved in three directions. The first one, about regulatory experiments, the idea was that DSO can propose and implement derogations to the current regulation. The topic is quality of service regulation. They don't lose the incentive and penalty, of course, also of the quality of service regulation, but it's up to them to find the most appropriate path to the requested quality levels. And just to say that regulatory experiments in Italy covers 9 million customers, so they are very large, on a very large scale. The second direction is very close to the topic of today, because we entered exactly for flexibility market, for flexibility services, in a phase that is 4 or 5 years long, where a new framework for balancing market has been introduced aside the old one. For instance, according to the old one, only large-scale generation resources could participate in balancing market. Now also small aggregated resources at every level, including renewables, can participate in balancing market. And especially according to this idea of pilot regulation, we avoid case-by-case approvals. And again, we reached 1.3 gigawatt of new resources in the balancing market. And a second example of pilot regulation is going to spread just in the next month, in the next weeks maybe, about flexibility at distribution level. Building on the Platone experience, we are now evaluating the proposals of DSO for flexibility service at local level, again in a pilot regulation. And the third dimension is towards regulatory sandboxes. This has been used in the gas sector, that so far was the less exposed to innovation. And we launched the call, and we are now evaluating the proposals for innovation in this sector that so far was not impacted by this kind of initiatives. So I conclude, I think that regulation can contribute to effective regulation, effective innovation. We must have some principle in mind. First, variety is inherent with innovation. So there is no a single solution. We have always to select the best suited tool, and we can choose from the toolbox according to different targets, different involved roles, the scale of the experiment, I would say the state of the innovation, and also the funding and derogation issues. Derogations are the most critical issues because there is a risk that regulators must avoid, that derogation can provide an advantage, a competitive advantage to some parties, and so this could be a discrimination. So we have to consider derogation only if there is no discrimination among market players and safeguarding the consumer interest. This can be really a difficult, a tricky point. Also, the difficulty of this kind of contribute that regulators can give to innovation is extracting lessons from the trial experience. This is not simple, this is not easy. But in my experience, pilots and sandbox are useful because all players change their mindfulness of the problems and develop a different approach. And there can be and should be a learning process among all parties. I repeat, regulators included. Last, I would say that pilot projects are interesting, but scale matters. Scale matters. So we have to go beyond the limited pilots or limited sandboxes. They can be useful in a very beginning stage. For instance, for the gas sector is the case, but we have to provide a push towards large-scale innovation. That is really the point to build a future-proof system. And it is up to us to work together, of course, with the stakeholders, operators, and customers for eliminating any regulatory barriers and reducing the uncertainty and the risk of novelties. Thank you very much for your attention. And if the case, I can provide some answers.
Thank you very much for the insightful input. We have one question in the audience, if I may direct it towards you. Is that okay? So the question is, have cybersecurity requirements been considered in Platone at all? So maybe this is a question some of you can answer. And second part of the question, what's the view by Herrera on cybersecurity requirements for flexibility approaches? So maybe the second part you might be able to address.
The requirement for flexibility.
Yes, and the cybersecurity requirements.
Well, cybersecurity requirements are a very general level, so there is no specific requirement.
Okay.
I hear an echo. Can you avoid? So, thank you.
Yes, microphone. You can find one here, Hercule. Ah, perfect. You're just figuring out the microphone. Just a second.
Yes, on cybersecurity, of course, we had this Platone project building up the platforms and interfaces and so on, and now into the national application, real application, like, of course, RoamFlex, MindFlex, and all the other local DSOs implementing Platone. The cybersecurity aspects are being industrialized, and what we see now, of course, this is one of the most tough and challenging work we are doing, but of course they are central, because the most we open the grids to interact with the customers and with other players, the most cybersecurity issues are in. But we are working on top of the Platone platforms just to implement all these cybersecurity issues, and we are doing, of course, in the local industrialization of Platone.
Perfect. Thank you very much. Okay, then now we're going to get to a very important point of the agenda, aka the lunch break. But before I leave you out, I have two things to announce. The first thing is we also have a showcase area in the back, and because our virtual participants cannot be here, obviously, they'll be shown some videos summing up more or less what is shown there. So don't leave, just stay in the virtual room and check out our videos. And before you here in the room all disappear to the back, I would like to gather you here and make a maybe last photo of all the participants within the Platone project, so we also have a nice memory to remember this day. So with this, have a good lunch break, and I see you, or we see you, at 2 p.m. Thank you very much.
Future energy system needs flexibility. If you ask the technician, they tell you, give me prognosis and data, I control the demand side. If you ask the business people, they need marketplaces and the price to the good flexibility. If you ask the practitioner, they need a product and the proof that it works and is cost effective. In Flex community, we bring together these people. Platone has started it together with the Fever and the EdgeFlex project. Meanwhile, we have 19 projects on board and more than 200 practitioners, academia people and industry people. It will go on forever, hopefully beyond the end of these projects. The proof is in February 2024, we will have the next Flex Community Conference.
The blockchain access layer is an IoT integration platform based on blockchain technology that allows the integration of the devices coming from the physical infrastructure. It's based on blockchain technology, allowing the certification of the measurement and also the sharing of the data in a secure way using a flexibility register. Inside the flexibility register, the blockchain technology also enables a data access management, keeping the data ownership and the fingerprint of the data, allowing all the energy stakeholders interested on accessing the data to share it in a secure way.
Local flexibility market is a multi-platform system which enables distributed energy resources connected to the grid to provide flexibility services to system operators. The solution is based on a market approach and implements all the phases foreseen in ancillary services, such as procurement, planning and forecasting, and activation and settlement. The added value of this system is a market platform which guarantee unique several products and a unique register which collects all flexibility data and a smart edge device which enables customers to provide flexibility services to the grid, and blockchain technology which certifies measurements and payments.
So today I'm presenting the Avacon Local Flex Controller, which we also name ALFC. It's an energy management system for low voltage grid that is able to monitor generation and consumption to predict the residual load demand of a community and the energy demand of a community, and control small-scale flexibilities in rule-based and schedule-based control approaches. In the demonstrator, we have successfully applied different use cases and shown that the ALFC is able to apply virtual islanding, the coordination of flexibility requests, and also apply bulk-based energy supply and energy export schemes.
The state estimation tool is a real-time data processing algorithm that ensures the observability of the Mesogia pilot site of the Greek demo and has been developed within the framework of the Platone project. It essentially is a distribution system state estimator which captures the closest to reality operating state of the network. Also, it acts as a key enabler for the network tariff model that has also been built within the framework of the Platone project. The innovation related to the state estimation tool is the deployment of synchrophasors in distribution networks and the processing of both conventional and synchrophasor data.
So the key area that I'm presenting, it's about the software tools, the software architecture that we have developed in order to estimate the scalability and applicability potential of the Platone use cases into future distribution network. This framework of this key ER, we have developed a software architecture that will quantify the impact of the deployment on a large scale on different boundary conditions of the solution tested in Platone. The scope of this, the creation of this software tool is to estimate which could be the potential and the benefits that can be triggered by the large-scale deployment of the solution tested in Platone when it will be applied in future scenarios, or when they will be applied in different network conditions characterized by different types of load, different type of generation, or different type of customers connected to the grids. The scope is to give an ex-ante evaluation of which could be the potential to deploy this solution at a larger scale.
I'm
I'm honored today on the behalf of my team at RWTH Aachen University to present to you the so-called distributed optimal power flow, which is suitable for solving optimal power flow problems for AC, DC, as well as hybrid AC-DC systems. Obviously, following the open source philosophy of the Platone project, the source code is accessible via Git and can be used by the different researchers and other interested parties. Within the Platone project, we have used this to investigate the replicability and scalability of the developed solutions within different use cases. Please feel free to refer to the website and the repository, and we would be happy to assist you with any questions that you might have. Thank you.
What I'm holding here is the last generation of our low-cost phasor measurement unit. This is a key device for the digitalization of operation of distribution system operator. It allows the conversion of measurement, analog measurement, in digital data, and we can manage this data in a very flexible way thanks to the direct connection to our DSO technical platform. Managing the data is now one of our standard services that we have implemented in our Sonio architecture, and allows to manage data both as phasors when we need or raw data, so that we have a very detailed information with synchronized measurement that allows us to check into the details of a transient. It's the modern and simple way to digitalize the information for the operation of the grid and integrate the results in a modern digital platform.
The Flexibility Market Platform is a blockchain-based platform that supports the creation of the flexibility market. The flexibility market is managed by the web-based platform of the market platform and allowed to create intraday and day-ahead market session, allowing the participation of any kind of market participants, so TSOs, DSOs, aggregators, and customers. The blockchain technology is used for the certification of the entire processes inside the market platform, so for collecting the results and also for request and offer, and also for creating a new innovative mechanism for the incentivization of the customer using tokenization mechanism.
The light node is a very important component of the Italian demo. This is an edge device installed in the customer property. It consents to the DSO to send an activation command, and on the other end, it makes available this activation command to the flexibility asset. The light node is connected to the smart meter to read the real-time measurement, certify this measurement on blockchain, and send this measurement to the flexibility register. It is a very important device because thanks to this device, we can enable all the users in the flexibility market.
I am proudly on the behalf of the whole Platone project presenting to you the educational video series, which is basically categorized in 3 different steps. An introduction about the digitalization of modern power systems and the open source philosophy which can pave the path and accelerate our movement towards this, followed by an introduction about the Platone framework and its different components. Then in the second place we have the tutorials about the open source DSO technical platform, and last but not least we have the testimonials from the demonstrators, which all of these video series are at your disposal on our website, and we would be happy to assist you with any questions that you might have after watching the series. Thank you.
The blockchain access layer is the transparent, reliable, standard link between people and the power grids. The customer just plugs a light node at home, and it's linked immediately and automatically with the smart meter. It just sends all the measurements for the service given to the grid back to the system operator and receives the commands for the service execution. Automatically, all this data are ready for settlement for the rewarding to the customer of the service given.
Hi, I will give you an overview over the probabilistic load forecasting package, short PROLOF, that can be used in the DSO technical platform. PROLOF is a Python package based on PyTorch, which can be used to train, use, and evaluate a deep learning model specifically created for time series forecasts. The model we are using is a recurrent neural network in an encoder-decoder structure, which is quite flexible to forecasting time steps and horizons. In addition to this model, we provide a package for data pre-processing, including scaling and data encoding, and the option to do hyperparameter tuning using Optuna. All of this can be done by just adjusting a configuration file. There's no need to touch the code itself. The package is available on PyPI under the Apache 2.0 license, so feel free to just use it. And there's also a version currently in development that is to be run on Kubernetes as an application standalone. If you are interested in the Kubernetes version of PROLOF or have any further questions, feel free to contact me via mail.
The DSO technical platform is a key component of the Platone concept. It allows a new type of implementation for the DMS, distribution management systems, thanks to an innovative software architecture. This is a concept we originally developed in a previous project called Sogno, but in Platone we made it grow to a mature product that is now also a project in the Linux Foundation Energy. With this architecture, we build a modern DMS as a modular systems, where each functions become a microservice, and we have a standard interface in a databus. We also offer two options of databus, one based on MQTT, another one based on Kafka, for maximum flexibility of operation. It's a key new concept that substitutes the monolithic software that were typical of old SCADA systems.
The future energy system needs flexibility. If you ask the technician, they tell you, give me prognosis and data, I control the demand side. If you ask the business people, they need marketplaces and the price to the good flexibility. If you ask the practitioner, they need a product and the proof that it works and is cost effective. In Flex community, we bring together these people. Platone has started it together with the Fever and the EdgeFlex project. Meanwhile, we have 19 projects on board and more than 200 practitioners, academia people and industry people. It will go on forever, hopefully beyond the end of these projects. The proof is in February 2024, we will have the next Flex Community Conference.
The blockchain access layer is an IoT integration platform based on blockchain technology that allows the integration of the devices coming from the physical infrastructure. It's based on blockchain technology, allowing the certification of the measurement and also the sharing of the data in a secure way using a flexibility register. Inside the flexibility register, the blockchain technology also enables a data access management, keeping the data ownership and the fingerprint of the data, allowing all the energy stakeholders interested on accessing the data to share it in a secure way.
local flexibility market is a multi-platform system which enables distributed energy resources connected to the grid to provide flexibility services to system operators. The solution is based on a market approach and implements all the phases foreseen in ancillary services, such as procurement, planning and forecasting, and activation and settlement. The added value of this system is a market platform which guarantee unique several products and a unique register which collects all flexibility data, and a smart edge device which enables customers to provide flexibility services to the grid, and blockchain technology which certifies measurements and payments.
So today I'm presenting the Avacon Local Flex Controller, which we also name ALFC. It's an energy management system for low voltage grid that is able to monitor generation and consumption to predict the residual load demand of a community and the energy demand of a community, and control small-scale flexibilities in rule-based and schedule-based control approaches. In the demonstrator, we have successfully applied different use cases and shown that the ALC is able to apply virtual islanding, the coordination of flexibility requests, and also apply bulk-based energy supply and energy export schemes.
The state estimation tool is a real-time data processing algorithm that ensures the observability of the Mesogia pilot site of the Greek demo and has been developed within the framework of the Platone project. It essentially is a distribution system state estimator which captures the closest to reality operating state of the network. Also, it acts as a key enabler for the network tariff model that has also been built within the framework of the Platone project. The innovation related to the state estimation tool is the deployment of synchrophasors in distribution networks and the processing of both conventional and synchrophasor data.
So the key here that I'm presenting, it's about the software tools, the software architecture that we have developed in order to estimate the scalability and applicability potential of the Platone use cases into future distribution network. This framework of this key here, we have developed a software architecture that will quantify the impact of the deployment on a large scale and on different boundary conditions of the solution tested in Platone. The scope of this, the creation of this software tool is to estimate which could be the potential and the benefits that can be triggered by the large-scale deployment of the solution tested in Platone when it will be applied in future scenarios, or when they will be applied in different network conditions characterized by different types of load, different type of generation, or different type of customers connected to the grids. The scope is to give an ex-ante evaluation of which could be the potential to deploy this solution at a larger scale.
I'm honored today on the behalf of my team at RWTH Aachen University to present to you the so-called distributed optimal power flow, which is suitable for solving optimal power flow problems for AC, DC, as well as hybrid AC-DC systems. Obviously, following the open source philosophy of the Platone project, the source code is accessible via Git and can be used by the different researchers and other interested parties. Within the Platone project, we have used this to investigate the replicability and scalability of the developed solutions within different use cases. Please feel free to refer to the website and the repository, and we would be happy to assist you with any questions that you might have. Thank you.
What I'm holding here is the last generation of our low-cost phasor measurement unit. This is a key device for the digitalization of operation of distribution system operator. It allows the conversion of measurement, analog measurement, in digital data, and we can manage this data in a very flexible way thanks to the direct connection to our DSO technical platform. Managing the data is now one of our standard services that we have implemented in our Sonio architecture, and allows to manage data both as phasors when we need or raw data, so that we have a very detailed information with synchronized measurement that allows us to check into the details of a transient. It's the modern and simple way to digitalize the information for the operation of the grid and integrate the results in a modern digital platform.
The Flexibility Market Platform is a blockchain-based platform that supports the creation of the flexibility market. The flexibility market is managed by the web-based platform of the market platform and allowed to create intraday and day-ahead market session, allowing the participation of any kind of market participants, so TSOs, DSOs, aggregators, and customers. The blockchain technology is used for the certification of the entire processes inside the market platform, so for collecting the results and also for request and offer, and also for creating a new innovative mechanism for the incentivization of the customer using tokenization mechanism.
The light node is a very important component of the Italian demo. This is an edge device installed in the customer property. It consents to the DSO to send an activation command, and on the other end, it makes available this activation command to the flexibility asset. The light node is connected to the smart meter to read the real-time measurement, certify this measurement on blockchain, and send this measurement to the flexibility register. It is a very important device because thanks to this device, we can enable all the users in the flexibility market.
I am proudly on the behalf of the whole Platone project presenting to you the educational video series, which is basically categorized in 3 different steps. An introduction about the digitalization of modern power systems and the open source philosophy which can pave the path and accelerate our movement towards this, followed by an introduction about the Platone framework and its different components. Then in the second place we have the tutorials about the open source DSO technical platform, and last but not least we have the testimonials from the demonstrators, which all of these video series are at your disposal on our website, and we would be happy to assist you with any questions that you might have after watching the series. Thank you.
The blockchain access layer is the transparent, reliable, standard link between people and the power grids. The customer just plugs a light node at home, and it's linked immediately and automatically with the smart meter. It just sends all the measurements for the service given to the grid back to the system operator and receives the commands for the service execution. Automatically, all this data are ready for settlement for the rewarding to the customer of the service given.
I will give you an overview over the probabilistic load forecasting package, short PROLOF, that can be used in the DSO technical platform. PROLOF is a Python package based on PyTorch, which can be used to train, use, and evaluate a deep learning model specifically created for time series forecasts. The model we are using is a recurrent neural network in an encoder-decoder structure, which is quite flexible to forecasting time steps and horizons. In addition to this model, we provide a package for data pre-processing, including scaling and data encoding, and the option to do hyperparameter tuning using Optuna. All of this can be done by just adjusting a configuration file. There's no need to touch the code itself. The package is available on PyPI under the Apache 2.0 license, so feel free to just use it. And there's also a version currently in development that is to be run on Kubernetes as an application standalone. If you are interested in the Kubernetes version of PROLOF or have any further questions, feel free to contact me via mail.
The DSO technical platform is a key component of the Platone concept. It allows a new type of implementation for the DMS, distribution management systems, thanks to an innovative software architecture. This is a concept we originally developed in a previous project called Sogno, but in Platone we made it grow to a mature product that is now also a project in the Linux Foundation Energy. With this architecture, we build a modern DMS as a modular systems, where each functions become a microservice, and we have a standard interface in a databus. We also offer two options of databus, one based on MQTT, another one based on Kafka, for maximum flexibility of operation. It's a key new concept that substitutes the monolithic software that were typical of old SCADA systems.
The future energy system needs flexibility. If you ask the technician, they tell you, give me prognosis and data, I control the demand side. If you ask the business people, they need marketplaces and the price to the good flexibility. If you ask the practitioner, they need a product and the proof that it works and is cost effective. In Flex community, we bring together these people. Platone has started it together with the Fever and the EdgeFlex project. Meanwhile, we have 19 projects on board and more than 200 practitioners, academia people and industry people. It will go on forever, hopefully beyond the end of these projects. The proof is in February 2024, we will have the next Flex Community Conference.
The blockchain access layer is an IoT integration platform based on blockchain technology that allows the integration of the devices coming from the physical infrastructure. It's based on blockchain technology, allowing the certification of the measurement and also the sharing of the data in a secure way using a flexibility register. Inside the flexibility register, the blockchain technology also enables a data access management, keeping the data ownership and the fingerprint of the data, allowing all the energy stakeholders interested on accessing the data to share it in a secure way.
Local flexibility market is a multi-platform system which enables distributed energy resources connected to the grid to provide flexibility services to system operators. The solution is based on a market approach and implements all the phases foreseen in ancillary services, such as procurement, planning and forecasting, and activation and settlement. The added value of this system is a market platform which guarantee unique several products and a unique register which collects all flexibility data and a smart edge device which enables customers to provide flexibility services to the grid, and blockchain technology which certifies measurements and payments.
So today I'm presenting the Avacon Local Flex Controller, which we also name ALFC. It's an energy management system for low voltage grid that is able to monitor generation and consumption to predict the residual load demand of a community and the energy demand of a community, and control small-scale flexibilities in rule-based and schedule-based control approaches. In the demonstrator, we have successfully applied different use cases and shown that the ALFC is able to apply virtual islanding, the coordination of flexibility requests, and also apply bulk-based energy supply and energy export schemes.
The state estimation tool is a real-time data processing algorithm that ensures the observability of the Mesogia pilot site of the Greek demo and has been developed within the framework of the Platone project. It essentially is a distribution system state estimator which captures the closest to reality operating state of the network. Also, it acts as a key enabler for the network tariff model that has also been built within the framework of the Platone project. The innovation related to the state estimation tool is the deployment of synchrophasors in distribution networks and the processing of both conventional and synchrophasor data.
So the key here that I'm presenting, it's about the software tools, the software architecture that we have developed in order to estimate the scalability and applicability potential of the Platone use cases into future distribution network. This framework of this key ER, we have developed a software architecture that will quantify the impact of the deployment on a large scale and on different boundary conditions of the solution tested in Platone. The scope of this, the creation of this software tool is to estimate which could be the potential and the benefits that can be triggered by the large-scale deployment of the solution tested in Platone when it will be applied in future scenarios, or when they will be applied in different network conditions characterized by different types of load, different type of generation, or different type of customers connected to the grids. The scope is to give an ex-ante evaluation of which could be the potential to deploy this solution at a larger scale.
I'm honored today on the behalf of my team at RWTH Aachen University to present to you the so-called distributed optimal power flow, which is suitable for solving optimal power flow problems for AC, DC, as well as hybrid AC-DC systems. Obviously, following the open source philosophy of the Platone project, the source code is accessible via Git and can be used by the different researchers and other interested parties. Within the Platone project, we have used this to investigate the replicability and scalability of the developed solutions within different use cases. Please feel free to refer to the website and the repository, and we would be happy to assist you with any questions that you might have. Thank you.
What I'm holding here is the last generation of our low-cost phasor measurement unit. This is a key device for the digitalization of operation of distribution system operator. It allows the conversion of measurement, analog measurement in digital data, and we can manage this data in a very flexible way thanks to the direct connection to our DSO technical platform. Managing the data is now one of our standard services that we have implemented in our Sonio architecture and allows to manage data both as phasors when we need or raw data, so that we have a very detailed information with synchronized measurement that allows us to check into the details of a transit. It's the modern and simple way to digitalize the information for the operation of the grid and integrate the results in a modern digital platform.
The Flexibility Market Platform is a blockchain-based platform that supports the creation of the flexibility market. The flexibility market is managed by the web-based platform of the market platform and allow to create intraday and day-ahead market session, allowing the participation of any kind of market participants, so TSOs, DSOs, aggregators, and customers. The blockchain technology is used for the certification of the entire processes inside the market platform, so for collecting the results and also for request and offer, and also for creating a new innovative mechanism for the incentivization of the customer using tokenization mechanism.
The light node is a very important component of the Italian demo. This is an edge device installed in the customer property. It consents to the DSO to send an activation command, and on the other end, it makes available this activation command to the flexibility asset. The light node is connected to the smart meter to read the real-time measurement, certify this measurement on blockchain, and send this measurement to the flexibility register. It is a very important device because thanks to this device, we can enable all the users in the flexibility market.
I am proudly on the behalf of the whole Platone project presenting to you the educational video series, which is basically categorized in 3 different steps. An introduction about the digitalization of modern power systems and the open source philosophy which can pave the path and accelerate our movement towards this, followed by an introduction about the Platone framework and its different components. Then in the second place we have the tutorials about the open source DSO technical platform, and last but not least we have the testimonials from the demonstrators, which all of these video series are at your disposal on our website, and we would be happy to assist you with any questions that you might have after watching the series. Thank you.
The blockchain access layer is the transparent, reliable, standard link between people and the power grids. The customer just plugs a light node at home, and it's linked immediately and automatically with the smart meter. It just sends all the measurements for the service given to the grid back to the system operator and receives the commands for the service execution. Automatically, all this data are ready for settlement for the rewarding to the customer of the service given.
Hi, I will give you an overview over the probabilistic load forecasting package, short PROLOF, that can be used in the DSO technical platform. PROLOF is a Python package based on PyTorch, which can be used to train, use, and evaluate a deep learning model specifically created for time series forecasts. The model we are using is a recurrent neural network in an encoder-decoder structure, which is quite flexible to forecasting time steps and horizons. In addition to this model, we provide a package for data pre-processing, including scaling and data encoding, and the option to do hyperparameter tuning using Optuna. All of this can be done by just adjusting a configuration file. There's no need to touch the code itself. The package is available on PyPI under the Apache 2.0 license, so feel free to just use it. And there's also a version currently in development that is to be run on Kubernetes as an application standalone. If you are interested in the Kubernetes version of Prolove or have any further questions, feel free to contact me via mail.
The DSO technical platform is a key component of the Platone concept. It allows a new type of implementation for the DMS, distribution management systems, thanks to an innovative software architecture. This is a concept we originally developed in a previous project called Sogno, but in Platone we made it grow to a mature product that is now also a project in the Linux Foundation Energy. With this architecture, we build a modern DMS as a modular systems, where each functions become a microservice, and we have a standard interface in a databus. We also offer two options of databus, one based on MQTT, another one based on Kafka, for maximum flexibility of operation. It's a key new concept that substitutes the monolithic software that were typical of old SCADA systems.
The future energy system needs flexibility. If you ask the technician, they tell you, give me prognosis and data, I control the demand side. If you ask the business people, they need marketplaces and the price to the good flexibility. If you ask the practitioner, they need a product and the proof that it works and is cost effective. In Flex community, we bring together these people. Platone has started it together with the Fever and the EdgeFlex project. Meanwhile, we have 19 projects on board and more than 200 practitioners, academia people and industry people. It will go on forever, hopefully beyond the end of these projects. The proof is in February 2024, we will have the next Flex Community Conference.
The blockchain access layer is an IoT integration platform based on blockchain technology that allows the integration of the devices coming from the physical infrastructure. It's based on blockchain technology, allowing the certification of the measurement and also the sharing of the data in a secure way using a flexibility register. Inside the flexibility register, the blockchain technology also enables a data access management, keeping the data ownership and the fingerprint of the data, allowing all the energy stakeholders interested on accessing the data to share it in a secure way.
Local flexibility market is a multi-platform system which enables distributed energy resources connected to the grid to provide flexibility services to system operators. The solution is based on a market approach and implements all the phases foreseen in ancillary services, such as procurement, planning and forecasting, and activation and settlement. The added value of this system is a market platform which guarantee unique several products and a unique register which collects all flexibility data and a smart edge device which enables customers to provide flexibility services to the grid, and blockchain technology which certifies measurements and payments.
So today I'm presenting the Avacon Local Flex Controller, which we also name ALFC. It's an energy management system for low voltage grid that is able to monitor generation and consumption to predict the residual load demand of a community and the energy demand of a community, and control small-scale flexibilities in rule-based and schedule-based control approaches. In the demonstrator, we have successfully applied different use cases and shown that the ALFC is able to apply virtual islanding, the coordination of flexibility requests, and also apply bulk-based energy supply and energy export schemes.
The state estimation tool is a real-time data processing algorithm that ensures the observability of the Mesogia pilot site of the Greek demo and has been developed within the framework of the Platone project. It essentially is a distribution system state estimator which captures the closest to reality operating state of the network. Also, it acts as a key enabler for the network tariff model that has also been built within the framework of the Platone project. The innovation related to the state estimation tool is the deployment of synchrophasors in distribution networks and the processing of both conventional and synchrophasor data.
So the key area that I'm presenting, it's about the software tools, the software architecture that we have developed in order to estimate the scalability and applicability potential of the Platone use cases into future distribution network. This framework of this key ER, we have developed a software architecture that will quantify the impact of the deployment on a large scale and on different boundary conditions of the solution tested in Platone. The scope of this, the creation of this software tool is to estimate which could be the potential and the benefits that can be triggered by the large-scale deployment of the solution tested in Platone when it will be applied in future scenarios, or when they will be applied in different network conditions characterized by different types of load, different type of generation, or different type of customers connected to the grids. The scope is to give an ex-ante evaluation of which could be the potential to deploy this solution at a larger scale.
I'm honored today on the behalf of my team at RWTH Aachen University to present to you the so-called distributed optimal power flow, which is suitable for solving optimal power flow problems for AC, DC, as well as hybrid AC-DC systems. Obviously, following the open source philosophy of the Platone project, the source code is accessible via Git and can be used by the different researchers and other interested parties. Within the Platone project, we have used this to investigate the replicability and scalability of the developed solutions within different use cases. Please feel free to refer to the website and the repository, and we would be happy to assist you with any questions that you might have. Thank you.
What I'm holding here is the last generation of our low-cost FESO measurement unit. This is a key device for the digitalization of operation of distribution system operator. It allows the conversion of measurement, analog measurement, in digital data, and we can manage this data in a very flexible way thanks to the direct connection to our DSO technical platform. Managing the data is now one of our standard services that we have implemented in our Sonio architecture and allows to manage data both as phasors when we need or raw data, so that we have a very detailed information with synchronized measurement that allows us to check into the details of a transit. It's the modern and simple way to digitalize the information for the operation of the grid and integrate the results in a modern digital platform.
The Flexibility Market Platform is a blockchain-based platform that supports the creation of the flexibility market. The flexibility market is managed by the web-based platform of the market platform and allowed to create intraday and day-ahead market session, allowing the participation of any kind of market participants, so TSOs, DSOs, aggregators, and customers. The blockchain technology is used for the certification of the entire processes inside the market platform, so for collecting the results and also for request and offer, and also for creating a new innovative mechanism for the incentivization of the customer using tokenization mechanism.
The light node is a very important component of the Italian demo. This is an edge device installed in the customer property. It consents to the DSO to send an activation command, and on the other end, it makes available this activation command to the flexibility asset. The light node is connected to the smart meter to read the real-time measurement, certify this measurement on blockchain, and send this measurement to the flexibility register. It is a very important device because thanks to this device, we can enable all the users in the flexibility market.
I am proudly on the behalf of the whole Platone project presenting to you the educational video series, which is basically categorized in 3 different steps. An introduction about the digitalization of modern power systems and the open source philosophy which can pave the path and accelerate our movement towards this, followed by an introduction about the Platone framework and its different components. Then in the second place we have the tutorials about the open source DSO technical platform, and last but not least we have the testimonials from the demonstrators, which all of these video series are at your disposal on our website, and we would be happy to assist you with any questions that you might have after watching the series. Thank you.
The blockchain access layer is the transparent, reliable, standard link between people and the power grids. The customer just plugs a light node at home, and it's linked immediately and automatically with the smart meter. It just sends all the measurements for the service given to the grid back to the system operator and receives the commands for the service execution. Automatically, all this data are ready for settlement for the rewarding to the customer of the service given.
Hi, I will give you an overview over the probabilistic load forecasting package, short PROLOF, that can be used in the DSO technical platform. PROLOF is a Python package based on PyTorch, which can be used to train, use, and evaluate a deep learning model specifically created for time series forecasts. The model we are using is a recurrent neural network in an encoder-decoder structure, which is quite flexible to forecasting time steps and horizons. In addition to this model, we provide a package for data pre-processing, including scaling and data encoding, and the option to do hyperparameter tuning using Optuner. All of this can be done by just adjusting a configuration file. There's no need to touch the code itself. The package is available on PyPI under the Apache 2.0 license, so feel free to just use it. And there's also a version currently in development that is to be run on Kubernetes as an application standalone. If you are interested in the Kubernetes version of Proloaf or have any further questions, feel free to contact me via mail.
The DSO technical platform is a key component of the Platone concept. It allows a new type of implementation for the DMS, distribution management systems, thanks to an innovative software architecture. This is a concept we originally developed in a previous project called Sogno, but in Platone we made it grow to a mature product that is now also a project in the Linux Foundation Energy. With this architecture, we build a modern DMS as a modular systems, where each functions become a microservice, and we have a standard interface in a databus. We also offer two options of databus, one based on MQTT, another one based on Kafka, for maximum flexibility of operation. It's a key new concept that substitutes the monolithic software that were typical of old SCADA systems.
The future energy system needs flexibility. If you ask the technician, they tell you, give me prognosis and data, I control the demand side. If you ask the business people, they need marketplaces and the price to the good flexibility. If you ask the practitioner, they need a product and the proof that it works and is cost effective. In Flex community, we bring together these people. Platone has started it together with the Fever and the EdgeFlex project. Meanwhile, we have 19 projects on board and more than 200 practitioners, academia people and industry people. It will go on forever, hopefully beyond the end of these projects. The proof is in February 2024, we will have the next Flex Community Conference.
The blockchain access layer is an IoT integration platform based on blockchain technology that allows the integration of the devices coming from the physical infrastructure. It's based on blockchain technology, allowing the certification of the measurement and also the sharing of the data in a secure way using a flexibility register. Inside the flexibility register, the blockchain technology also enables a data access management, keeping the data ownership and the fingerprint of the data, allowing all the energy stakeholders interested on accessing the data to share it in a secure way.
Local flexibility market is a multi-platform system which enables distributed energy resources connected to the grid to provide flexibility services to system operators. The solution is based on a market approach and implements all the phases foreseen in ancillary services, such as procurement, planning and forecasting, and activation and settlement. The added value of this system is a market platform which guarantee unique several products and a unique register which collects all flexibility data and a smart edge device which enables customers to provide flexibility services to the grid, and blockchain technology which certifies measurements and payments.
So today I'm presenting the Avacon Local Flex Controller, which we also name ALFC. It's an energy management system for low voltage grid that is able to monitor generation and consumption to predict the residual load demand of a community and the energy demand of a community, and control small-scale flexibilities in rule-based and schedule-based control approaches. In the demonstrator, we have successfully applied different use cases and shown that the ALC is able to apply virtual islanding, the coordination of flexibility requests, and also apply bulk-based energy supply and energy export schemes.
The state estimation tool is a real-time data processing algorithm that ensures the observability of the Mesogia pilot site of the Greek demo and has been developed within the framework of the Platone project. It essentially is a distribution system state estimator which captures the closest to reality operating state of the network. Also, it acts as a key enabler for the network tariff model that has also been built within the framework of the Platone project. The innovation related to the state estimation tool is the deployment of synchrophasors in distribution networks and the processing of both conventional and synchrophasor data.
So the key here that I'm presenting, it's about the software tools, the software architecture that we have developed in order to estimate the scalability and applicability potential of the Platone use cases into future distribution network. This framework of this key here, we have developed a software architecture that will quantify the impact of the deployment on a large scale and on different boundary conditions of the solution tested in Platone. The scope of this, the creation of this software tool is to estimate which could be the potential and the benefits that can be triggered by the large-scale deployment of the solution tested in Platone when it will be applied in future scenarios, or when they will be applied in different network conditions characterized by different types of load, different type of generation, or different type of customers connected to the grids. The scope is to give an ex-ante evaluation of which could be the potential to deploy this solution at a larger scale.
I'm honored today on the behalf of my team at RWTH Aachen University to present to you the so-called distributed optimal power flow, which is suitable for solving optimal power flow problems for AC, DC, as well as hybrid AC-DC systems. Obviously, following the open source philosophy of the Platone project, the source code is accessible via Git and can be used by the different researchers and other interested parties. Within the Platone project, we have used this to investigate the replicability and scalability of the developed solutions within different use cases. Please feel free to refer to the website and the repository, and we would be happy to assist you with any questions that you might have. Thank you.
What I'm holding here is the last generation of our low-cost phasor measurement unit. This is a key device for the digitalization of operation of distribution system operator. It allows the conversion of measurement, analog measurement, in digital data, and we can manage this data in a very flexible way thanks to the direct connection to our DSO technical platform. Managing the data is now one of our standard services that we have implemented in our Sonio architecture, and allows to manage data both as phasors when we need or raw data, so that we have a very detailed information with synchronized measurement that allows us to check into the details of a transient. It's the modern and simple way to digitalize the information for the operation of the grid and integrate the results in a modern digital platform.
Flexibility Market Platform is a blockchain-based platform that supports the creation of the flexibility market. The flexibility market is managed by the web-based platform of the market platform and allowed to create intraday and day-ahead market session, allowing the participation of any kind of market participants, so TSOs, DSOs, aggregators, and customers. The blockchain technology is used for the certification of the entire processes inside the market platform, so for collecting the results and also for request and offer, and also for creating a new innovative mechanism for the incentivization of the customer using tokenization mechanism.
The light node is a very important component of the Italian demo. This is an edge device installed in the customer property. It consents to the DSO to send an activation command, and on the other end, it makes available this activation command to the flexibility asset. The light node is connected to the smart meter to read the real-time measurement, certify this measurement on blockchain, and send this measurement to the flexibility register. It is a very important device because thanks to this device, we can enable all the users in the flexibility market.
I am proudly on the behalf of the whole Platone project presenting to you the educational video series, which is basically categorized in 3 different steps. An introduction about the digitalization of modern power systems and the open source philosophy which can pave the path and accelerate our movement towards this, followed by an introduction about the Platone framework and its different components. Then in the second place we have the tutorials about the open source DSO technical platform, and last but not least we have the testimonials from the demonstrators, which all of these video series are at your disposal on our website, and we would be happy to assist you with any questions that you might have after watching the series. Thank you.
The blockchain access layer is the transparent, reliable, standard link between people and the power grids. The customer just plugs a light node at home, and it's linked immediately and automatically with the smart meter. It just sends all the measurements for the service given to the grid back to the system operator and receives the commands for the service execution. Automatically, all this data are ready for settlement for the rewarding to the customer of the service given.
Hi, I will give you an overview over the probabilistic load forecasting package, short PROLOF, that can be used in the DSO technical platform. PROLOF is a Python package based on PyTorch, which can be used to train, use, and evaluate a deep learning model specifically created for time series forecasts. The model we are using is a recurrent neural network in an encoder-decoder structure, which is quite flexible to forecasting time steps and horizons. In addition to this model, we provide a package for data pre-processing, including scaling and data encoding, and the option to do hyperparameter tuning using Optuna. All of this can be done by just adjusting a configuration file. There's no need to touch the code itself. The package is available on PyPI under the Apache 2.0 license, so feel free to just use it. And there's also a version currently in development that is to be run on Kubernetes as an application standalone. If you are interested in the Kubernetes version of PROLOF or have any further questions, feel free to contact me via mail.
The DSO technical platform is a key component of the Platone concept. It allows a new type of implementation for the DMS, distribution management systems, thanks to an innovative software architecture. This is a concept we originally developed in a previous project called Sogno, but in Platone we made it grow to a mature product that is now also a project in the Linux Foundation Energy. With this architecture, we build a modern DMS as a modular systems, where each functions become a microservice, and we have a standard interface in a databus. We also offer two options of databus, one based on MQTT, another one based on Kafka, for maximum flexibility of operation. It's a key new concept that substitutes the monolithic software that were typical of old SCADA systems.
The future energy system needs flexibility. If you ask the technician, they tell you, give me prognosis and data, I control the demand side. If you ask the business people, they need marketplaces and the price to the good flexibility. If you ask the practitioner, they need a product and the proof that it works and is cost effective. In Flex community, we bring together these people. Platone has started it together with the Fever and the EdgeFlex project. Meanwhile, we have 19 projects on board and more than 200 practitioners, academia people and industry people. It will go on forever, hopefully beyond the end of these projects. The proof is in February 2024, we will have the next Flex Community Conference.
The blockchain access layer is an IoT integration platform based on blockchain technology that allows the integration of the devices coming from the physical infrastructure. It's based on blockchain technology, allowing the certification of the measurement and also the sharing of the data in a secure way using a flexibility register. Inside the flexibility register, the blockchain technology also enables a data access management, keeping the data ownership and the fingerprint of the data, allowing all the energy stakeholders interested on accessing the data to share it in a secure way.
Local flexibility market is a multi-platform system which enables distributed energy resources connected to the grid to provide flexibility services to system operators. The solution is based on a market approach and implements all the phases foreseen in ancillary services, such as procurement, planning and forecasting, and activation and settlement. The added value of this system is a market platform which guarantee unique several products and a unique register which collects all flexibility data and a smart edge device which enables customers to provide flexibility services to the grid, and blockchain technology which certifies measurements and payments.
So today I'm presenting the Avacon Local Flex Controller, which we also name ALFC. It's an energy management system for low voltage grid that is able to monitor generation and consumption to predict the residual load demand of a community and the energy demand of a community, and control small-scale flexibilities in rule-based and schedule-based control approaches. In the demonstrator, we have successfully applied different use cases and shown that the ALFC is able to apply virtual islanding, the coordination of flexibility requests, and also apply bulk-based energy supply and energy export schemes.
The state estimation tool is a real-time data processing algorithm that ensures the observability of the Mesogia pilot site of the Greek demo and has been developed within the framework of the Platone project. It essentially is a distribution system state estimator which captures the closest to reality operating state of the network. Also, it acts as a key enabler for the network tariff model that has also been built within the framework of the Platone project. The innovation related to the state estimation tool is the deployment of synchrophasors in distribution networks and the processing of both conventional and synchrophasor data.
So the key here that I'm presenting, it's about the software tools, the software architecture that we have developed in order to estimate the scalability and applicability potential of the Platone use cases into future distribution network. This framework of this key ER, we have developed a software architecture that will quantify the impact of the deployment on a large scale and on different boundary conditions of the solution tested in Platone. The scope of this, the creation of this software tool is to estimate which could be the potential and the benefits that can be triggered by the large-scale deployment of the solution tested in Platone when it will be applied in future scenarios or when they will be applied in different network conditions characterized by different types of load, different type of generation, or different type of customers connected to the grids. The scope is to give an ex-ante evaluation of which could be the potential to deploy this solution at a larger scale.
I'm honored today on the behalf of my team at RWTH Aachen University to present to you the so-called distributed optimal power flow, which is suitable for solving optimal power flow problems for AC, DC, as well as hybrid AC-DC systems. Obviously, following the open source philosophy of the Platone project, the source code is accessible via Git and can be used by the different researchers and other interested parties. Within the Platone project, we have used this to investigate the replicability and scalability of the developed solutions within different use cases. Please feel free to refer to the website and the repository, and we would be happy to assist you with any questions that you might have. Thank you.
What I'm holding here is the last generation of our low-cost phasor measurement unit. This is a key device for the digitalization of operation of distribution system operator. It allows the conversion of measurement, analog measurement, in digital data, and we can manage this data in a very flexible way thanks to the direct connection to our DSO technical platform. Managing the data is now one of our standard services that we have implemented in our Sonio architecture and allows to manage data both as phasors when we need or raw data, so that we have a very detailed information with synchronized measurement that allows us to check into the details of a transient. It's the modern and simple way to digitalize the information for the operation of the grid and integrate the results in a modern digital platform.
The Flexibility Market Platform is a blockchain-based platform that supports the creation of the flexibility market. The flexibility market is managed by the web-based platform of the market platform and allows to create intraday and day-ahead market session, allowing the participation of any kind of market participants, so TSOs, DSOs, aggregators, and customers. The blockchain technology is used for the certification of the entire processes inside the market platform, so for collecting the results and also for request and offer, and also for creating a new innovative mechanism for the incentivization of the customer using tokenization mechanism.
light node is a very important component of the Italian demo. This is an edge device installed in the customer property. It consents to the DSO to send an activation command, and on the other end, it makes available this activation command to the flexibility asset. The light node is connected to the smart meter to read the real-time measurement, certify this measurement on blockchain, and send this measurement to the flexibility register. It is a very important device because thanks to this device, we can enable all the users in the flexibility market.
I am proudly on the behalf of the whole Platone project presenting to you the educational video series, which is basically categorized in 3 different steps. An introduction about the digitalization of modern power systems and the open source philosophy which can pave the path and accelerate our movement towards this, followed by an introduction about the Platone framework and its different components. Then in the second place we have the tutorials about the open source DSO technical platform, and last but not least we have the testimonials from the demonstrators, which all of these video series are at your disposal on our website, and we would be happy to assist you with any questions that you might have after watching the series. Thank you.
The blockchain access layer is the transparent, reliable, standard link between people and the power grids. The customer just plugs a light node at home, and it is linked immediately and automatically with the smart meter. It just sends all the measurements for the service given to the grid back to the system operator and receives the commands for the service execution. Automatically, all this data are ready for settlement for the rewarding to the customer of the service given.
Hi, I will give you an overview over the probabilistic load forecasting package, short PROLOF, that can be used in the DSO technical platform. PROLOF is a Python package based on PyTorch, which can be used to train, use, and evaluate a deep learning model specifically created for time series forecasts. The model we are using is a recurrent neural network in an encoder-decoder structure, which is quite flexible to forecasting time steps and horizons. In addition to this model, we provide a package for data pre-processing, including scaling and data encoding, and the option to do hyperparameter tuning using Optuna. All of this can be done by just adjusting a configuration file. There's no need to touch the code itself. The package is available on PyPI under the Apache 2.0 license, so feel free to just use it. And there's also a version currently in development that is to be run on Kubernetes as an application standalone. If you are interested in the Kubernetes version of PROLOF or have any further questions, feel free to contact me via mail.
The DSO technical platform is a key component of the Platone concept. It allows a new type of implementation for the DMS, distribution management systems, thanks to an innovative software architecture. This is a concept we originally developed in a previous project called Sogno, but in Platone we made it grow to a mature product that is now also a project in the Linux Foundation Energy. With this architecture, we build a modern DMS as a modular systems, where each functions become a microservice, and we have a standard interface in a databus. We also offer 2 options of databus, one based on MQTT another one based on Kafka for maximum flexibility of operation. It's a key new concept that substitutes the monolithic software that were typical of old SCADA systems.
Welcome back. Hello, hello. Welcome back after the lunch break to the second part of the final conference. I can see happy faces, refreshed faces. I think we all deserve the break. And before we come to the next session, I would like to sum up a little bit what happened in the morning, at least part of it. So we have heard about DSOs and their challenges and how Platone and its solutions tackle some of these challenges. We have heard about the key exploited results and, in general, the open source approach of them and why open source is important. And we've heard about the importance of demonstration projects in general and how regulation and innovation should be thought together. Now, we will have another session on the importance of demonstration projects. And this session will be held by Jens Blei. We pre-recorded the session, so we just played for everybody, for the audience online, but also for the audience here on site. And before we start that, I would like to just give 2-3 sentences about Jens Blei. He started as a police officer actually in Bremen and later achieved a degree in public administration. He held various positions within the police force and Ministry of the Interior, and currently he is serving as a mayor of Twistringen. We heard there was a trial site there. Twistringen, according to Wikipedia, is a city with 12,797 inhabitants, so not the biggest, but also maybe not the smallest city. And he's mayor since 2019. And I was also told that he is a passionate cyclist. So with this, I would hand over to him and his pre-recorded session.
Dear participants, it's a great pleasure for me to be able to speak to you today. Unfortunately, it was not possible for me to be with you in person today. However, I have been given the opportunity to convey a message to you, and for this I would like to thank Benjamin Petters. Thanks for that, Benjamin. I'm the mayor of the city of Twisting, and my name is Jens Blei. Twisting is a small town in Lower Saxony in the district of Diepholz. And the city of Twisting has about 13,000 inhabitants. Our companies belong to the middle class, and there's a clear sense among our companies that they want to be more independent of the energy supply in the future. The city of Twisting has already adopted measures in advance of the existing energy crisis, and in the new residential areas it is now forbidden to get the energy through a gas pipeline. Since the energy crisis, citizens accepted, and according to that, the crisis should not be seen as a crisis. It's a great opportunity to create the energy transition. In the city of Twisting, more energy is currently produced than consumed. And we intend to push ahead with the expansion of renewable energies. And thus we will triple our energy productions by 2028. And the focus is on wind energy generations. The city and companies will generate their own electricities with photovoltaic systems. And it's a great opportunity to be able to use the local produced electricity local as well. But we need intelligent neighborhood solutions. Locally generated electricity is fed into the grid. Wind turbines have to perpetually shut down, and the grid cannot transport the electricity. And therefore it's necessary to find better solutions. The citizens do not understand why wind turbines are shut down at that time. The city of Triesting is pleased to be able to participate in the great European project Platone. And I would like to thank Ion Avacon for the opportunity, especially Hermann Carnebo. And when Hermann asked whether we want to make Triesting European, I didn't have think twice. However, another aspect in particular is more important to me. I'm interested in solution on how we can better supply neighborhoods with their own energy. And the Platone projects shows such solutions. Currently, the photovoltaic power is supplied directly to the grid. On very sunny days, there's a lot of electricity. At night or on days when the sun is weak, there's no. And the Platone stores the electricity. And on days without the sun, the electricity is returned. And in this way, local generated power and energy is used, and the power grid is relieved. The discussions with the citizens have shown how great the interest is. We quickly found participants for the project, and we want to find solution on how to use the local electricity. And in doing so, we find that the laws do not fit. And with the end of the Platone project, we are not allowed to use the battery storage. And battery storage ensures better use of local electricity and relieves the burden on the power grids. With the battery storage, we would like to develop a constructions area in the future. And this is a hope. We hope to get new laws. The acceptance of the citizens and companies for the energy transition is very high at the meanwhile. And the time has come to take the most important steps for the new energy age. And the great Platone project is forward-looking for me. We hope to continue the project and the possibility to use battery storage in the future. And finally, I want to thank you for allowing me to speak about my opinion on the energy transition. And for me, the Platone project is a great contribution to a new energy area. I wish you a great as well as interesting event with many interesting results and preparatory courses for the necessary energy transition. Thanks to you. Bye.
Okay, we are a little bit ahead of our time, which is not necessarily bad. And in the next session, we will have a combination of things I saw. It was going to be a panel and short testimonials, if I'm not mistaken. This session is going to be moderated by my dear colleague Selene Liverani, who is a senior technology and projects advisor at EDSO. And Selene, please join me on the stage and then introduce your panelists. Have fun.
Thank you very much, Andreas, and thank you, everyone. As Andreas mentioned, I'm not going to be the only one on stage right now, and I have the pleasure to invite with me 4 speakers and project partners that really, over the past 4 years, worked for the core on-field and testing activities of Platone in our 3 demos in Italy, Germany, and Greece. So I invite to come with me Gabriele Fedele, technical coordinator of the Italian demo of Platone, Gianluca Nori from Acea Energia, service provider in the Italian demo, Benjamin Petters from Avacon Net, German demo leader, and last but not least, Froso Gralista from Hedno, member of the Greek demo team. Okay, so before we start our panel discussion, we would like to set the scene with some pitches from our demos. So our speakers will briefly present to you their journey. They will start by introducing how the demo started and what challenges they needed to address and what needs they needed to look into. And then they will guide you through everything that happened until today. We start with Gabriele from Areti, who's going to speak about the Italian demo.
Thank you. Okay. Can you hear me? Thank you, Selene, for giving me the floor. For me, it's a very pleasure to talk about our experience on the implementation that we have done in Italy. So I prepared just a few slides to talk about our experience. First, in this first slide, we can see what is the aim of our pilot. In detail, we would like to create a local flexibility market to allow the DSO and TSO to acquire flexibility from the distribution energy resources connecting medium and especially in low voltage grids. After we report 5 key points about our experience. First, it's about the kind of market that we have implemented, that is a non-discriminatory and open market that use also the technology of blockchain to certify the exchange about the data and transaction. On the other end, we implement a solution to promote a massive involvement of the customer in low voltage, connecting low voltage to our grid. The kind of issue that we face during the project is the congestion, and about also the kind of market that we have implemented. It's a common DSO TSO market, because we think that with the energy transition we can have a lot of flexibility resources in medium and low voltage, and we can have a great liquidity of the market. So we think that in this condition, the common DSO and TSO market, we could have the best solution to unlock the flexibility from the grid from the distribution grid. And in the end, we have implemented a kind of traffic light mechanism to avoid everything to avoid the possible constraints that the providing of flexibility could be caused on our grids. After this is some key points from the technical point of view. On the right of this slide, there is the architecture that we have implemented in the Italian demo. you can see the platform that we use it in the project, and this platform resume the more important process that usually we meet during the flexibility market. On the other hand, there is another important activity that we have implemented in the project, that is the customer engagement. After my colleague Gianluca talk about this experience, but for our point of view, the customer is a very important part of our demo, because they are involved in all the tests that we are facing, and they give to us the feedback to improve the solution. At the end, about the installation, we have installed in the customer property some components to increase the flexibility of the end users. These components are a storage and a device that enable the end users in the flexibility market. This device is a key exploitation results that we can see also in the other room. That is this device is the light node. At the end, this is the main results that we report here. We have implemented the local flexibility market with all the components, and now we are using this approach also in other projects. For instance, we use this approach in another European project as Be Flexible and Flow, but also, as I said during the presentation of this morning, in Romflex, that is an Italian project promoted by Italian NRA. About the involvement of the users, we have an important outcome, because we have increased the awareness of the end users on the flexibility opportunities for the end users. And after we have an interview with the customer that take part in the project. For the involvement of the end user, we have defined a device, named the light node, that standardizes the interface with the system operators and with the flexibility register, a unique database that collects the measurement for the flexibility market. In the end, we highlight one of the most important things that we would like to promote with our demo, the involvement of the low voltage users, because we think that, especially in a urban area, a massive involvement of the users can unlock a great volume of the flexibility that we can have in this context. Okay, for the moment, thank you.
Thank you very much, Gabriele, and thanks for highlighting already some of the steps ahead for Areti that we're going to discuss later for sure. It's now the turn of the German demo, so Benjamin from Avacon, please.
Yes, thank you. Yeah, so today, like in the morning, I was already presenting, or I gave some insights on the key exploitable result, but now I would like to take the opportunity to give you some better insights on our motivation. So what you see here on the left side is basically a picture of the municipality in which where the demonstrator have implemented, and the picture quite well visualize the situation in our grid. The distribution grid which we are operating is rather rural. We have a lot of renewable generators. Since several years. It's nothing new, but now we see that in the low voltage grid there's also like a really rising number of PV generators operated by private customers. Most of these assets are operated within battery storage for improving PV self-consumption. And in future, we expect an increase of flexible loads coming with the electric chargers for electric vehicles. And what we see now, especially in our trial, is that we see
change, a transition from demand-driven low voltage grids to generation-driven low voltage grids. And these communities already today display a very high surplus of generation. They are causing very high export power peaks, and the grid has to handle these high power peaks and also amounts of generated energy. So the objective of our demonstrator is basically to look to what extent can these small-scale flexibilities integrated into a DSO control scheme that benefits the customer, but also the grid operator by applying different control schemes, which we have implemented with the help of the DSO technical platform and the expertise that is also provided by RWTH Aachen. For this purpose, we have implemented an energy management system that applies different use cases. And we have demonstrated it in the field, so in a low voltage community that has a smart secondary substation which provides real-time data or soft real-time data about the residual load demand. Ah, okay, better now. And we have involved several customers providing flexibility from battery storage systems. We have added a large-scale battery energy storage system that provides additional flexibility, which simulates future storage capacities located in the households. And some sensors in the field providing additional measurement data for control. The services, what the energy management system is implementing are basically monitoring features, forecasting features to predict generation and consumption, and based on these information and data, we are controlling flexibilities with a balancing algorithm that is using different approaches, like a rule-based or schedule-based approach that uses forecast services and optimization features. And the use case that we have applied, as I mentioned, it shall have a benefit for the customer and for the DSO. In the first use case, we were applying a virtual islanding balancing approach at which the community is enabled to improve their local self-consumption. And meanwhile, this control scheme also reduces peak loads in the low voltage and medium voltage grid. We also wanted to show that the scheme is able to coordinate the request of flexibility activation coming from different market participants like DSO, TSO, aggregators, or any flexibility market participant. And in this control scheme, we also wanted to apply a bulk-based energy supply, meaning for example, we have like a generation-driven low voltage grid, which displays a lot of surplus of generation as shown in the first slide. We want to predict these surplus of generation, use and control batteries to export the surplus of power at suitable times for the medium voltage grid. So this use case is a bit over the edge of the current regulation, but basically we wanted to show that if there is like more freedom to control flexibility, we wanted to investigate what grid positive effect would be possible.
Thank you very much, Benjamin, for the overview of the results of the German demo. We move on to the last pitch presentation, also for the Greek demo.
Thank you. Thank you. So, hello from me as well. I'm Froso Kralista. I'm an engineer for Hedno and I'm a member of the Greek demo team. It's really nice being here with everyone at the conclusion of our project. For us in Hedno is the distribution system operator of Greece. It handles a very complex grid with more than 8 million customers with a very complex geographical distribution, both the mainland and islands, with high mountains and fields, with rural and urban areas, with also big climatic differences. And all of those challenges are compounded also by the high penetration of renewable energy sources and the outlook that we have for the future with the integration of more renewable power. And so for Hedno, Platone offers a solution of unlocking flexibility by applying the scenario of variable distribution use of system tariffs, as our colleague Panagiotis has already explained. In order to deploy and to utilize the variable tariffs, we need to have a very good observability of the grid. And this is then when where the state estimation tool that has also been referred to by Themis comes into play. So these are the two tools that have been utilized by the Greek demo. So the Greek demo comprises of Hedno and our colleagues from the NTUA. In very short, because my colleagues already explained about those key exploitable results, what we have been able to accomplish with Platone is via the state estimation tool and in the demo area that is in the Mesogia area in Athens, in Attiki region, we have been able to have a near real-time view of the grid state. This is in compound with using conventional measurements from SCADA, for example, or for smart meters. And also we have deployed 5 of the synchrophasor measurement units that have been developed by the RVTH. And this concept has been validated with real data. And then the result that we get from the state estimation tool has been used as an input for the deployment of the variable distribution use of system tariffs algorithm. And we can deduce that by motivating the customers to change their consumption profiles via the variable tariffs, we can reduce a lot of congestion in the system and also to postpone the need for costly reinforcements to the grid, especially in view of the increased renewable energy sources penetration. So, where is the, what's happening? Oh, sorry. I went back. So, as the project concludes, we have built a very good know-how. First of all, in terms of the installation of the PMU, of the SMUs, because this is a complex undertaking for a DSO with the size of Hedno. So we have built a lot of, we have gathered a lot of lessons learned on that step. We have also seen how important it is to have the data harmonization in order to go into large-scale deployment of the algorithms and the platforms that Platone proposes. A very useful also conclusion is that the solutions that have been developed in Platone can be scalable on a larger field in Hedno. And there is now a proposal to create some regulatory sandboxes in Greece. So if it would be possible, then we could also test that in such an environment. And also the tool of the variable distribution use of system tariffs is really important because in a future consultation with the regulatory authority, it can be used by Hedno in view also of the recent change that has happened in Greece concerning the use of system tariffs that went from volumetric to according to peak contracted power. This also creates a larger burden for the consumer, so the proposal of Platone could be used in a future scenario to create a new reality about that. Thank you very much.
Thank you very much, Froso. Now we have a complete full picture of the demonstrators of Platone. And I think we can move on to our panel discussion. But before that, we're going to bring on screen again the Slido QR code, because I would like to invite already from now the audience online to start posting their questions in the Q&A box. We will have some time in the end to direct them to the speakers. Also for the on-site participants, if you're not shy, you will have the chance to raise your hand and ask directly. I will also launch a couple of Slido polls, so I really invite the audience to scan the QR and participate in them. And I, in fact, start with the very first poll I have prepared for you that should now come on stage. I would like to know from you what are the top challenges you think that actors in the energy system will need to face over the next 10 years. And on this note, I ask my first question, Froso, this is for you. You represent HEDNO, the Greek DSO. So I would like to know, how do you see the roles and responsibilities of DSOs changing over the next 10 years? And how do you think your experience in the Platone project will support HEDNO in overcoming and facing some of these changes?
That's a very good question, Selena. Thank you for that. So, as I already explained, HEDNO is a very big DSO and it's very centralized. So, in the future, with increasing share of renewable energy sources and also the increased need for digitalization, I think that not only HEDNO, but all other DSOs need to be more adapted to deploying novel technologies, to also progress in having advanced observability of the grids. And I think that the tools that Platone has developed are a very, very useful portfolio for DSOs. Already from our side, from HEDNO, we foresee that they could be used as discussion points in future regulatory change.
Thank you, Froso, for your answer. I will now turn to Gabriele, maybe to complement it. You, on the other hand, you represent the DSO of the metropolitan area of Rome, Areti. So I would like to know from your perspectives, what are going to be the biggest challenges that your DSO will face over the next years? And how do you think the validated solutions from the Platone project will support you in that?
Okay. As just in the morning, the CEO of Areti talked about what is the future for our grid in the next years. We wait a great increase of the electrical load and distribution generation on our grid. So to face this change of paradigm, we have to implement a new rule of the DSO. This rule could be divided into parts. From one side, we have to enable the distribution energy resources, connecting medium and low voltage, to provide flexibility to the global market. And on the other end, as DSO, we have to use these resources to solve the local grid issues. So this is the two main roles that we have to implement in the next years to help the energy transition on the distribution on grid. About the rule of about the Platone and these two aspects, we think that in Platone we have faced these two aspects, designing a local market that can use by the DSO, but also by the TSO in a common way to acquire these flexibility resources. So we think that this is the main activity, but we know that there are also a lot of challenge that we have to again to face in the next years, to clarify what is the right model to coordinate TSO and DSO or other things about the defining of a product. But at the moment, for the next years, I think that this new role of the DSO is a very crucial for all the DSO, not only for the urban area, but for every kind of DSO in Europe.
Thank you very much, Gabriele. And I see the audience is also pointing at some of the topics we have already touched upon, digitalization, cooperation among system stakeholders, but are also introducing some very interesting points maybe for later. But now that we've looked at DSOs, we have to say that DSOs are not the only actor in the energy system that is experiencing an evolution in their role. And especially with the recent changes in the EU regulatory framework, there is an actor that is becoming increasingly interesting, the one of flexibility service provider, or FSP. So Gianluca, because Acea Energia and Platone cover the role of aggregator or FSP, what can you tell us about the role that FSPs have in the establishment of local flexibility markets, and how do you see this role fitting in the current electricity market context? But also, what are some of the enablers and challenges that are still there for their participation in the market?
Yes, thank you, Selene. And thanks to the DSO for the organization. If I can, I take a step back to explain what is the context where this new role born, because as you have said, we are facing some movement on the regulatory framework. Because of maybe before Marco Baron said something about that, but we come from 40 years of such a mess, from the pandemic first, after the energy price crisis with the war, and now we are facing also a consumption crisis. So in 4 years of the project, the word we used to know, it no longer exists. So also the transformation that we once saw as pure innovation now becomes extremely relevant to foster the energy transition. So this is the context where the new role of the DSO, but also some new role, such as the aggregators, born and growth in relevance. Just to know, in Italy, in 2022, we are facing an increase of 20% of resolution issues by the regulatory electricity market regulatory. So this is a extremely important point, and if this is not enough, in last year we with the so-called eco bonus, we see an installation of 1 gigawatts of distributed storage. And the point of generation in the Italian territory exceed now 1 million. So in this context, I think it's important to highlight the crucial role of an actor who can aggregate the resources, manage and optimize, also compliant with the needs of the network. And but not only that, because we have said something before, the attention on the customer engagement, because the aggregator is the touch point of the end user with all the market operators, and it's necessary that a figure like the aggregator, that is the entry point of end user, is capable to make a complex concept such as the flexibility affordable to the most, I think, no? So this is, I think, the two pillars of the role of the aggregators, the management and optimization of theirs, and the customer engagement. On that, related to these issues, we have some constraints, some barriers we are facing also in Platone. For example, but not only in Platone, because we know the pilot project in Italy, some pilot project, for example, the UVAM. So is the financial aspect, because now we are facing a delicate moment also in the financial world. And it's difficult to think that one market operator like the aggregators can face some important investment like software, like platform, but sometimes also for the device, for the field devices. alone. So these issues can be passed, for example, socializing the investment. And also in the last European consultation that closed a few months ago, the European Commission asked us to socializing the spending about with all the market participants about the market of flexibility. At the same, for example, through some financial contract mechanism. So this is the first, I think, the first barriers. The second barrier is related on the second pillars, the customer engagement. And I think we can speak about that in a few minutes. But I want to conclude saying that overcoming these barriers, we can reach some common goals, because we open the market liquidity of flexibility market, and we can also fostering, obviously, the energy transition.
Thank you very much, Gianluca, for really highlighting all the potential that there is around this figure of FSPs, but also the fact that we still need to do quite some work and overcome some barriers. You also mentioned the buzzword of my next question, which is also appearing over there in the cloud, on customer engagement. And I'm in fact stopping this poll and starting next one, because one of the key objectives of Platone was also to really improve customer engagement and putting user at the center of the solutions we were going to develop. And so my question for the audience is, in your opinion, how can we ensure user empowerment and strengthen their role in the energy transition? But before I leave the word to the speakers, I propose to actually hear from one of the users of the Platone demo. So we are going to launch right now a short video that we have prepared together with one of the users of the Italian demo of Platone that I'm calling on stage now, on screen now.
So my name is Simona, and I live in Rome in an apartment with my family. And I was involved in the Platone project through a colleague. I'm an academic. I teach in the School of Architecture. So perhaps this is a peculiar role that I cover because I'm already interested and open to this kind of experimentation. And this explains also the reasons for which I was very happy to join the Platone project. Before the beginning of the project, I had a pretty broad knowledge about energy consumption, as it deals with my everyday life and work. But taking part in the project has, of course, broadened very much my knowledge, especially about the awareness in energy consumption. During the project, I was involved in various customer engagement activities. Actually, a focus of the whole experience was the use of the application Flexibili, which allowed me to monitor the installations with which my apartment is equipped. And the experience has been very, very interesting and enlightening, especially about the flexibility that a consumer can have in using the installations and using electricity. So the simulations about the flexibility market were also very important, and these probably have been the most interesting learning part of my experience, which actually have proved to me as an individual and to my family that it is possible to reduce the carbon footprint and to have some kind of role in a lighter energy consumption. So in my opinion, there are very important concrete benefits in using electricity with great awareness. Of course, there are economic benefits which must be, but there is also a side which deals with the education of each individual in using energy and in being flexible in the use of this energy. And also what is important is to be updated with incentives and with the technology that we can use, also the digital technologies that we can use to make our flexibility better and to improve it.
So I was actually personally involved in the recording of this video together with Professor Simona Salvo, and I was very positively surprised by how involved and knowledgeable she is about even some of the most technical aspects of the demo. So Gianluca, I'm getting back to you because as from ACEA, you were also responsible of customer engagement activities in the Italian demo. So what was your experience? What challenges did you encounter in the customer engagement process? But also, what are the lessons that you've learned from it?
Yes, thank you.
And sorry, but I think Gianluca might have a couple of slides to show while he's talking about this, so...
Yes. Thank you. Take in mind that Simona is engaged 4 years ago, so this is the reason why technical. Yeah, sure. So, as you said, ACEA Energia is the responsible in the Italian demo of the customer engagement. We have done some good job in collaboration with Baum, with BIP, and with Areti for the customer engagement. In the slide, you can see some results we have from the customer engagement, but I would like to say something about the strategy, because we have some meet with Baum for the preparatory steps, where we decide to use a user-centric design. So to put the user at the center of the customer engagement, to have some feedback for the needs, for the expectation on the participation of the project. So this is the strategy, and we organized 2 workshops, as you can see in the slide. 2 workshops, one aimed to the key stakeholders, so industries or other FSP, and one dedicated to the end users. In particular, the second, dedicated to the end users, we organized 2 sessions, one informative and one interactive. And in the informative session, we have the possibility to explain a little bit the mechanism of the flexibility market. Also the impact on the daily life, because maybe before someone say something about that, but the impact could be important on the life of the end users, and some needs to have in mind for the second session, the interactive one. In the interactive session, we design all the value chain of the flexibility market for the end user, from the point of view of the end users. We have a gamification of the flexibility market of Platone, so all the participants plays a role of the flexibility market. And we have some focus group to underline the remuneration aspect of the end user. So this is what we have done. We present to the engaged user like Simona in a second session, an informative session. Also the app Flexibili we develop in the Italian demo is the application with the end user can entry in the energy in the flexibility market. But let me speak about a little bit of the results of the customer engagement. That is the core of the of the answer, I think. This is a fact sheet with what we have done after the workshop, where you can find all also the main site of the workshop. Sure, as Simona said before, the raising awareness of the energy consumption, not the flexibility, but energy consumption is the first step towards we have to raising the awareness of the end users. The aggregators need to support local energy communities. This also is a key point for me. But we have to say that the energy community, the knowledge of the end users on energy communities is higher than the flexibility matters. The flexibility can be used as a means of exchange of additional services, like for other market participants, like DSO we have said before, and the efforts can be addressed to minimize the impact of flexibility services on daily life. So the smart plug and the home devices are unavoidable tools. Saying that, I conclude that saying that the real lesson learned of the customer engagement is the strong need to raising awareness of the end users. But in this, the aggregators can be alone, I think. I mean, all the market participants can divide the efforts, for example, through the marketing channel or the social media, to raising the awareness of what is the flexibility market, what is the potential. Also sharing the knowledge about the possibility to bring some benefits both to the system and to the singles too.
Thank you very much, Gianluca, and for bringing also the topic of awareness and information to the customers. Later we will see again the word cloud. I can see it here, and I see there's a huge transparency and awareness word, so this is definitely a fundamental point. But Benjamin, I would like to hear your opinion as well. You also conducted some customer engagement activities in your demo, which is located in a rural community in Germany. I think you also have a couple of pictures to show us, but please tell us about your experience and your learnings, and maybe some of the remaining barriers that there are there to overcome to really facilitate provision of flexibility services to the grid.
Yes, thank you, Selena. Yeah, in our demonstrator, we had to address basically like 3 challenges. One is the regulation challenge, the technical challenge, and the incentivation of customers to participate in the project. The last point I will give later to Jonas Töpken. He will give a more insight on the customer view. So I will rather focus on the regulation and the technical engagement of our customers. And yeah, I already have showed you our use cases that we applied in a demonstrator. It's, I already mentioned, a bit over the edge of the current regulation. So the legislation and regulation that we have in Germany does not allow us to apply the use cases as we have applied them in the field. So it means that with our customers, we have to make like bilateral agreements that we have access to their flexibility to apply our use cases. But the even bigger challenge was basically the technical hurdles that have had to overcome during the project. As I mentioned, we wanted to apply the demonstrator in a close field grid section, like a low voltage grid section. And the challenge was to integrate the customers and enabling them to provide flexibilities and integrate it to the energy management system that we have implemented. And yeah, it means that we had to start a very huge customer engagement process. We had first to find a suitable field test location at which we already today see future generation and consumption characteristics of households. So meaning low voltage grid with a high share of rooftop photovoltaic system and households which already have like an energy storage. We yeah, it means then we had to contact customers and find, first finding a suitable field test location and then contacting the customers to participate in the project. We also had to look for suitable technical components that can be measured and controlled and that provide interfaces for the connection to the energy management system. Because, and I think probably many here knows that in Germany we still have a slow rollout of the smart meter framework. There are still some interfaces in this framework in a definition phase, which means we can't use them for our demonstrator for measurement and control. So we had to implement our interim solution. But also we have investigated that many of the flexibilities in the low voltage grid, the DSO has no access to several reasons. Some of these assets do not have an interface that is actually able to react on external signals. So we had to look for assets that enable these features. And we then had to implement it in the field. And yeah, our implementation phase has was during the Corona phase. And then we had like this huge manufacturing delays. Like it was hard to get components. There were like long delivery times. And then there are like these politician decisions in Germany, which is incentivizing households to build rooftop photovoltaic systems. This requires installers, and there's a huge lack of installers because the demand at household level to get a PV system is so huge. You can wait almost 12 months for an installer to install your device on your rooftop. So for us, it means we had to look for solutions to get the demonstrator set up. And we then decided to involve our education department because we as grid operator, we are educating young people to do the grid installations and work. And we involved them in our demonstrator to equip households with the inverters and storages and the communication devices to get our households integrated in the energy management system in the field.
Thank you very much.
Sorry, Selene, if I might add something. Also, Luca Lo Schiavo from ARERA before said that the customer engagement is also a regulatory barriers, not only engagement barriers, no? Because I think this is important to know because to divide the effort through all the market operators, no? So this is, I think this is important.
Thank you both, Gianluca, for remarking a very important aspect, I think, of the role played by regulation in such innovation activities, and Benjamin really for making us understand how much effort and work is needed to put together something like this and really have these results today with us. It came really with a lot of work. And as Benjamin mentioned, we will finish the session hearing again about customer engagement with a testimonial from a representative of customers in Germany. But now for the moment, we move on, and I ask to put the Slido back so we see the results of the previous question. And yeah, as I said, transparency, very big over there. But I will close this poll to start the last one that I've prepared for the audience, asking about what benefits can digital solutions bring against the needs and challenges in the power systems that we have discussed so far. And then I will have one question that I will ask to all three DSOs that are here on stage with me about So the Platone Open Framework that we have presented today in many occasions, many sessions, and all the innovative equipment, measurement control devices that were tested and installed in the project. And I would like to know from the 3 DSOs, what was the main benefit that you experienced from the implementation of these novel solutions? And how do you think you can leverage them in the future, really in the day-to-day management and operation of your grids? Frosso, I think we can start with you.
Thank you, Selena, for the question. So, as I already mentioned for Hedno, we have concluded that the solutions that we tested can be scalable for our grid and for our systems. And we have also pinpointed a lot of areas that need to be, a lot of small glitches, for example, that they need to be fixed, for example, in terms of data handling. So I think that it is in the future of not only Hedno, but most DSOs, I think that similar solutions are going to be very important in order to educate people on flexibility and on how they can become actors themselves, the consumers, in their consumption and in handling and maybe also defining their tariffs and things like that. And also on the technical side of how important it is from now on and going to the future to have a very good image, a very good estimate of what is happening to the grid, because the topologies are changing. Production is becoming decentralized. The people are now consumers, are not consumers anymore. They also produce. Smart devices are being installed in most houses. It's very important also with climate change to be mindful of the environment, to go towards zero neutral. So there are a lot of challenges in the future that will make such solutions very relevant, and this is the future for the energy sector, the energy market.
Thank you, Frosso, for bringing the grid observability issue on stage, one of the central points of the grid demo.
It's really important also for us, for Hedno, because we have a very huge renewable energy potential, but we also have a grid that was built in different times. So this grid now needs to go to the future, and it's really important to do that in a way that is also cost efficient, and it also guarantees that we have always provision of power to our customers.
Thank you very much.
Welcome.
And Gabriele, what's your take on this? What was the main benefit brought by Platone for Areti also for the future?
For the future, Platone. First of all, Platone helped Areti to understand more in detail what is the local flexibility and how we can use the flexibility. For use this flexibility from the distribution energy resource connected to our grid, we have implemented the architecture that we have seen before, but there is a component very important for us in this architecture that is the DSO technical platform. This is a platform used by the DSO to elaborate the request of flexibility that we send to the market for the matching with the flexibility offered. To elaborate this request, we have implemented several functionality as the forecast, load forecast, generation forecast that help us to understand how the grid, what is the problem that the grid can have in the day after or during the day in the next 4 hours. This is a very challenging way to see our infrastructure, and this platform for us it is a step, a a new step because it uses all the devices that now we are installing on our grid to increase the observability, and it is a kind of interaction also with the end user, because the end user now with this new paradigm is not the end point of the grid where we have to guarantee the connection to the grid, but the end user are a very player that we can involve in the management of the grid. And to involve the end user, we have to use this kind of tools and all the other platforms that talk with for instance, for the DSO technical platform. And the future, for our point of view, go in this direction, as said in the morning also by Arera and other Italian NRA and other important players that this morning we have listened.
Yeah, so the circle closes and we go back to the customers, and there's no way we can do without them. Benjamin, you're the last for this question. Biggest benefit brought by Platone and how you're going to use it in the future?
Yeah, I think the benefits of digitalization in general is basically that the DSO has the opportunity to improve observation of the distribution network by applying monitoring services. And this is basically also the basis to control small-scale assets in the lower voltage grid levels of the distribution grid. And together with automation of these control schemes, it is like a perfect combination then to improve the efficiency also of the distribution grid. And I think this has also successfully shown in each of the demonstrator in Platone. And we also have shown that with the open source approach and the DSO technical platform, were able to implement like automated flexibility control schemes, also with the help of, as I mentioned, RWTH Aachen, who were implementing the algorithms for optimized control, so that we were basically able to apply these use cases and show the grid beneficial effects.
Thank you, Benjamin, very much. I think we came to an end to my questions, but now we have 10 minutes more or less to open the floor to the audience. So I would like to see if there's someone from the audience who has a question. Otherwise, we have a couple of them from online, and I can take them. The first one, I think, Benjamin, is for you. Our participant asks, in your opinion, why the German regulator does not allow the implementation of the use cases that you have tested in the German demo, also in relation to the slow transition towards the smart metering that you're experiencing in the country?
That's a pretty tough question. Well, I think in general, we do not have to forget there's like an energy market. I think in many of the project, I mean, we have like the system operator, we have the customers, and we have the energy market. And in most, I mean, at least for the German demonstrator and the use cases, we left out a bit the energy market, but we need to respect these markets. And when it comes to the question why the regulator is not implementing these use cases, because also the energy market has to be respected and has to be involved in these schemes. And these schemes, or the combination of all three together now, it doesn't allow the application of these use cases. But however, I think the regulator in Germany is motivated to that the DSO has more access to the control of small-scale flexibilities. So we are currently in a phase at which the demand-side management in low-voltage grid will be a bit adapted by next year. And I think also soon we will have a redispatch scheme for generators in the low-voltage grid. I mean, it has been widened so that, the past, only the transmission system was integrated in the redispatch scheme. Now, in the last year, we have integrated the high voltage and medium voltage grid, and so soon probably the low voltage grid will also be integrated in the scheme. So, I mean, there are some control schemes, but the use cases that we have applied in the demonstrator, we will see if they will be applicable in future. And there was, I think, a second question.
It was asking in specifically related to the slow deployment of smart meters in Germany, if there's a relation between the two aspects. Hot topic.
It's hard to answer, but I think it's yeah, there are definitely several reasons. I think the data privacy law was one major, data security issues. Yeah. Let's answer it like this. It's yeah. I mean, there should be like more an expert in this question involved. But I think that's a good summarization.
Yeah. Thank you very much, Benjamin. There is one last question that I like very much, and I think it will allow us to close the panel with a very positive note. And I think I will ask it to all of you, starting from Gabriele, which is, can you mention the greatest satisfaction you gained from participating in this project? Gabriele?
I don't know. I'm very happy to take part, and from my point of view, I think that the best results of this experience, it's about the person and all the implementation and the team that working on this project. And I think that will be other project that we can continue this journey.
Thank you. Gianluca?
Yes, I'm an aggregator. I play the role of the aggregator that comes from a competitor market. So the best thing I have seen participating in Platone is the sharing the knowledge that in competitor market is not easy to find. So this is the best things I bring from Platone experience.
Benjamin? Is this tougher than the regulatory question?
It's the easier question. It's the easier question they have done to you.
Yeah, sorry. Can you repeat it again?
Yes, what is the greatest satisfaction that you've gained from participating in Platone?
Yeah, I mean, it's like everything what is related to our demonstrator. I mean, we managed to implement a balancing scheme mostly right from the scratch that involves almost every important actor, like the DSO, the customer, IT service providers, weather forecast service providers. So all together in a 4-year demonstrator to put together, generate measurement data for evaluating the balancing control schemes. I think it's a huge success in this short time.
Thank you, Benjamin. Froso?
Okay, I think my colleagues have already answered that question for me, so it was really very nice to collaborate with everyone, and the amount of knowledge that we gathered, both each of us individually and the company in a whole, is really useful. And we've already mentioned it as well that for Hedno, at least, it was the first time that we deployed schemes of observability and installing devices such as the PMUs. This is something that has not been done before, even in a research context. So I think that it was really important that we build a very considerable know-how, and because we are also the new generation of people that will shape the industry in the years to come, I think that this is really important because we will be more equipped to face the new challenges that lie ahead of us.
Thank you, Frosso. And with this, we're coming to an end of our panel. But as I mentioned, the last word we will hear from the customers. So we will now leave the stage, but we leave the floor to Jonas Topken from WC Germany, Wibera, Project Bürgerdialog Stromnetz, on behalf of the German Federal Ministry for Economic Affairs and Climate Action. Jonas, please.
You had another, be careful with the glass. You had another question there.
So this works? Yeah, sounds good. Yeah, thank you first of all for the invitation by Avacon and the possibility that I can also present my thoughts here. And yeah, I'm today will, as already has been introduced, report for the project Bürgerdialog Stromnetz. It's German for the citizens' dialogue on the electricity grid. And it's a project what we as PwC Germany are running on behalf of the Federal Ministry, as said before. And we have extensive exchange with citizens on all topics about the energy transition. And now I will first focus on some general points and then also point out some aspects about the project Energieplattform Twistring, this Platone project, which we have spoken before. So first, I want first to focus on the role of citizen participation in the energy transition projects. Secondly, point out the challenges in this citizen participation. Then I like to derive the key elements, what we see as a good strategy. And fourthly, add details on the project. So what role does citizen participation, and we already talked a lot about this, or a stakeholder engagement play? What role does it play in the energy transition? And the energy transition is a task for the society as a whole. So on the one hand, it's about building up the renewable energies. It's about, on the other hand, expanding the transmission and distribution grids, and it's also about energy efficiency, sector coupling, so everything together. And the challenges are huge, and we don't have time to make mistakes or to wait for the all-encompassing solution. And these regional initiatives and these regional projects bring significant value to test necessary projects and ideas, bring it into practice, and often these projects are then meant to be established also on a larger scale. And these projects bring people together and involve them in a good way and show how they can shape the energy transition by themselves. Well, this brings me to the second point. So the challenges of citizen participation are great. And changes in general are, with changes, people often feel insecure. They even feel anxious about these changes. And this is no different with the energy transition. So we as Bürgerdialog Stromnetz are often asked, for example, about a declining value of the citizens' property due to new power lines which are constructed. Or they are worried about the energy security due to the fluctuating energies of wind and solar power. Or also the development of the energy prices during the energy transition is a huge topic, like we experience and when we talk also to other DSOs and TSOs. And the same applies to these demonstration projects. So out of the citizens' view, everything should just remain as it is. And yeah, in addition to these changes and worries they have, you have to face a challenge like we did with the COVID pandemic. We learned a lot about the influence of fake news and wrong information. And it's exactly the same thing with the energy transition. Stakeholders sometimes try to influence the mood of the people deliberately by misinforming the people with wrong information and getting them on their side. But however, there are measures that can increase the acceptance and on the one hand for this project, but on the other hand also for the energy transition as a whole to make it a success. And yeah, first big point is participation. This is a major key factor, and this was there before. It's about For the small projects, participation, making information transparent and open, but also for the energy transition as a whole. So you can raise awareness about the problems in an early stage and discuss these topics in a targeted manner. And when you talk to the people on an early stage, and they have fears, they're anxious, you can convince them that there are no bad changes, or probably that these changes, these projects, even lead to a better future. But still, you also have often to listen carefully and maybe at some points also find compromises to get along with the people. And besides participation and communication, a huge factor is also about financial participation. So if people can earn money, acceptance is directly much greater. In the context of wind and solar projects in Germany, it's often possible that the citizens or the municipalities in Germany can participate financially at these projects. But with a grid expansion, it's not possible like this in Germany, and this is often criticized, and we often hear this from the people. And therefore, I recommend three key factors for a successful communication strategy. It's a transparent and coordinated communication. It's to ease the people's fears and, if necessary, also accommodate them. And thirdly, it's, as far as possible, also create financial value. And finally, I would like to talk briefly about the project Energieplattform Twistring that we heard before. And there it's important that not everybody had to participate. So with the energy transition as a whole, this is not always possible because everybody is part of it. Like I said, it's a task for the community as a whole. And as Benjamin taught before, there were comprehensive communication measures that took place and information events, which is, like I said before, really, really important. And during these events, many questions arose, for example, about the loss of the storage units due to the frequent loading and unloading, also about the running costs of the solar panels or the batteries. These were skeptical questions. And a major issue is the loss of comfort. Like I said, the people want that everything stays like it is before. And they are worried, for example, that at a certain point they can't use their electric car because it's not possible to load it, or that their household is getting colder, their house is getting cold because the heat pump is not able to work because there's a lack of power. However, the people who participated in this project understood the value of the project and the opportunity they can take to reduce their carbon footprint, to increase self-sufficiency. And this has even strengthened the local feeling of belonging due to the higher self-sufficiency of the small town we were talking about. But there were also kind of small financial aspects one has to admit, which certainly led some people maybe to participate, because when they have a higher part of their own energy they produce, they use higher part by themselves, it's cheaper than buying the energy out of the electricity grid, so they kind of save money in comparison to this. So, to my conclusion, the energy transition is the task of our century and for our generation, and these changes trigger fears and worries. Regardless whether it's a small-scale demonstration project or the energy transition as a whole, we have to take care of these. And communication and citizen participation is an important key factor which contributes highly to the success of the project, or, like I said, the energy transition as a whole. Nevertheless, and this is also kind of particular for Germany, there we have huge participation programs which often hold up the projects and the energy transition. And so also here you have to find a compromise always between acceptance and taking all the people along with the project, but also just the implementation of the project and get the projects and the energy transition done. So thank you, and I think now later we're heading to the break, and if you like, we can discuss on a few points in detail. Thanks.
Jonas, thank you. He already did my job. He announced the break, so I don't have to do anything anymore. So we have 15 minutes break time now, also for the information for the audience online. because some of our participants have to go, unfortunately, so we need to have some minutes to do that. But stay tuned and be back around 3:35. See you then. Should kind of welcome back. Welcome back after this short break. Please take a seat. The next session will be moderated by the lovely Helena Gerard. And the next session is about, she's from Vito, obviously, and she's also the leader of the Bridge Regulation Working Group, if I'm correctly informed. Very lovely initiative. The session will be about collaboration, cooperation, and communities, and how they can accelerate innovation. Dear Helena, please join me here on the panel, yes, and have fun. The microphones should be on.
Okay, thank you. So, good afternoon. I hope everybody is still awake, that refreshed, and ready for an interactive session, because it's on cooperation and it's on interaction with all of you. So we have some very experienced speakers who will give the ins and outs of collaboration within several EU and even international initiatives. So I would like already to welcome on stage the 4 panelists of this session. So we have Ferdinando Bosco, we have our great coordinator, Antonello Monti, we have Ludwig Karch, and last but not least, we have Fiona Williams. Please join me on stage so that we can have an interactive session on collaboration, but not just on collaboration, but more to have the focus, collaboration, is it actually useful to speed up innovation? And if it speeds up innovation, is it then bringing value? Or, let's say it bluntly, should we do more collaboration, or was it just a waste of our time? I don't think so, but we will try to discover it in the next 50 minutes. But before we go into the details, I would also would like to launch a little question to the audience, both here in the room and online. What do you think about collaboration and cooperation? Is it really something which is useful, important, or is it indeed just something that we do because it sounds great, but in the end we prefer to go alone because that goes much quicker? I hope it works, and I hope it switches on now on the screen. So think again, how important is cooperation and collaboration? That will also tell us whether we still need to convince you of the need of cooperation, or whether we all agree already. It's good, there is at least... Let's assume that most of us will vote for number 5. And let's also, maybe for those who are still hesitating and don't dare to answer, because that's obviously also an option, let's give some good examples of collaboration. And the first one I would like to ask to enlighten us a bit on a very interesting innovation is Ferdinando Bosco. So Ferdinando, can you tell us a little bit more on the OneNet interconnector? Because Ferdinando, as most of you already might know, because he was already introduced earlier this day, he is a very experienced researcher in several, I would say, digital technologies. He is involved in many European R&D projects, and in particular the ones where collaboration is a key for success. So give us maybe your view on the innovation from the OneNet project, and also how it relates to what's done in Platone.
Yeah, thank you, Elena. Can you hear me? Yeah. Thank you very much, Elena. I think collaboration is the key words. Also cooperation. Collaboration and cooperation are the keywords in OneNet project, in which we presented the solution that it's in charge of create this big collaboration at European level. Because we started to investigate all the results of all the projects and all the countries, because the OneNet project is a very huge project that I think is comprehensive of almost all the Europe. We have 4 European clusters divided by different parts of the Europe with 10 different demos and 21 use case applications. And our goal, our main goal, is to create a unique network for the entire Europe in which all the energy stakeholders can collaborate and cooperate each other for creating innovation, because We believe that innovation means now having this kind of collaboration where the data exchange is at the base of this collaboration. Because all the new IT solution for the digitalization needs to collaborate and data exchange for creating new services. So OneNet proposed a digital solution that is completely decentralized. And this is the overall architecture that we designed for pursuing this goal, in which at the bottom we have the OneNet participants that are any possible energy stakeholder involved in the energy transition, then can cooperate. And then we have TSOs, DSOs, customer, FSP, any kind of stakeholder. And then we have the core of the OneNet idea, vision, that is the network of platform. We believe that already existing, we are already existing a several solution, IT solution that allow to implement innovative services, but we need to link all the existing solution in different countries in order to create this cooperation. And we believe that network of platform means keep the existing solution, but proposing them something that facilitate this integration and this cooperation. And this is why we create the OneNet connector. The OneNet connector, together with other additional solutions that be part of the OneNet framework, allow to create this cooperation among all the energy stakeholders in an easy way. It's a completely open source, so you can download it and install by yourself in your existing environment. And this integration facilitates to integrate any other existing platform, so any other stakeholder. So if you want to cooperate, have a cooperation between TSO and DSOs, or DSO and have FSP, or involve the customer and their environment, you can use the OneNet connector in order to create this integration. It's very easy to be deployed. It's a low cost, let's say, from an IT perspective, because it's quite very low requirements. And it offers a series of standardized interface for integrating existing platform. And it's based on two big initiatives, rounding around the data space concept, let's say, that are IDSA, the International Data Space Association, and FIWARE, that allow us to create this standardized way for creating this OneNet connector and enabling this cooperation among all the stakeholders. The collaboration is also a keyword in terms of result among all the projects. Because in OneNet we cooperated, we have a very huge consortium which all the partners, I think, cover all the projects related to the energy domain and the possible stakeholders. So what we have done is to create this sort of experimentation towards Platone project and interface project, thanks to European Dynamics, that is the coordinator of interface. And we used the experience done in OneNet in order to create this communication and integration from two worlds that does not communicate each other until we use the OneNet connector. So we have the market implemented in Platone, we have the market implemented in interface, how we can match these two platforms in order to easily communicate each other and share the knowledge. And we create the connector that enable this sharing of knowledge in an easy way. So this is, from our point of view, the collaboration meaning.
Okay, thank you very much. And I'll come back to you later in the panel with a very specific question, so you can already think about it. Because now it's a friendly, I would say a friendly engagement between two projects, for example, between Platone and Interface, to collaborate with the OneNet connector. How will you convince other actors to also use the OneNet connector? It'd be very interesting to know how you can engage them in the initiative, although it looks fine on the technical side, but still you probably need to convince them. How will you do that? But let's move on. Think about it later. We will talk about it because the same question is also valid for some of the other initiatives here on stage. How to engage that actually somebody joins the valuable initiative. But let's move on. So another panelist is our coordinator, Antonello Monti. And I must say I was, I would say, intrigued by hearing that within the Platone Final event, we would talk about cooperation, not just between projects or within Europe, but even beyond. Antonello has a very long-lasting experience, not only in European projects and European R&D, but also worked in industry and worked also largely in the US. So you're probably the perfect person here to tell us a bit more on cooperation with Canada. What is it about, and is it an added value to work with, I would say, countries outside Europe? Because still, often you hear that the grids and the problems and the cases are very different. So what do we gain by cooperation?
Yeah, I think, first of all, this is a very hard challenge working across the ocean. From the point of view of academics, we love that. And it's, I think, one of the major problems we suffer, that we can only limit our cooperation within Europe. So this call that where Platone was funded had the opportunity to have funding we could allocate for a cooperation with Canada. It was an option, and you were going in, there were two options in the call. We decided to go with this one. Why? Because myself as academic, I thought that's great, because there is always to learn from realities that are very different, and for the academic world, this is a fundamental value. So that was the foundation behind. So we had to do it as part of the call, and we had different activities we were able to place within the project. First of all, among others, this activity brought the decision with our university to pick University of Alberta as a strategic partner, which means that now we have a continuous scientific exchange between Canada and Germany, and in particular the University of Alberta. We saw that cooperation was important also within the project because, as you said, they're different. So the regulation in Canada is different, the way the markets are structured is different, and we thought it's very interesting to compare, would Platone work in Canada, or what are the barriers? So we are still in this discussion with them right now, and we could learn from their regulation something, oh, the Canadians do it differently, that could be maybe transferred to Europe. So not only at the scientific level, the cooperation was interesting, and it is still interesting. We are just right now working on the deliverables related to this aspect, to learn from each other, to get advice from group which is very detached from the project. So we had at least one professor from the university in our advisory board, and so we get advice from somebody who can look very, not only physically, but also conceptually far away from Platone and comment. And that brought us also to have more type of cooperation. So currently we have 4 PhD with joint supervisions that link the scientific activity, and they invited us in their events. So I've been invited to be in keynote to their major conference where they have a kind of a network of all the grid operators and energy operators in the region of Alberta. And they invited me to be there, present Platone. So there was this mutual exchange of experience, problems, and so on, which I think was a great asset for the Platone project. And we hope, actually, part of our solution could work in that context, particularly the DSO technical platform with the Sony architecture, which is hosted now in the Linux Foundation, is something totally open and not constrained by regulation. And so we are discussing with some of the people from Alberta are involved in the activity of the Linux Foundation, so looking at the evolution of the platform, and they're also discussing with their own DSOs and if maybe they could use the same software architecture. And this will bring some incredible kind of bridges in cooperation that will go also beyond what the call was expected, just a little bit of workshops and so on between the two institutions.
Okay, I must say I'm intrigued, but it sounds that international cooperation, that we probably have not explored the limits on it, and that we should do more, that there is more to explore, more to be done. So thank you for highlighting. Then maybe going from something very international to more European or even local cooperation, but maybe it's not so local. So we have Ludwig Karch here, who, of course, his CV is very, very long, but if we talk about collaboration and cooperation, he's also the perfect person on stage. He's involved in many collaboration initiatives, going from the set plan, ERANET, Bridge, and many more. So you know everything about the do's and don'ts on collaboration.
No.
And now my main question is, the Flex community. It's one of the main outcomes of the Platone project. It's all about collaboration and communication. So tell us more about it. Why did you do it? And why should we be proud at the end of the Platone project that this one flight?
Yeah, thank you for this nice introduction, but I know that I don't know nothing. Flex community. Let me first explain a bit to the audiences out there. I guess everybody in here has known it because you have been involved, but some people outside don't know what it is. So give me 2 or 3 minutes to explain what it is, and then we can talk about the why and how we can go on with it. We selected a good date to remember it. It was the 2nd February of 2022 in the midst of Corona at 2:02. We pressed the button and we created it. So everybody remembers the date. Who was we? That was more or less led by 3, or if you also put gift to it, 4 projects, Platone, EdgeFlex, and Fever. Meanwhile, it's a community of 19 projects that have representatives in the various activities. Some have been mentioned here, some maybe are local. The Pebbles, for example, is a German one that did a lot in blockchain. We have 231 registered members. When I say registered, then it means we have a platform, a community platform in the internet. People can go there, they can see what we are doing. Then they can register and get some access to something. What is important, and that is shown here, we wanted to attract, and we did attract people from academia, from industry, from framework setting, so regulation, for example, and consultants, of course. And the majority is industry, and that was very important. We didn't want to create a good academic community, but we wanted to have something that is, say, cross-sector, if I can use this term here. The purpose, I mean, and I will come back to that. We said, okay, it should be about flexibilities, of course. It is about large-scale use, not just experimenting in a sandbox and in a lab. Large scale, do it in the broad sense. But that also means that we need to create awareness. I mean, if we sit together, for example, today, everybody would agree that we need flexibilities, but go out to the streets of Brussels. So this is also a question of communication. And then, as I said, we want to somehow bring together in a multidisciplinary way all stakeholders, or a diversity of stakeholders from research industry, regulatory organizations, but also from national, transnational, and international level. That was the idea behind. And the last one, and we can discuss that because the both of us are also very much involved in the bridge community. The bridge community is built around European-funded projects that have a lifetime of 3 or 4 years, and then they are done. In the best case, someone takes the torch, some person takes the torch from one project to the other. People like you did, like Anto does, and some others. But organizational-wise, the projects are done then. And we are losing. And so we said, okay, we want to create something that is independent. What did we implement? We implemented this community platform. We started with these 200 people. We have flex groups, one on technical aspects, one on market aspects, one on solutions for the industry, and one very special one that is a flex offer user group that is more about standardizing interfaces and so on. We are ongoing, we have the flex groups. We are doing, meanwhile, a survey between the 200 members and others. What is it exactly that we should do next? We should also come up with topics, maybe topics that have not been put in any funding program yet, that need to be researched still. And we will exist forever. And we announced at least the Flex conference for the February 22 on 2024. We didn't announce the 2025 one, but I'm sure there will be one. So that was what it is. We can then discuss why.
Thank you. And I think we can indeed continue to discuss why, but also where it will end. There is, I think, a lot of things that can still be done. And somebody who can also tell us a bit more on all the challenges to bring innovation into the mix, into R&D projects, is our last but not least, our only woman in the panel, but she counts for 4, I can say. Dr. Fiona Williams, who is currently coordinator of the EdgeFlex project and also research director of Ericsson. And you're doing a lot of innovative stuff where collaboration is key. Can you maybe highlight some more what it's about and what we should remember from it?
Yep. We have in EdgeFlex partners from lots of different areas, and that's what's really interesting. The collaboration is very wide scale. We have, the objective of the project is to investigate new roles for VPPs, to expand the role they can play in stabilizing the grid, both short-term and long-term, and that's what we looked at. And in the context of doing that, we of course needed to cooperate with DSOs. We also found that a lot of the solutions we were developing could be directly applied by the DSOs, not just by VPPs. We found new markets. We were, at the time we planned the project, energy communities were new, and we thought that would be an interesting aspect to look into. We weren't sure how far we'd progress with the topic during the project, but it really took off. And we had an energy community operational in SWW, in Wunsiedel, in everything except legal entity name, because it's not yet possible to register it as a legal entity. But we went far beyond our original plans and ideas around investigating flex communities. And that turned out to be very interesting and led to lots of collaborations and discussions within the bridge context. We learned a great deal from, including that idea in our proposal, and from then trying to investigate the topic to the full extent and to integrate it into our work. And then, of course, to complete the picture, we were working with TSOs because they have the key links to the VPPs, and they're critical in also working with inertial estimation and allocation and frequency regulation, which we were working with in the project, both at the level of developing new fundamental principles and implementing new services. Which we built then in a platform based on the Sonio platform, expanding the Sonio platform, as was done in Platone. We took it in EdgeFlex and expanded it with new services in different directions. And we also developed an Edge PMU, RWTH developed the Edge PMU as a new product. It was a prototype deployed in the field trials in 3 countries, or 2 countries, 3 trials, 2 trials in Germany and 1 in Italy. And we deployed the Edge PMU there. And we were very lucky that by the end of the project, before the end of the project, which was in March, we had already agreed plans to go to our small-scale production of the Edge PMU to roll it out on a larger scale in SWW network in Wunsiedel. So I think that was tremendous innovation and success in the project to be already agreeing with a customer small-scale production, with the customer even helping to find the producer. They were so enthusiastic. And we had, as I said, 3 field trials, but we would have run more if we'd had the resources. We had requests from Vattenfall and other DSOs in Europe. We had 2 further DSOs in Italy, and Vattenfall from Sweden lined up. They were interested to join our field trials at their own expense. And Uniretti did join the field trial in Italy at their own expense, but we could really only support 1 trial in Italy, 1 extra one, and we didn't have the resources, especially not during Corona with the restrictions on travel, which ran right through the project. We weren't able to support more trials and produce more PMUs with the project and the university resources. So I think we had very many successes. We had over 40 high-quality scientific publications on the new fundamental techniques for frequency management. We had new services implemented for frequency voltage and inertia estimation at allocation within the service and in the platform, and trialed in the sites to the extent that it's possible in field trials. Not everything can be experimented with in every context. And we have production of the Edge PMU, and then we had huge learnings. I come from Ericsson, or I represent Ericsson in the project, so we were particularly interested to learn about the communications implications of the services, what they would require as support from communications networks, in particular mobile networks. And we wanted to investigate how edge infrastructure in mobile networks could support new services. And we were able to experiment with the Edge PMU, virtualizing it, which is virtualized. The software can be hosted on the edge infrastructure, and then the sensor is much simpler, can be deployed in the network, and you don't need to go to it to upgrade the software because its analysis software is in the edge infrastructure. And we were able to do all of that because we had partners from the power sector, both academic and commercial partners and consultancies in the project that were able to bring together all the competence needed to bring things from ideas through to experiments in the field where more DSOs wanted to join than we were capable of supporting, and where people wanted products before the project had even got to an end. So after many, many years of collaboration in EU projects, I've never seen a project that had so much commercialization within the lifetime of the project. At least of the ones which I've been involved with. There are probably other examples, but that were my ones.
I think it's very inspiring because we wanted to ask some questions indeed on how you would get to those solutions, but yeah, maybe you want to highlight.
Just maybe to outline the 5G aspect, because that's perhaps something we haven't discussed so far, or LTE. In many cases, LTE can support the solutions and is already available, but 5G has more extensive facilities and higher bandwidth, lower latency, etc. The solution sketch is the same whether it's LTE or 5G or other mobile networks. Basically, on the left, you see the devices which are deployed in the field. So PMUs, sensors, any other device you want to communicate with, which could, for example, be the energy assets of an energy community. You might want to control the assets individually and as a group. So you need to communicate with those assets. And rather than laying fiber connections or using fixed networks, if they're available, and often they're not, to the locations of the new assets or the assets you want to communicate with, it's very cost effective to use a mobile network. And with the newer networks like 4G and 5G, you have very high reliability and low latency networks, very high availability. And then you can use, as I mentioned, edge infrastructure, particularly with 5G, to virtualize your services. And that increases the robustness of the power grid because you also have services located locally in the local infrastructure and not at one centralized point hundreds of kilometers away. And that can be very valuable. And then the component on the right is you need a visualization of what's happening with the data, and that's normally a display in the DSO or the system operator or the VPP or the energy community. So these are the key elements of the solution when you're talking about mobile communications. These are the topics you're going to be dealing with. And you can see on the network there's a list of topics, 4G or 5G, underneath the second symbol from the left. And then below it, MCN, mission-critical versions of 5G non-standalone networks, so combined with 4G core networks. A mission-critical network is a mobile network which has been designed so that it has duplication of the key assets, duplication of processors and servers and nodes, and that makes it very reliable and robust. And that's what you need if you're really relying on in a critical infrastructure on your network. So we investigated that as well and provided the input to 6G concepts. And we were lucky that during the project we were able to we were able to develop a proof of concept of a new interface, an API for 5G to make it easier to use for utilities. And we submitted 3 standards contributions to 3GPP, the global organization for mobile communication standards, and they were accepted. And what 3GPP does, it's like FireWare, it standardizes the interfaces, not what goes between them, not the modules. You can build the modules as open source if you want. Some people
I think you're making the people jealous here with all your solutions.
Maybe it's about
or commercially.
Communication.
Yeah. I think
we then, with the standardization, was done in the IoT engine project, which you can see here. We continued the work of EdgeFlex when the resources ran out for that particular piece of work on the proof of concept. We developed the standardization proposals in IoT engine, and they were successful.
That's a very nice point, because you actually already answered the question before I answered, like, where will it continue? But what is remarkable in your example was that you had no issues in engaging, that they were basically standing in a queue to join. So my question is for both Ferdinando and for Ludwig. You have the Flex community, you have the OneNet connector. There are sound solutions, interesting initiatives. We all think this is useful. How do you engage others to also join the initiative? What should we do? How can we move it forward? Ferdinando?
Yeah, I think it was a big challenge because from my perspective, from an IT provider, so not properly an energy stakeholder, I have seen that the energy stakeholder are a little bit closed mind in terms of cooperation. It seems that they are stuck in their own environment and they don't want to cooperate for having innovative services. Now we are facing the energy transition. I think also they are conscious that need to cooperate or collaborate each other, but we need to convince them. In OneNet, we have done a lot of survey and analysis of energy stakeholder, existing project and so on, and we found that their big challenge is the data governance. So they are, let's say, they want to keep the data ownership, the data control. They don't want to lose what is their knowledge, let's say, in terms of business also. So what you can do is to push them from a regulatory perspective. So you can force them to cooperate, for example, or you can propose a solution. And from our perspective, an IT solution that they can use, ensuring them this kind of data governance and data control is secure, and they can keep this data control using an open IT solution. I think this was the what we leverage for convince them to use the OneNet connector inside the OneNet project, and this is how we can also go beyond the OneNet project in order to convince all the energy stakeholders to use an IT solution that is seamless to be integrated and ensure that you can keep control on your data and your knowledge without, let's say, any compromise and in a win-to-win situation, let's say. This is, I think, the best approach that we can use.
Yeah, that's, I think, a very good advice also for other projects to take that approach if you want to have impact beyond the project. Impact beyond the project, Ludwig. The Flex community, you already mentioned, it's here to stay. But how shall you convince to have more actors to join and also to keep it alive?
Let me do it a little bit philosophical. This morning we talked about Platone and Socrates already. You know, on the list with the course, I think one of the most important ones is still missing, the communication. It all starts with communication. Then you get to collaboration, and the ones that learned Latin said collaborare, we do something together. And then comes cooperation. We have a joint goal, a joint system, and we jointly operate it, which is another level. And then comes the highest level, that's the community. And if you look at that, then you understand the challenge, and you understand also a bit what at least I would envision with the Flex community. We took it from communication. We started talking to each other. between the projects. What are you doing? What are we doing? What do we plan? Blah, blah, blah. Where are the issues? Then we did something like collaboration. We said, okay, let's work in working groups, and we have a conference, and we do something together, and then we see what we really can operate together. To be honest, we are not at the cooperation yet in the Flex community. We are now trying to do this survey, trying to create a first joint document, but that's not so easy. And to be honest, we are not at all at a community level, because community level, I'm not the wiki, but if you would go to wiki, it would tell you something like a group of individuals that share a vision or something. And then you ask me, how can we make it survive? I think we stepped through communication, collaboration, we are a bit in cooperation, but now we have to work on the community. And to be honest, I don't know how. But if we don't manage to get these people with their, not only with their brains, we are at their brains, and we are at their fingers and keyboards, but we are not yet at their stomachs and hearts. And that is something that we definitely need to make a change in this world. And you please help that we turn the Flex community in a community. That was philosophical, wasn't it?
Yeah, let's try to find an answer later today or in the coming weeks on your question. But you triggered something very interesting. You mentioned, for example, the bridge working groups, but you also mentioned it all starts with communication, talking to each other. And there is one initiative that, with respect to Platone, we need to mention. It's something that Ercole led, but unfortunately he's not here anymore, but it was the involvement and the leadership of Platone in the, I would say, the redesign of the harmonized electricity market role model, which is, in a sense, I would say, almost a basis to communicate, because it's all about roles and a common language to start a common vision. Maybe I have a question there for you, Anto, because there is also some, I would say, some criticism sometimes when we say we communicate, we look for consensus, we collab, and then we can collaborate. Often it also means that we are not so innovative anymore, because we need to find the common denominator. Is that true or not? And how, within, for example, the example of the harmonized electricity role model, how could we bring innovation while also reaching consensus? It's not so easy. It's not always together. So what did you do to make that happen?
Yeah, it's a very good point. And when you were asking the question, it reminds me also a comment I was thinking on the previous discussion on the one-net connector. It's a similar challenge. And I think one point that specifically in the one-net, and then you're familiar with that, we are trying is to engage people from the beginning. So normally you do the whole process and then you come with your innovation, you ask people to believe in it. That's too late. So what we are trying in one-net is with the concept of Griffon. We have been trying to involve in our ideas and innovations people, the community outside the project from the very beginning. And I think this is important to make people feel part of the transformation. If you bring the novelty and you push to them, there will be always a reaction, what is this? And try not to surprise, but to accompany people can be a challenge, can be a solution to this challenge. And for example, with the Griffon, which is this grid forum that we created to support the activity of OneNet, we present our deliverable before we deliver to the Commission. And we ask people, this is what we are doing. What do you think? Is that in the right direction? Not that we publish, is written in stone, and then believe in what the project did. And I think it's an experiment we are doing. And we will see. People will adopt the one-net connector. It means that that strategy is winning. But I think it's a way to, at least to analyze, maybe even further. This was the first experiment we did in one-net, because it's key to be together from the beginning.
Yeah, I saw Ludwig, I saw you reacting, and also Fiona. So you agree what Anto says?
Yes, I think what Ludwig said, the communication is key, is
Yep.
the element. Sometimes you manage to understand the interests of the people you want to attract so well that you choose the right topic for your project. And that was how we got so much success in EdgeFlex. We chose the right topics, and it was already something which the customer, target customers wanted, and they were queuing up for it, more or less. But we also had to, for the energy community, go out and communicate. And SWW ran workshops in the local community before they offered the possibility to join the energy community, to see what the interest was like, to prepare people. And we described the process in a document for the Bridge group on stakeholder involvement as an example of how we did it. And I think the time right now is ideal for getting people involved, because there's so much discussion about the energy transition in all levels of society that it's not just an issue for the energy sector actors, it's an issue for everyone. So if you manage to find a topic or identify a topic through your communication which fits with the interests of your target group, and they are interested, it's a question of finding the topic rather than developing the interest. At the moment, everyone is interested in green energy and energy transitions and reducing fossil fuel usage. So that was just the point I wanted to bring in. This is a good time to be working with communities and collaboration and trying to get people involved. You don't have to try so hard. You have to communicate. And if we had more communications people, specialists in our project, we'd be much quicker than going out as technologists.
Maybe this is exactly the point. Now we are talking communication, but as it's the basis, I think we can spend some minutes on that. Remember, Fiona, when we started, and we did projects together since, I don't know, 8 years, 10 years. And in the beginning, the both of us, we more or less came, and also Anto, from the digitalization world. So we could explain computers. The others could explain substations. And now we understand that the people that understand substations need to talk to the people that understand computers. Unfortunately, they use the same terms with different meanings. Okay? And we are not talking about backgrounds, attitudes, expectations, and so on. And that is something that we need to learn, and still learn in every single project that we do. We need to make these people from these two worlds, the digital world and the energy world, talk to each other. And when you mentioned the HAMREM, the harmonized model, I don't recall them, but we introduced something like 12 or 15 new roles, and I would guess some 10 is digital roles. That's the digital operator of this and the digital communicator of that, and that is new to the harmonized model. There were so many roles that people were familiar when they lived in the energy world. Now we put all these digital roles in there. And now the people that discuss it have a hard time to understand why we need a digital aggregator role or something like that. That is the basis. We need to clear the terminology and the ontologies, and then we can dare to talk about collaboration or cooperation.
Interesting to hear, indeed, because often you hear like dissemination and communication comes with at the end of a project, but all these suggestions here point out that if we want to have some impact and something successful, it needs to start not even at the beginning of the project, but even before, by engaging people to choose the right topic and the right priorities. So I think that's an important learning that comes from this panel. Maybe a final question or suggestion, because we have now been talking a lot on communication, involving stakeholders. That obviously takes time. And often it is said, if you want to go far, you need to collaborate. But if you want to go fast, you need to go alone. And we need to go fast for the energy transition. But still, it's clear we do want to collaborate. How can we fasten up the collaboration? Because it takes time. Do you have some good suggestions from your experience that how we can make it as efficient as possible? Ludwig.
Start right away, because I'm seeing Andreas. Unfortunately, Andreas, you were the moderator today. Otherwise, you would have had a section here to explain our stakeholder survey from Platone. The first thing is, understand what these people do, think, act, expect, and need. And we are doing that. And I mean, I cannot blame people for not knowing. I mean, the psychologists do that. Who is a psychologist here? Okay, but we do this survey. You didn't present it, but I think it will be a result documentation. We looked at, I don't know, 100 different types of people, and we tried to understand what do they expect, what do they want. I don't know if you ask them what language do they speak, but that would be the database that everybody needs when we want to involve someone for collaboration, cooperation, or even a community. What type of person is that? And we need not try and guess. We should take it from a database. And we are working on that. And we keep going. And we will introduce that in the Flex community, by the way.
Perfect. I think it's already one very intriguing action to keep it alive. Fiona, how, from your experience, how would you think that we can even speed up this collaboration? How can we facilitate it? How can we make it more efficient?
I think it helps always to prepare the framework of the collaboration. And if you can design a framework for collaboration so that you take into account the interests of the different groups and allocate the topics and the groups together in such a way that you're pre-guessing some of the interest groups, you'll be quicker to get the whole thing moving than if you start with everybody in one group and then start a discussion on how should we form groups and what topics should we have. If you get a balance between making a proposal, this could be one structure, and then asking, would that fit, and can we improve this structure, and then starting from a proposal, that speeds things up a lot. And then there are a lot of different roles to implementing the energy transition. Some of them need to go slowly, perhaps, especially when you get to EU level with 27 member states. It takes a while to get an understanding of 27 positions to find out even what they are and how to bring them together. But you need to, at the same time, move ahead in different countries, and you can segment the actions on the problem, if you're lucky, to speed it up. And I think there are many issues which you can do on your own product development, like the Edge PMU. It could be done, it could be put on the market. It doesn't have to be agreed with 27 member states, it's a product. Sometimes you can segment things into software and hardware and products and systems, which can be done independently of large-scale cooperation, and it's usually much more efficient. But to get an understanding of what the product should do and how it should be used before you even design it, that usually takes the collaboration, and that's where EU projects and communities are great, because you get this insight into how does your target group think, what do they want, and then when you've got that insight, then you know what to design and how it's going to be used. Then you can work in your own.
All very valid suggestions. I would say let's try them in the upcoming projects. Before I give the last two panelists also the possibility to give their final words, how we can improve or speed up collaboration, I would like to launch the final poll. It's a bit of, you heard a lot of good ideas, how we can improve communication, how we can speed up communication, but what, according to you, is the best approach for your upcoming projects and initiatives? I think the poll should be launched. So can it be on 1, 2, 3?
Doesn't work. No, I mean, Ludwig, you did it.
Oh, yeah. Look.
If you wouldn't have interrupted me.
While everybody is deeply thinking out of all those good suggestions, what is the most appropriate approach? Question for you, Anto, because you have been working both with industry and also with academia, and there we definitely also need this collaboration, but there are two different worlds. How can we bring them together and speed up this joint interaction between those two, sometimes very distinct worlds?
I think I want to put few things together, what we discussed this morning and what we're discussing here. And I think we are in a time, we have clear urgency, so we all need to work together. And this morning we have been talking about open source. And this has been, to me, a new revelation when I started working with this mentality on how people can bring energy together. It's so much we have to do in such a short time that only join forces we can do things. And this is a big call that we are getting as a community to change a complete system while the system is getting under pressure. And we want to electrify the society. Everything becomes electric. You know, everybody solves this problem. I just make it electric. And we are the electrical people. We are the one that have to really solve the problem. And only if we all work together, this is possible. And so the idea of open source software, for example, and doing this at every level, it's a key moment to bring the knowledge and to formalize knowledge in some of the critical action. Digitalization is one of the key enablers of this process. We cannot do it separately in separate office of research or it can be a company. It's a unique challenge the whole world is facing. And that's where we cannot just work the way we've been working before. We have to sit together, all together, and limiting the barriers, because there is so much at stake that any barrier doesn't make sense.
Thank you very much. And then Ferdinando, because you have been doing this collaboration with so many partners within the context of the OneNet project, but also within Platone, can you give us a very practical advice to finish our panel? So all those good suggestions that we have now put on stage, how can we materialize that in the context of a project? When you start, which activity is really jumping out and helped you moving forward in a more efficient way?
Yeah, I think I have a good conclusion for that, because I agree with all the panelists, all the things that are mentioned there. I think the knowledge sharing is the best way to speed up the process, because we have a lot of results, we have a lot of knowledge coming from the stakeholder and the projects, and we need to do not reinvent the wheel every time. We need to use what we have done so far in order to speed up the process and not start again. And one of the best results of, I think also, one of the results of the Platone project is to creating a repository for the use cases. So we have a unique repository when all the projects can put their own use cases there, and you can find use cases similar to you in order to don't start again, but starting from results from other projects and other stakeholders. And I think, practically speaking, we need to apply this methodology for sharing the knowledge, not only for the use case, but also for the technologies, for all the results that we have. So we need to create a framework with a methodology in order to share the knowledge and start from the result from the other perspective and other projects that we can reuse. I think this is a practical suggestion.
And I think it's perfect because it's also nicely on the slide here, that knowledge sharing is key, but also all the other suggestions that were given, that we need to communicate more, but also we need to communicate earlier. And then we can create involvement and engagement at the start. And then we will have these, I hope at least, the very interesting developments within the different projects and ideas here presented, that they will continue to last and support the common goal, is realize the energy transition. So I would like to close this panel here, and I would like to thank the panelists for their engaging ideas. And I would say this is not the last word we said about it, but at least it's one step forward. Thank you very much, Ludwig, Fiona, Anto, and Ferdinando.
Thank you. And this is to become a member of the Flex community. Honorable member.
Thank you very much for this interesting discussion and insights. Now we have lost a little bit of time, but I think we can make it up in the next session. In the next session, we want to paint a picture of the Platone journey that continues. And to do so, we have 4, let's say 5-minute pitches. I hope we can leverage this time so we'll not be late. And we will start with the first pitch with Cristina Cochero. She is from IREC and she's the project coordinator of Flow. Cristina, are you there? Are you online? Can you hear us?
I am. I hear you. I hope you hear me.
Yes, perfect. So the floor is yours. Have fun.
Okay. Do you see the slides? Okay, perfect.
We do not.
Is it? Okay, perfect. Now, yeah. Super. Thank you for the invitation. Hi, everyone. I'm sorry I've not been able to be with you there in Brussels, but now we can manage hybrid meetings, so that's amazing that I can join and hear Elena and other colleagues before, and having these great conclusions from your project. And today and now I'm going to explain you further things we are doing. So just starting, almost starting, is 1 year flow. Next week, General Assembly of first year flow. Some of your partners, you see them here. So what is Flow? Flow is a project, European project, that aims to valorize flexibility from electric vehicles and through user-centric. So the idea is to focus on the user. We have 30 entities, so it's a big, super big project, I would say, with many different profiles, which solves some of the discussions you were having before. So we were able to join energy side, TSO, DSOs, and mobility side, so CPOs, let's say EV OEMs, chargers OEMs, and also obviously some research institutions, technical side, technology providers, aggregators, and so. So the idea was to have representation of the ecosystem so that we are able to really grow up on other projects' results and demonstrate in a real scale the electric vehicle flexibility. So if you can change the slides, I will go super fast to the slides because I have this 5-minute speech, and I want to keep in time. Okay, perfect. So pillars, as I said, user-centric, focusing on some words that you have already heard on previous projects, so interoperability, smart charge, optimal operation, integration. But the idea, as we said, is to scale on the results of those projects and to really, and I will explain at the very end, the pilot, so to really demonstrate that on a higher scale so that we leverage on our results, on the software and the hardware that we have in place to demonstrate this on the markets where we are able to. Please, next slide. So first, we are establishing a common knowledge base. We are trying, and I encourage you, soon there will be the first deliverables online to check them. We have tried to define what is the smart charge, how we define it in different countries, how we define it in different markets. Also, what is vehicle grid integration and vehicle to grid services and those flexibility services. So we are trying to, as you said before, somehow put the baseline for those definitions across different countries that are involved and with different schemas. Please. Then we have our work package fully based or fully focused on user engagement, and the leader is from the social side, which really is, I would say, an added value because we really need to explore how user is seeing that and how we can engage them on these softwares, hardwares, and markets that we are aiming to. Please, next. Then on interoperability, cybersecurity, and shared data models, again, a lot of efforts putting on that because as you mentioned before, and you see in the picture, the interconnections between all of the agents are incredible. So we should deal with that, and we should deal with that, assuring this security main for the users that you have just listened, and also for grids for sure. And next. It's only 2 more. And then providing different tools for supporting all the stakeholders that are on the projects. So the idea is that our tools can be open and can be used for this EV operation in an integrated way, and seeing the integration and the flexibility provision from a ecosystem perspective. So taking into account the requirements and the needs from the energy side and from the mobility side. And the next slide, the last one. And for that, we are defining this orchestration platform where the idea is that all these tools, not new tools, but the tools that we have in place and new or adaptations of those ones are going to be interconnected so that we can enhance this flexibility valorization and really alleviate our grids. And for that, for demonstrating that, we have different pilots. And last slide, please. Different pilot sites where we will demonstrate, as I said, on a real scale, this EV integration and flexibility provision, in some of them with smart charge policies, in some of them with vehicle to grid, we will be able to do that. And the idea is also to tackle different users and different EV owners and EV owners and managers, let's say, so to have a picture of how we can later on replicate that and scale that up in all Europe. So I don't know if I have 5 minutes or more, but I hope it is clear and open for any further information or you may need. Thank you.
Thank you very much. Next up is Andrea Gotti. He is a new product developer at e-mobility at Scame. He should be here, if I'm not mistaken. There he is. Very lovely. Please join me here on the stage and have fun with your presentation. I think so. Am I driving the presentation? We might. I'm not sure whether.
Okay.
There you go.
Very good. Thank you very much for the invitation, and thanks to ACEA for extending this invite, even though we were not directly involved in the Platone project. So I will briefly talk about our company, about our involvement in V1G and V2G projects, and then we will give our insights, our comments about challenges and opportunity when it comes to integrating electric vehicle and electric vehicle supply equipments into the smart grid. So, brief history of the company. Scame is a company based in northern Italy. We've been in business for 60 years. Since 1999, we've been involved in electromobility, starting with hardware components, so plugs, sockets, corsets. In 2010, we started with the AC chargers, wall box and pillars. In the last few years, in 2018, we participated in a Muse Grids, which was one of the Horizon 2020 initiatives. So we built a V2G bidirectional charger based on CCS charging method. And in the last couple of years, we have also been cooperating with RSE, Ricerca Sistema Elettrico in Italy, Milan, to leverage V1G schemes regarding electric vehicles. So this is just a quick snapshot. As you can see, Scame designs and manufactures in Europe AC and DC chargers for the domestic all the way up to public installation of high-power DC chargers. So just a few words about Muse Grids. Again, this was a Horizon 2020 project. It was completed December of last year. And as you can see, it was about optimization of energy self-production in local areas and maximization of local energy exploitation. So what Scame did specifically was designing this bidirectional charger that we co-developed together with Iveco, and we were therefore able to showcase and demonstrate bidirectional power transfer. So clearly there were challenges because, for example, at the time when we started the project, we were simply unable to find electric vehicles that feature ISO 15118, which is the protocol intended to support bidirectional power transfer. Then, again, only prototypes were available that provided this kind of functionality, and we ended up building one ourselves. And finally, Dash 20 of ISO 15118, which explicitly deals with bidirectional power transfer, hadn't even been published yet at the time. So what we ended up doing was designing this device and, let's say, starting from the most recent norm, which was Dash 2, we applied some sign convention in order to take into account the bidirectional power flow. So in other words, a charging profile with a positive reference meant charge power of 10, 20, 50 kilowatts, whatever. -5, -10 meant discharging power at that power rate. We also participated in this CIR, Controllore Infrastruttura di Ricarica, which is an Italian initiative, and it's intended to enable private chargers. Just imagine your wall box in your garage to become aggregated by a remote operator. So this has now been specified in CEI 021, which is the Italian electrical grid code for low voltage, and we also participated in the PAS, publicly available specification. So for example, one of the takeaways from this experiment for us was the launch on the market. We were the first in Italy, and I would say at this point in the world, to integrate the chain to communication, which is a power line communication that allows us to provide power management schemes by talking directly to the smart energy meter. So essentially, what are the challenges and what are the opportunities? So as you can see, there is a rather incoherent landscape of grid codes, communication schemes, local initiatives, different power meters, and clearly for companies like ours, we can definitely develop applications for the Italian market. That's where we are the strongest, but clearly becomes very difficult to provide integrations to every single French meter, Belgian meter, Italian meter, and so forth. Another challenge that we see regarding specifically V2G, again, bidirectional power transfer, is about different grid codes across Europe, particularly for one of the use cases that is based on AC charging. So just to keep it very simple, what happens? With AC chargers, the power electronics is on board of the vehicle. Therefore, it needs to meet the local grid codes. Finally, again, we are interested in exploiting demand-side response schemes. For example, the Muse Grid charger that you saw earlier will be shipped shortly to Turin at Terna to be tested as a demand-side response device. So bottom line, we need clarity, we need standardization to make sure there is no uncertainty and there are interoperable solutions across Europe. Thank you.
Thank you, Andrea. Just leave it there, perfect. The next one will be virtual again, is David Martin Utrilla. Can you hear us? Are you there online?
I am here, yes. Can you hear me?
Yes, perfect. The floor is yours. Have fun, David.
Thank you. Well, first of all, I wanted to thank you for the opportunity to present the Be Flexible project as a continuation of the Platone project. I can hear echo, so maybe, well. Well, Plato had also disciples. They also follow the path, and we can become the Aristotle of this Platone. Well, I don't have time for details. Can next slide, please? Next. Very, very brief, almost one slide. From my side, we are a consortium of 21 partners and some affiliated entities. Almost half of the Platone's partners are with us, RC Engineering, Areti, EDS owner, WTH. We have a budget of over 10 million on the 4-year project ongoing, which started on September 2022. We have a very varied consortium, not only in terms of nationalities, but also in terms of specialities. We have tremendous human and professional value, and have no doubt that this will give excellent results. Next, please. Our ambition next, very summarized. This is the one slide. We cover 4 large blocks, 4 key areas. The first, all the activities related to customer engagement and the value proposition. We are revising the value proposition from other projects, doing some interviews with the stakeholders, coming up with a value map for the whole value chain. Also reviewing successful engagement strategies implemented in previous projects, identifying social barriers and drivers for the different profiles, and also develop an engagement roadmap to test it. Regarding to the services ecosystem, different types of services were defined, some customer-centric and other grid operator-centric. I would say this is a significant gap we want to fill. Grid operator-centric are relevant, also well addressed in previous projects, but customer-centric could be decisive to boost flexibility. Energy efficiency and other customer-focused services already exist, and with a little adaptation to the flexibility needs of the DSOs, they can make a big difference. We have up to 32 different value propositions, and both customer-centric and grid operator-centric. We are going to test them in the pilots. This is why some businesses different from DSOs participate in the next block. Will focus on platforms. There's the so-called Grid Data and Business Network Platform, the GDBN, already addressed in previous projects. This is a platform in which not only DSO, but all the stakeholders can exchange data, prosumers, energy communities, aggregators, and which aims to facilitate the activation of flexibility services stakeholders. Also ADMS and DERMS platforms in which we aim to ensure interoperability. And finally, markets and regulation. We are going to start talking about acquisition mechanism, not only market mechanisms, but also other mechanisms that may be more efficient in certain situations, especially in lower voltage levels for DSOs. In terms of regulation, some critical issues are being addressed, such as DSOs remuneration, baseline management, or submetering. There are pilots in 4 different countries with different approaches, from pilots for addressing TSO-DSO coordination as in Italy, to pilots focused exclusively on prosumer environment and aggregation, where we don't even have it, so as in the case in France. This is the summary of our objectives. Next, please. Our objectives, now fully aligned with what we have just told about in the key areas: customer engagement, platforms, services, and regulation. We can go to the next. It is too much text. This is the work packages organization. I want to explain it with detail because we have almost one work package for each key area, and giving the required relevance to each block in the demonstration packages. As a demonstration project, we have the heart in the proposal of the demonstrations. Next, please. One phrase to reflect the soul of the project, that customers and their needs are the key. And well, that's all from my side. Congratulations for the Platone project, and don't stop research.
Thank you, David. So last but not least, Antonello, I think no need for introduction. We are slightly late on time, but you have been very efficient today. I have high hopes.
Kill the electronics to complete. So very quickly, a few points to conclude about the future and in terms of other activity. You heard a lot about it. The LFE project, Sonio, is growing. And so we are sure the results of this project will go on for a long time. The community is getting bigger, and that's really a great satisfaction to see that that original idea is becoming something really concrete. We heard about initiative in Italy connected to Platone, and they've been remarkable. I mean, want to thank Areti in particular for what they have done. But we are trying to do the same in Germany, so Germany is trying to copy Italy this time. We are building discussion, cooperation within some of the large research centers in Germany, particularly Fraunhofer and Office, to follow the same path. Because in my mind, particularly in Germany, we had a big problem of the small DSOs, which are a large number and with limited IT experience, and we need to help them very closely. And that's what we want to do there. And starting point will be the Platone framework. That's been already agreed between Fraunhofer and Office. You heard about the use case repository. It was an open source development of our project. It's now an official tool of the European Commission. It's going to be ported, is currently with the help of ETRA, ported on the ERI platform of the European Commission. Is going to be one of the results that will help all the future European Commission projects, and that's a great success of our group. You heard already about be flexible, I should have written, and flow. The other point is, we discussed this morning the link between open approach and interoperability, and as you were already mentioning, the internet is the way we are doing this. It's a coordination support action that I'm leading as Fraunhofer, not as RWTH, where we are really setting the conditions and the framework to have interoperability, and not just for 3 years, but building interoperability community, going back to what Ludwig was saying. And we are working on other proposals. I put a logo there. It's the big hope I have right now. Many of the partners have been around here, but in Platone, Twin EU, it would be the perfect continuation of Platone. It's a huge consortium that replied to the call of digital twin, is under review. I hope any day soon to get a positive answer from the Commission. That will allow a lot of the community of Platone to come back together and to merge with the OneNet community, because some of the partners also, like Elena, for example, from OneNet, will be involved if we are successful. And that will be the perfect continuation of Platone. Will come at the perfect time at the end, and looking at digital twin for Europe, which is a big challenge in terms of the digitalization of the energy system. That's it from my side.
Thank you, Antonello. Our last speaker for today, Roberto Zangrande. May I ask you kindly to come one more time to the stage, and he'll be giving us the closing remarks. The stage is yours. Microphone is there.
Is there a color in particular? Any? Okay, so I won't steal any more of your time. There has been a couple of intense days for every one of you. The public has slimmed down to a selected number, as we say, but I think that it has been extremely interesting. I won't bother you on recapping what is Platone, because you know that. But I would like to bank on the last considerations that Antonello made. So the step forward as far as this this project is concerned. And I made a couple of notes today while I was here. I started being interested in the European projects involving the distribution system operators and the distribution world several years ago with a project that was called Evolve DSO, that probably Antonello remembers, but we share the same color of hair. And so this is highly justified. And if I look back to Evolve DSO, well, that was Jurassic. We were talking about the evolution of the roles of the DSOs independently from the evolution of high evolution of technology. We couldn't even imagine that the evolution of the technology would have affected in such a profound way the business and the evolution itself of the business model of the DSO. And in those days, I happened to be closing the final also event of Evolve DSO, and I remember distinctively that I was impressed by the huge work that was done by that project and the members of that project. You can trace it on the web if you are interested, but is wasted time at this point. Well, the difference in these years is so big that I came to a couple of notation. First of all, there is, in my opinion, after such an event that was exclusively devoted to those who had to put their fingers in this project, we should imagine to give a feedback to the Commission, an articulated feedback to the Commission, and organize a workshop and have the counterparts of the Commission, 5, 6, 7, not more than 10 people around the table listening to the results that have been achieved. And I'm staring at Selene. She does avoid my my eyes, but please make a note of that. We must really talk about this, because all these achievements must be given the opportunity to be recorded by the Commission, especially in this period when the preparation of the programs of the next Commission is there. There will be evolution within DG Energy, there will be evolution within DG Research, and it is good if fresh messages from this side of the technology go to the Commission. And the second point that I would like to note about this is that maybe today we did not talk too much about the relations, about the findings and the evolutions that this project is triggering with the evolution of the related talents. And do not forget that we are approaching the year of skills, and that there will be a lot of possibilities to pair the skills that are needed for the future also related to a project like Platone. And as far as the skills and the talents are concerned, there is a strong invite from my side, which is to the ability, if possible, to consider the chain of talents which is needed to implement the results of Platone and to guarantee the evolution of the findings of Platone. And this is another invitation. Maybe in a provocative way, we shall try at EDSO Secretariat to be, as said, provocative and propose you after the summer something to reason around, and maybe together with a feedback to the Commission, we can start talking about the profiles, the professional profiles, and the technical profiles that are essential for the success of a project like this. For the rest, while thanking Selene for the points that she prepared for me for these closing remarks, it's all what you already know. I wouldn't repeat it. I respect very much the quality and the quantity of the job that has been performed in this project. And I do thank you very much on behalf of the European Distribution System Operators Association for the progress that you have granted, not to a tiny part, but to a relevant part of the system. Last recommendation, let's not keep these results within a group like this. Sell the results within your own companies. Be proud of the fact that you have achieved something like this, and let's spread the message also within the institution, because this must be acknowledged, this must be recognized. Thank you very much.
Thank you very much. So what is left to do, I guess, to conclude this event? I have written down 2 or 3 sentences. I hope it's going to be something that you would like to hear. Anyways, it was a very big pleasure having you all here. And when I look back now at today, it was a long day, obviously, but it fills my heart with joy and hope that there's a lot of great work done and will continue to be done with what we have learned, and will be also carried, as we heard, into other networks, into other projects. So this is very great. So from my side, keep shining bright, stay flexible, as we learned, and let's continue to power the world with our good ideas and our motivation. And let's agree to one thing. Don't say goodbye, say see you later. With that, thank you very much. One thing, if I may, there's going to be some snacks in the back, don't forget, and I also heard there are going to be little presents for some of the people and drinks, so don't run away immediately. And also thank you for the virtual participant for being patient with us and this program. See you. Okay. Wieder ein Tag weniger.
Well done.
Ja.